Good morning, everyone. Welcome to day 4 of the one-week faculty development program on AI for Future. Let me quickly take you through the day 4 schedule. The first lecture, that is lecture 8, will be on future of AI and industry collaboration by Dr. S. Sai Satyanarayan Reddy sir. Furtherly, lecture 9 will be on attention and transformer models by Dr. Joshna Devi Bodapati ma'am. Then there will be continuously 2 lab sessions. The first lab session will be held on the topic using GANs for image generation, a hands-on approach by Dr. K. Devi Priya ma'am. And the last lab session will be deploying AI models by Dr. Joshna Devi Bodapati ma'am. Firstly, I would like to welcome the resource person for the first session, that is Dr. S. Sai Satyanarayan Reddy sir, into the meeting. And let us go forward with his profile reading.
Good morning, all. Can you hear me?
Yes, sir. We can hear you. Dr. S. Sai Satyanarayan Reddy is the principal and professor of computer science and engineering, bringing with him an impressive 30 years of teaching experience, including 10 years as a principal. He has done his Bachelor of Engineering in RIT, Master of Engineering in Pitts Pilani, PhD in Data Mining, and postdoctoral fellowship at California Public University. His career highlights involve joining KG Reddy College of Engineering in 2023 and previously served as principal at Vardhaman College of Engineering, Shamshabad, principal at Shreyas College of Engineering, Nagol, and has organized 20 plus FDPs, 4 international conferences. He visited more than 16 countries for presentations, participation in conferences like USA, Canada, Israel, Korea, China, Italy, Ireland, Spain, Australia, etc. His professional achievements involve ratified professor in computer science engineering by JNTUH Hyderabad, active member of prestigious organizations such as senior member of IEEE, fellow of IETE and the Institute of Engineers, life member of CSI and ISTE. He has published over 80 research papers in highly reputed journals like Scopus and has successfully guided 4 PhD scholars with 2 more scholars currently pursuing their research under his supervision. So with this remarkable background, now I hand over the session to you.
Yeah, just a minute. Can you see my screen?
Yes, sir.
Yeah, thank you very much for introducing me, and good morning to all the participants for the, I think this is the last but one day workshop, and excellent teaching and learning is happening in the AI. So today, coming to my session, I am just dealing with the future of AI and industry collaboration. So this is a completely theoretical exposure. Just I'll tell you about some of the topics which are related to AI and which are related to future AI, and also the faculty involvement and industry collaboration. So I'm trying to bridge these things, especially used for the faculty members. And thank you for giving this opportunity by IIT Roorkee. And I just start with my presentation. This is the today's session topics, artificial intelligence. I just give you a briefing about artificial intelligence. Of course, in the last 4 5 days, you are exposed to this, but I'll give you in 1 or 2, 5 minutes about this, and later I'll shift to future AI and importance of AI transforming industry and education, and current AI trends and industry use cases for AI, and academy industry collaboration, which is very very important. And also a role of faculty, and conclusion, way forward, then conclusion. So these are the some of the session topics today I'm going to cover. And starting with the artificial intelligence, of course, artificial intelligence refers a collection of advanced technologies. So everybody's, it's a buzzword today. Everybody is talking about artificial intelligence, deep learning, neural networks, and so many other buzzwords. And the artificial intelligence mainly refers a collection of advanced technologies that empower computers to perform tasks that typically require a human intelligence. So it is clubbing with the human intelligence. And these tasks includes interpreting visual inputs, like how images and videos, and comprehending and translating spoken and written languages. So and analyzing the large data sets. So that is very very important, and providing an actionable recommendations and much more. Essentially, AI enables machines to mimic cognitive process such as
जी भी
learning,
चलता रहेगा, छोड़ो,
reasoning,
कौन अपना वो लगाया आज।
and problem solving. So making them capable of handling complex and dynamic real world scenarios. That is how artificial intelligence, actually understand. And coming to the purpose of this artificial intelligence is a
Control and public
transformative
control
field.
and control the work and
Hello. Okay. So, hello. Can you hear me? Hello.
Yes, sir, we can hear you.
Yeah, yeah. So this the purpose of artificial intelligence is a transformative field of technology that enables machine to mimic, as I told you, human cognitive process. So learning, reasoning, and decision making, and it's a core. And AI allows systems to learn from past experiences. That is very very important. And all the data which is stored and data sets are created, and based on the past experience, this adapt to new information inputs. That's the purpose of AI, and it will perform the tasks that typically require human intelligence. That's how the purpose. And for example, AI-powered systems like chess playing. If you take chess playing programs, it will demonstrate strategic thinking by analyzing thousands of possible moves and outcomes. So, like, and similarly, if you take the self-driving cars, Tesla, okay, for example, and cars using AI to process real-time data, their environment, such as road conditions, traffic signals, and obstacles, and and movement of other vehicles. All these things it will maintain, and that is to for the safe and efficient driving decisions. That is how actually the underlying technology is there in these applications. Yeah, like in the deep learning, of course, deep learning is a subset of machine learning that uses neural networks to stimulate how human brain pattern recognition in better images, sounds, videos, and other things. And similarly, we are using NLP, natural language processing, that helps machine understand and interpret and respond human languages, enabling capabilities like chatbots, voice assistants, and automated translation. That is what is the purpose of the AI. And coming to the next, we will see the key components of AI. In these key components, I think these words all of you are well familiar with, but I just give you the briefing about this, and later we'll just move to the next slide. This key components of AI is machine learning. Machine learning, as I told you, is an application that AI allows system automatically learn and improve from past experiences without requiring explicit programming. That is how the machine learning works. For example, if you take predicting trends and speech recognition and recommendation systems, so all these things, the examples of the machine learning. And coming to the deep learning, this is a specialized subset of machine learning that mimic the workings of human brain by utilizing artificial neural networks to process vast amounts of data, huge amounts of data. Okay, so recognizing faces, for example, you should have millions of faces, and how cybersecurity people will do all this application. Recognizing faces and voice assistants and autonomous vehicles, all these things comes in this deep learning examples. And go to the moving forward, neural networks. These are computing systems inspired by human brain neural structure. Okay, we have neural structure, neurons. We have billions of neurons are there. And maybe decision support systems and sentiment. All these are the examples of your cognitive computing. Coming to the NLP, of course, so the NLP as enables computer to understand, interpret the generate human language and speech, bridging gap between the humans and machine. That is how the NLP works. And coming to the last one, computer vision is a leveraging deep learning. Computer vision analyzes, interprets visual data such as images, videos, graphical content. Okay. Like autonomous vehicles and medical image analysis, MRI scanning, these images and security surveillance. So all these are all integrated ecosystem of AI concepts, which is revolutionizing industries by enhancing decision making and automating process and improving human computer interaction. So these are all these key components will work like that. Okay. Coming to the next one, types of AI. So in types of AI, we have two types. One is all type based on the capabilities, and AI type based on the functionalities. So coming to the capabilities, we have say narrow AI. For example, AI designed for a specific task. Okay, like we are using Siri, okay Google, so Netflix recommendations. So all these things comes into the narrow AI. Of course, it is operates on the limited scope. It is also called weak AI. Okay, coming to the general AI, or the all that can perform any intellectual task like a human. Okay, so these are the research still. It's still a lot of cognitive skills, capabilities should take into account. So that is about the general AI. And coming to super AI, the hypothetical AI surpassing human intelligence sometimes. Can think, can give reasons, can solve problems, and make independent decisions. So that is also, of course, still going on. That is super AI. And coming to the function based AI. So for example, if you take reactive machines is the basic AI systems that respond to current scenario without storing past experience. That is reactive, this thing. Based on the incident, it will immediately give the reaction. Okay, so action reaction type. And example, IBM Deep Blue. Okay, maybe chess AI, or Google AlphaGo. So all these comes into the reactive machines. And coming to the limited memory machines, all that temporarily stores past data to make decision. So here in the limited memory machines, the temporary data will be stored, and based on the temporary data, the decisions will be made based on the past experience, based on the scenarios happened in the past. So all these things comes into the picture. That is about the limited memory machines. And example, self-driving cars, because when you are using the self-driving, because you are the driver, so based on your type of driving, okay, so it will automatically set, so that gives the past data, and based on that it will navigate the traffic safety. That is how limited memory generally works. And coming to the theory mind AI, theory mind AI
Excuse me,
is
sir.
a concept designed to understand human emotions, beliefs, and social interactions. So that is how the theory of mind AI will work. And currently it's under developing process. It's not yet realized. And coming to the self-aware AI, it's a hypothetical AI, as I told you, that possesses consciousness, emotions, and self-awareness. Okay, so expected
Excuse me,
to
sir.
surpass the human intelligence. Hello,
Sir, sorry to
hello,
interrupt.
yeah.
PPT is not visible, sir.
Oh, just one minute. Just one. Can you see now?
No, sir. No.
Just 1 minute. Now?
Yes, sir.
Okay, okay, okay. So anyway, I'm just talking about types of AI. Now I just completed this one, and moving forward, the future of AI. The future of AI is basically, I'm just giving the description about the future of AI. What areas actually human intelligence and the future of artificial intelligence will be there. So for enhanced human AI collaboration, AI will act as a collaborative tool, okay, assisting humans in complex decision making, creativity, and automation of repetitive tasks. So, example, AI-powered design tool and co-pilot applications in the programming. That's about the enhanced human AI intelligence as a collaboration. And coming to the advances in the autonomous systems, autonomous vehicles, so drones and robots, so which will become more intelligent and efficient, revolutionizing transportation, logistics, and manufacturing industries. And coming to the personal AI solutions, AI will deliver hyper personalized experiences in healthcare, education, entertainment through improved understanding of individual needs and behaviors. There's a personalized AI solutions. So based on these personalized AI solutions, a person which is a hyper personalized experiences about his health, his education, and his own requirements of entertainment, all these things comes into the personalized AI solutions. Coming to the AI in sustainability, AI will play a critical role in tackling climate change by optimizing energy consumption, predicting weather patterns, and managing natural resources efficiently. So, the sustainability, environment, and how you are making this sustainable development goals and all these things, this will work. And coming to the general AI development, this is very, very important. And the journey towards general AI, capable of understanding and performing tasks across domains with human like cognitive abilities, that will accelerate. So it will find out the cognitive skills, the brain, how you are thinking, how you are behaving, how your emotions, and all these things comes in the general AI development. And coming to the integration with the quantum computing, the fusion of AI and quantum computing will unlock unparalleled computational power and enabling breakthrough in the like drug discovery, cryptography, and material science. So a lot of research is happening in these material science, and cryptography is still the research. A lot of things are happening in drug discovery. Okay, so all these things are basically comes in the integration with the quantum computing. And coming to the AI ethics and regulations, of course, as AI evolves, stricter ethical guidelines and regularity frameworks will be essential to address concerns related to data privacy, security, and of course bias. Okay, that bias I'll explain you afterwards. Okay, this is how these ethical regulations are very, very important for the future AI. And AI for social good applications in the fields like education, health, and disaster management will ensure AI benefits society and address global challenges. So this is about the AI for social good. So environment, ethics, and sustainability. So and cognitive thinking. So all these are which are basically future of AI. Some of the components what I just discussed. There are many more. Okay. And coming next, the important topic is the importance of AI transforming industry and education. So our main goal is how, what is the importance of artificial intelligence in transforming industries and education. So how you are meeting the industry requirements, and how the education institutes are taking care about this and what they're helping it. Okay, actually, I just visited Israel. I just give you one small experience in Israel. Israel, they're doing research. Israel is Tel Aviv University. Visited university. Almost 100 students of our doing research in physics. Okay, and they're doing a lot of what you call research. And you believe it or not, the Prime Minister also will visit to the university and take the suggestions from the professors and the research scholars. Okay, that's how the research will be happening. That is how it really you can see the research there. Okay, and what are the latest developments? Also, they'll give demonstration based on that. They will start the research. That's the reason they always top in terms of the research. In terms of that's the reason they have a lot of good nomination. In the cultivation or maybe the research in the health curing. When I talk about health curing, they have different types of research. Okay, on the snails. Okay, they used research on snails, how it will kill the cancer. Okay, so anyway, that is a different topic. Now let us see how the industry are collaborating. I mean, industries and education are expecting what is the importance of AI in the various fields. For example, if you see AI in healthcare, okay, medical, for example, medical diagnostics, AI-powered tools like image systems assist doctors in diagnosing diseases like cancer, heart conditions, and neurological disorders with accuracy. Okay, nowadays, PET CT, we have CT scan, then MRI scan, now PET CT, and now robotic arm. So many developments are happening, and it will give accurate surgery also sometimes. Okay, and this is again based on the type of medical history. Okay, medical diagnostics. And coming to drug discovery, AI accelerate drug development by analyzing huge data sets and predicting the success of new treatments. So that is in the healthcare and also patient care. Okay, chatbots and virtual assistants 24/7. Now you can see transcription, medical transcriptions. Directly you can like Practo and other thing. Directly you can interact with them, and it will give the suggestions also. Okay, chatbots also. Okay, and also predictive healthcare. AI analyzes patient history and like supervisor learning, unsupervised learning, so data mining. So these are the predictive healthcare. Also, we can analyze based on the patient history and environment data to predict potential. So that is how the AI in healthcare. Coming to AI in manufacturing, for example, it's a automation of process. AI powered robotics streamline production lines and improving efficiency and reducing errors. That is how the automation process will be done. And similarly, predictive maintenance. AI system predict machinery breakdowns and preventing downtime and costly repairs. And also quality control. Vision-based AI ensures defects and products and detected in real time. And similarly, supply chain optimization also. AI analyzes demand trends and ensuring seamless inventory management and logistics. That is how the AI in manufacturing will work. And coming to the AI in finance and banking, fraud, that's the main thing is fraud detection, credit risk analysis, and automated customer service, then investment decisions, and then all loans, advances, so all and repayment. So all these things is coming to the bank finance. I mean finance and banking. Okay, so AI systems detect unusual transactions, reducing the risk of financial fraud, and of course AI worthiness, like CBL scores, give borrowing accounts in the bank and based on the history of the data. Okay, and chatbots of course handle the customer queries, and robo advisors also recommended nowadays. In say in China and some other countries, robo advisors are there near banks, and it will give the advisors personalized investment strategies and about the how to take the loans, how to give the advances, and all these things. Okay, and about the interest rates and other things. So all these are basically coming to the included in the AI, finance, and banking. So this is also very, very important: fraud detection, of course, security and other things. And coming to the AI in retail e-commerce, okay, personalized shopping experiences. Okay, you see nowadays. Previously, we used to go and select the our clothes, but now it's already displayed. Okay, if you select a cloth, automatically it will appear on your screen before the mirror. Okay, then you can see whether that is suited, that cloth is suiting, that garment, that attire is suitable to you or not, that color is suitable to you or not. So this is the personal experience in Paris. It is already installed. Okay, and inventory management is predictive analytics helps retailers maintain optimal stock levels, reducing overstock and shortages. So in the stock market, which stocks I have to invest, which stocks I have to drop, which I have to sell, which I have to I buy. So these all analysis we have a different setup of inventory management. And coming to the dynamic pricing, AI adjusts pricing in real time based on demand, competition, and the marketing conditions. And similarly, customer support is virtual assistants, and you have how to handle the queries and making customer service more efficient. It is all these things in the AI retail e-commerce. Coming to the AI transport and logistics, autonomous vehicles is a major industry, big industry in the world. The construction and autonomous are very, very big industries in the world. Okay, everybody will have a vehicle and everybody will have a house. Okay, like this. So self-driving cars and trucks are transforming transportation with AI-based navigation system and route optimizations. Of course, you have Google Maps and other things like this. So AI optimizes delivery routes and saving times and fuel costs and logistics. So this route optimization generally used by your Swiggy and Zomato. All these are the real applications. And predictive traffic management is AI predicts traffic patterns, enabling authorities to manage congestion effectively. Where the traffic is more, I think you can see that. And fleet management is AI powered systems track vehicles, ensuring timely maintenance and efficient operations. That is there in the vehicle. How it will give alarm, alerts like this. And coming to the AI personalized learning. Okay, AI personalizing is adaptive learning platforms, and we have interactive tools and content curation. That is, AI curates personalized study material tailored to the needs and interest of the learner. Okay, what exactly learner wants. Okay, and it will give the personalized study material tailored to their requirement. For example, you have so now your syllabus. Okay, if your syllabus is given, automatically it will frame the question bank. It will give the answers to the questions. So, and it will prepare the material. Okay, and where you can download and you can use based on the syllabus. So that is our content curation. And I have gamification also there. That is, AI integrates game-like elements into the education and making learning more engaging and effective. That is your engineering education, different methods what you are using. Like you are using regular flipped classrooms and think pair, think share. So all these are some of the things what you are using regularly in the teaching learning process. So like this here also, gamification is basically it integrates game-like elements into the education, so making learning more engaging and effective. That also you can use. And interactive tools are AI powered tools like virtual tutors and provide immediate feedback and assistance to the students. So all these things is coming to the AI personalized learning. And coming to the AI educational administration. Administration is student. Okay, of course, in the every engineering college, what we can see, student enrollment management and attendance tracking, resource allocation, and grading automation, and results and processing of their CMMs and PCs and ODs. So all these things are now the lot of engagement that AI is helping institutions to predict enrollment trends also, and optimizing admission process. So next in 2025 admission, what we are supposed to do, and based on the history of the data which is available, and based on that we can check the enrollment and guess what is the enrollment. And of course, AI based nowadays, facial recognition directly when you go to class, it will check the what is the attendance and directly give the attendance, and that will be in the database, and it will immediately post the database to the parents. And seamless attendance tracking system in the classroom is happening. And coming to resource allocation, all predicts demand for resource like faculty, classrooms, and study materials, ensuring efficient utilization of these things. Okay, how that is the and coming to grading, of course, AI automates grading and feedback and the faculty to focus on. So faculty can focus on teaching, posting attendance, taking feedback, all will be taken by the A education administration. And coming to A driven research development, it's we have see here A driven research is like big data analytics, and we are using hypothesis testing, collaborative research, and AI powered simulation. All these are the AI driven research development. Quickly adding to deserve insights and patterns, okay? So that they'll accelerate the scientific discovery by predicting outcomes based on the historical data. Okay, of course, it also connects the researchers across the globe, enabling collaborative problem solving in real time. Okay, collaborative research is very, very important nowadays. We are generally colleges are connecting to the different colleges and doing the collaborative research. Two others from one college, two others from different college, two others from other college. So collaboratively, the research is happening among the community, teaching community. That is how the database and enabling collaborative problem solving in the real time. And also in the AI creates a virtual environment to test theories and conduct experiments before real world implementations. Okay, this is how these things are happening. And coming to AI for bridging skill gaps in the education. So here reskilling, upskilling is very, very important. Reskilling, upskilling, EduNet, or you have the LinkedIn, okay, to reskilling of. So all these things basically the skill gaps in students. Employees provides personalized training programs. Okay, so and coming to the career guidance, so AI powered platforms recommend career paths based on individual aptitude and market trends. Okay, and customized course design also will happen, which will help the educators to design courses that match to the industry requirements. So generally in the board of studies and in the academic council meeting, the industry people will give some inputs. So based on the latest inputs, we can include in the curriculum. Okay, that can be designed, the customer design. Okay, so that comes in the AI bridging skill gaps in the education. Okay, and skill gap analysis, of course, in the NBA and other things, gap analysis is very, very important. What is the continuous improvement of the student from first year to final year? So all these things, and how you are bridging gap in the curriculum, how you are meeting the industry requirements. So that is upskilling, and all these things are very, very important. So this is where the data will be helping, okay, and to create a good data set. Okay, and coming to the last point in these future trends of AI in the industry and education. So industry's education is AI powered smart classrooms. I'm just concentrating on the ecosystem or regulations and ethics, all these things I'm just clubbing. So AI powered smart classrooms. Okay, AI powered classrooms. Uh, AI powered classrooms, interactive and automated classrooms with AI based tools for real monitoring and engagement, and cross industry collaboration, industries collaborating with education institutions to develop AI driven solutions, and lifelong learning ecosystem like AI platforms enable continuous education and skill upgrades beyond formal schooling. And also coming to, as I discussed, ethics and regulations, which are very important in integrating the ethical practices and regularity frameworks to address AI-related challenges. So these are the some of the importance of AI transforming industry in education and education. And coming to the current AI trends. So current AI trends, we have, I just narrated only four, but we have many things. But machine learning and deep learning, generative AI, okay, like ChatGPT or DALI, and edge computing and AI, IoT, and ethical AI and responsible development. So current AI trends is, as I told you, machine learning and deep learning. Okay, so that machine learning is the backbone of AI, that, and enabling system to learn from data without explicit programming. It powers recommendations system, fraud detection, and predictive analysis across various industries. That is how the ML works. Okay, we have the three learnings: supervised learning, unsupervised learning, and reinforcement learning. So models trained with labeled data, which is like spam detection and emails, which is their supervised learning, and clustering customer behavior, okay, where models identifying patterns are unable, that is unsupervised learning, And autonomous driving, AI systems learn by trial and error to achieve goals, which is called reinforcement learning. That is your machine learning and deep learning, the other one trend. Coming to the other machine learning, coming to the deep learning. Okay, deep learning, a subset of AML mimics the human brain and using artificial neural networks. The applications include facial recognition, language translation, voice assistant, and also this excels in handling large scales of data, videos, images, audio. All these things comes in the deep learning. Coming to the second point is generative AI. Generative AI refers systems that create content such as text, images, and audios, videos based on the input data. Like you use the chat GPT. Okay, all models like GPT generate human like text. Okay, enabling applicant in content creation, coding, and virtual assistant. Of course, you are effective prompt engineer, then you can get very good output. Otherwise, it will give different output. Okay, this is how you are asking questions is very, very important. Okay, so there is a different subject altogether, prompt engineering. Now, coming to the DALI, DALI generates realistic images and artwork from textual descriptions, revolutionizing design, art, and marketing. There are so many tools are available. Thousands of tools are available nowadays, based on the requirement. And coming to this generative AI, driving innovation in creating creative industry and automating repetitive tasks while enabling personalized experiences. Okay, this is how the things are happening. And for example, writing marketing content, writing marketing content and product description. Okay, that you can get it. Creating custom designs for branding, you can get it. And developing virtual characters and gaming environment also, you can get it. Okay, that is how these generative AI will work. And coming to the third point, edge computing and IoTs, AI processing occurs close to the source data, like IoT devices. Okay, so I would rather than relying on the centralized cloud systems. Okay, enhancing real-time decisions making in applications like autonomous vehicles, smart cities, and wearable healthcare devices. Okay, so these are some of the devices where healthcare devices, and reducing the latency and improves the efficiency by processing data locally. That is how the edge computing will work with the IoT. Okay, so IoT is empowered devices, analyze and act on real-time data. Okay, for example, as I told you, smart home devices like thermostats and security systems using AI to learner preferences, and AI and IoT integration, streamline industry operations, predictive maintenance, and logistics. Okay, and also responsibility. Last one is ethical responsibility. Ethical AI and responsible development is AI becomes more widespread, and ethical considerations and responsible development are critical. For example, as I told you, bias and fairness, ensuring AI systems are unbiased and represent diverse population in the data. Okay, so bias and fairness is a different subject. So how you believe the data, and what data you have to believe, and what data you have to rely on, what data you are trustworthy. Okay, that is very, very important. Okay, so they have different data sets. So how many number of users are using it, how many are not using it, how much data is effectively used. So all this is a different style. So bias and fairness, which will ensure AI systems to unbiased. Maximum it will check the unbiased and represent the data. And privacy and security. So protecting sensitive data used AI models, complying with the regulations of regulations. Okay, and coming to the transparency, AI decision making process must interpretable and explainable. Okay, that should be the transparent. Okay, we should understand what actually how you are processing, how you are interpreting, how you are understanding, how it is explaining. So all these is very, very important. And also coming to the other point is accountability. Okay, organizations must take the responsibility of AI driven outcomes, and particularly in critical areas like healthcare and law enforcement. Okay, then these are the some of the key initiatives. For example, so developing a framework for ethical AI practices and increasing public awareness about AI capabilities and risks. Okay, and collaborating across the industries, governments, and academia to ensure responsible innovation. So that is about the current AI trends. And coming to the industry use cases of AI. So say almost these are the same picture about the healthcare, okay, education, manufacturing, and finance, and retail. So market. So healthcare, you know that all powered tools analyze medical images such as X-rays, CT scans, MRIs to detect diseases with higher accuracy. For instance, AI system identify cancerous cells or diagnose the cardiovascular issues. So all these things in the healthcare. And coming to the drug discovery, all accelerates development new drugs by analyzing vast data sets and molecular structures and predicting drug interactions and identifying potential candidates for clinical trials. Okay, this reduces time and cost of drug development significantly. If any new drug is introduced, that will generally they'll test for the trial. The trial is guinea pigs. Guinea pigs. They'll be trying guinea pigs and its human-like structure, and later it is working fine. That will be the drug is given to the humans. Okay, that is under research. Okay, this is still that will considerably that will reduce the time and that will reduce the power also. I mean, instead of using number of people, if you have the data, you can always use the less time and the more effectiveness. And coming to the personalized medicine also helps the tailored treatment plan of individual patient by analyzing genetic data, lifestyle, and health history. Okay, based on the person lifestyle, their history, their genetical data. So that also can be possible with the personalized medicines. Okay, AI can recommend the specific medications and therapies based on the patient's unique profile. Yeah. And coming to the education, we have adaptive learning and AI powered engagement. So AI based platforms customize learning experiences by adapting to place the understanding level of individual students. They provide personalized lessons and exercises and feedback. And AI powered engagement is virtual tutors and AI chatbots assistant students with the instant answers and their questions to their questions. So improving engagement outside the classroom and engaging them, interacting with them. So and also educators will be helping giving grades and to the assignments and tracking student progress. Okay. Coming to the manufacturing is the predictive maintenance. So manufacturing basically is the predictive maintenance and automation. These are two things here. In the manufacturing, the AI analyze data from sensors installed on machines to predict equipment failures before they occur. So this helps to minimizing the downtime and reducing cost. That is about the predictive maintenance. And coming to the automation is robots powered by AI are employed on production lines to handle repetitive tasks such as assembly, packing, and quality control, so maintenance, and that boosts efficiency and reduce the human errors. Okay, that is how it works. And coming to the finance, which is the two major things in it, fraud detection and algorithmic trading. Fraud detection is AI system monitors and analyze transaction patterns to identify fraudulent activities in real time. Okay, for example is detecting unusual credit card usage or suspicious account behavior. You can real time you can experience if suppose if you do some credit transaction, the major more amount, automatically you will get a call and it will ask whether that is done by you or not. Okay, so that is how the checkings will be happening if it is unusual, otherwise it never happen. Okay, and coming to the algorithmic trading is an algorithms analyze financial market and identify patterns and execute trades with speed and precision. Okay, these systems help in maximizing profits while minimizing the risk. That is how the algorithmic trading will work. And coming to the last one, retail is personalized marketing. So all tracks customer behavior preferences and purchase history to offer tailored product recommendations and personalized promotions. Okay, example, e-commerce platform suggesting product based on browsing habits. Similarly, inventory management will optimize the inventory levels of forecasting demand and preventing overstock or stock outs, and also improving the supply chain efficiency. Okay, which ensures the customer always find what they need and enhancing the satisfaction. So that is more important. Okay. And coming to the next one is academy industry collaboration. So there are three things: existing partnership on and their impact. So collaborative research and development, R&D. Okay, that is the one of the most important concept in the academy. So collaborative research and development of R&D. So many universities partner with industries to conduct cutting-edge research, leveraging academic expertise and industry resources. For example, tech companies are working with universities to develop AI algorithms or 5G technologies. I hope IITs also, a partnership with very good companies, and collaborative research is happening already in the top institutes like IITs. Okay, and similarly, skill development programs. Okay, industry partners often provide tailored training programs to ensure students acquire skills market demands. Okay, the technology day by day technology that is become obsolete by tomorrow. That is how rapid the industry very okay. For example, in the skill development program, internship life that critical and application. So students may be learning sometimes in the here sending students to the and they'll be things happening in the and bridging gap, and also the live projects they'll experience so that they can get good jobs in the in future. That is how it happens. And also knowledge transfer. So academia provides a wealth of research and theoretical knowledge, while industries contribute real-world challenges and technological tools, creating a two-way flow of innovation. That is how it happens. Okay, and also of course funding for innovation. Industries, when you are partnership with industries, you can always expect industries, because if they get good, if you develop good product, okay, that product can be marketed. I mean, commercialized. Once it's commercialized, they'll get money. So that partnership, industry often fund academic research to solve good niche problems and explore futuristic technologies, and boosting innovation and institutional reputation. That is how the funding of innovation. So all these things are existing partnership and their impact of AI. And there are challenges. So research gaps means limited financial resources or infrastructure in academic institutions can hinder the success of collaborative projects, and many institutions lack of access to advanced tools and technologies required for high impact research. That is how the research gap there. And of course, misaligned goals, and academy may focus on theoretical research while industries prioritize short-term marketable solutions, creating a conflict on priorities. In the typical curriculum, once we design the curriculum, almost if you take BTech, almost 40 courses are approximately roughly 40 courses, and most of the courses are 50-60% are theoretical courses. So this is mandatory, because as per the guidelines we have to manage this percentage of humanities, this percentage of electives, this percentage of management courses, science. So all these things. So to match all these requirements, you may be that industry requirements may be missing sometimes. So that is one of the challenge for all the technical colleges. Of course, AITs, they have their own curriculum, because that is the MHRD, so they have freedom. But in other institutions like us, where it's affiliated to university, so we are bound to follow certain guidelines. So that will basically one of the challenge in the technology adaptation. And also slow pace technology adaptation, that is one of the gap. And communication gap is lack of communication and mutual understanding between the academy and industry professionals, so often limits to efficiency of collaboration. What happens is, in the industry is growing rapidly, curriculum is moving very slow. That is one of the gap. So to bridge the gap, we need to invite industries now and then regularly, and interact with them and update the curriculum and courses as per their needs. I think that maybe that you can fill up at least some gaps. Okay, and scalability issues is even successful collaborations may struggle to scale due to difference an organizational process and expectations, as I told you. So they have limited, what you call motivations. There are lot of differences and expectations. So that is also one of the major challenges. Coming to the academy industry, this already there, I think. Okay. So coming to the other one, driving academy industry collaborations. So what happens is in the okay. So benefits of academy industry collaboration is driving innovation through required skill. Do academic expertise industry needs. AI-driven health partnerships between medical technology companies. Okay. The technology transfer will happen. Renewable energy collaboration, energy farms. So this is one of the major, contribution from the academy. Expo industries allow students to work live projects and gaining practical experience and exposure to the real world challenges. Internships, technical at the tech companies for AI and software development. And skill development programs also will be there. Courses in cloud computing and data analytics designed by collaboration with IT companies. Okay. Now, for example, in our college we have SAP. Okay, we have in Intel. So these are the these are industries which they set up their labs here. Okay, SAP they set up the lab here with their own cost with the 30 systems, and they are training our students in the SAP technologies with a free of cost. Okay, so industry is also investing, and students also learning, so that they can save a lot of time in giving training when they hire. Okay, so that is how these this is working out. Okay, and also the faster implementation of emerging technologies. Okay, so fast implementation technologies. Your industry is academic research into market ready products by providing resource for rapid prototyping testing. Okay, and for example, AI powered predictive maintenance systems implemented in manufacturing units, and scaling AI solutions are industry partnerships enable deployment of academic AI solutions in larger scale and benefiting both organizations and society. For example, used for traffic optimization in smart cities. Okay, and also access to real world data. Industries provide data sets. Okay, that's the advantage, and based on that, and case studies that allow academics to train and refine AI systems. Okay, so we take the data from the industry, data sets and case studies, and based on that, the AI systems can be trained and improving their efficiency. Okay, that is one of the advantage. And coming to the last one, access to funding and resources of academy. Okay, for example, industries often fund research labs and innovation hubs with the academic institutions, ensuring access to advanced infrastructure. Okay, tech companies sponsoring AI research centers in the universities, as I told you, like SAP, and equipment and tools. Collaborative projects give academia research to cutting-edge technologies and software and hardware that would otherwise be inaccessible. It's very difficult for a regular college to invest all these things. So high-end systems, high-end configuration system can be given by the industry, so that our students can be learning and doing some projects. Be helpful. And also financial support for students, scholarships, grants, and assistantships. Okay, funded by industry benefit students, enabling them focus on the access offers with the top universities. Okay, some of the universities having Google AI research labs. So collaborative R&D centers bring together academia and industry to work on real world challenges and fostering innovation in emerging areas like AI, renewable energy and biotechnology. Okay, and similarly, innovation hubs. Okay, setting up innovation hubs with academia institutions allows industries to leverage faculty expertise and access to advanced research infrastructure. Okay, like giant innovation hubs for developing the smart city solutions. Similarly, open source collaboration, which will encourage and develop the open source tools and technologies, enabling shared progress and democratizing the access to innovation. So that is how the collaborative and R&D centers and innovation hubs will work. And coming to the second point, A focus programs. Okay, so certification. All the colleges now, institutions are certification programs are mandatory because the industry requires some certification program. Colleges create AI-focused certifications courses for the students and professionals addressing the industry-specific skills. Example: AI and machine learning certifications, co-designed by universities and tech companies like Microsoft and IBM. So these are the some of these certifications where when they're hiring, they'll see the certifications and based on the skills they'll hire the students. And also workshops and boot camps. So conducting hands-on workshops and boot camps to familiarize participants with cutting-edge AI tools and techniques, and also customized training modules. Industry partners can training modules aligned with technological and the market needs, which is AI focused development certification program. Engaging student projects and internships. Okay, live industry projects. Students can work on live projects provided by industry partners, gaining valuable real-world exposure. For example, analytics model for e-commerce platform, and and internship programs, paid internships for the students. Okay, maybe to contribute the industry specific challenges. Like example, take AI internships like Tesla and Nevada. Now they are giving the and giving the and solving real time AI so hackathons jointly organized by hackathons and that. So solve specific problem facing their uh, climate, renewable energy, bio, AI models for predicting natural disaster. Artificial intelligence partner uh, academy, but still, uh, issues are the use and English. A partnership. Leading continuous learning is professionals in both sectors may resist updating their skills, resulting in workforce that struggles to keep pace in the rapid technology advancement. Because updating is very, very important. When we, in 1992 in BITS, we developed a system, in the COBOL, okay, and we studied, Unibase, we studied, Fortran. Okay, so those are gone in 1990 to almost 32 years back. Okay, so we need to update ourselves, because there are a lot of changes are happening, but most of the people are reluctant to update their skills because it's a continuous learning is also difficult based on the, their preoccupied family setup and maybe the problems or various things. But still, we advise the other professionals in the both sectors, please update yourself. Then only we can live in the industry, okay, in the academy also. Okay, and also next, brain drain in academies. Talented researchers and educators often transition to lucrative industry roles. Okay, like job roles and salaries. Okay, that's a major concern. Okay, you get more salary in industries and they'll go to the industry, and academic research is not happening. That is actually, I did one on DST project on the how to retain doctorates in the academics. Okay, that's I did one DST project in CMS. Okay, so there I researched, actually I interacted with 200 doctorates across Telangana state, and I interviewed them and get the data surprisingly. Okay, so indeed, 50 to 60% are moved to the industry, and many of them are moved to the other countries for the research. Okay, so hardly very few students, very few professors are staying and doing research, in the academia. So that should be changed actually. So that's again, because personally I cannot, motivate everybody, but it should come with inherent the research skills. Okay, that basically will give the bridge. And coming to the communication gaps, of course, in the academy, differing objects. So academia focuses on long-term research and theoretical achievements, while industries prioritize short-term and market-driven solutions and creating misalignment goals and lack of common language. Academics and industry professors often struggle to communicate effectively due to differences in the terminologies, priorities, and methodologies, and insufficient collaboration process. In the absence of well-defined framework for collaboration can result in delays, miscommunication, and duplication of the efforts, and limited feedback. Maybe the industry seldom provide detailed feedback on academic contributions, so making it difficult for researchers to align their work with the practical requirements. So this is one of the major challenges in the collaboration. Coming to the AI and role of faculty. So this is also important. Faculty as enablers of innovation. Okay, so guiding research and development. So faculty play a pivotal role in driving innovation by mentoring students and leading research initiatives in AI. They bridge a gap between academic theory and practical applications. Okay, like supervising student projects, okay, and evaluating the projects on AI-based healthcare, for example, or smart systems, and creating an ecosystem of creativity. Okay, by fostering a culture of curiosity and critical thinking, faculty encourage students to explore innovative ideas and leverage AI to solve the real-world problems. And also integrating and emerging technologies, like faculty act as
मैम वीडियो
early
कैसे
adopters
लगेगी?
of and promoters of emerging AI tools and technologies with academic, curricula, and research activities. And coming to the importance of interdisciplinary collaboration, it's also important. So, cross-domain research and break silos. Okay, faculty can facilitate collaboration among different departments, ensuring AI applied historically and not confined to a single discipline. Okay, because interdiscipline is nowadays is happening, and expanding research origins. Okay, these collaborative efforts with experts from other fields lead to novel AI solutions. Okay? And coming to the empowering students with AI tools, practical learning opportunities we have to give to the students. Okay, like faculty can design a project-based learning modules that allow students to work with real-world AI tools like TensorFlow or PyTorch or MATLAB, of course, MATLAB. Okay, and assigning students a project to create a chatbot for university services. Okay, that is also one of the practical learning opportunity given to the students. Similarly, access to AI resources. Faculty can connect students with resources like open source datasets and pre-trained AI models and online learning platforms, and equipping them with the skills needed for AI-driven careers. That is also important. And coming to the industry partnerships, faculty acts a liaison between the academia and industry, securing internships and live projects for students, giving them exposure to industry challenges. Okay, so like students working in AI solution for logistics and companies to optimize supply chains. So all these things are some of the roles of AI, and especially roles of faculty members in the AI and connecting to the students. Coming to the last but one slide, conclusion and way forward. Okay, so the summary of AI trends and collaborative benefits. So AI is reshaping industries and education, driving innovation, efficiency, and personalized experiences. And academia industry collaboration accelerates research, fosters innovation, and prepares students with industry ready skills. And role of faculty in shaping the AI landscape is faculty can play a vital role as mentors, innovators, and collaborators. Okay, these are very important. So role as a mentors, innovators, and collaborators. Okay, and empowering students and bringing gap between the academy theories and real-time applications. And call to action, they strengthen academia and industry partnerships. So encourage stronger collaboration to address global challenge and develop cutting edge technologies and foster mutual growth. And invest joint research, skill development programs, and interdisciplinary project to build a future ready workforce and innovative solutions. Okay, we can align by aligning all the academic expertise with industry needs, we can the full potential AI and create a lasting impact on society. So that is very important. And coming to the conclusion, AI transforming industries and education by automating tasks, personalized experiences, and fostering innovation, and its ability to analyze data, predict outcomes, and improve efficiency make it indispensable for future ready world. And also these data, this AI trends and shaping the future technology with practical applications across the industries and new challenges to address. And staying updated on these trends is essential for leveraging AI responsibility and efficiency. And these some of the use cases which will demonstrate how AI revolutionizing industries by enhancing efficiency, accuracy, and customer satisfaction. So each industry leverages AI to solve unique challenges, driving innovation and growth. And academy institutional collaboration is essential for bridging gap in critical research and practical application. Research gap and misaligned goals and strategic partnerships and effective communication can overcome these barriers. And success stories demonstrate the transformative potential of such collaborations in driving innovation and social impact. And coming to the future, collaborations between academia and industry have immense potential to address critical challenges, foster innovation, and ensure inclusive development. By aligning resources, expertise, and goals and partnerships can drive progress in technology, education, and social impact. And by aligning all these expertise, academic expertise with industry needs, we can unlock the full potential of AI and create lasting impact on society. Okay, so this is the conclusion of our topic. And thank you very much. And over to the thank you, thank you. Hello, hello.
Yes, sir.
Yeah,
Thank you so much, sir, for the session. It was really informative and we have learned a lot from the session.
thank you,
Thank you for joining us today, sir. And all the
thank
participants,
you, Ma.
the next session will start at 11:45. So please join accordingly. Thank you so much.
Can I leave now?
Yes, sir. Yes.
Yeah,
Hello, sir. I have a question, sir.
yeah, yeah. Please.
Is sir, role of AI in banking and finance, sir, in fraud detection, sir.
Okay. Yeah. In the fraud detection, of course, the role of AI banking finance is very, very important. For example, in the fraud detection and cybersecurity, like credit card scoring and investment management and customer service, process automation, marketing, recovery. So all these basically, all these are the banking finance, and where the fraud detection and cybersecurity plays a major role. So AI can be used to analyze large volumes of historical financial data, so further to identify patterns and anomalies that may indicate fraud in the bank accounts. And similarly, machine learning algorithms can learn from historical data to detect fraudulent transactions in real time. Okay, as I told you in the credit transactions. Okay,
Okay, sir.
so fraudulent transactions in the real time and reducing the risk of financial losses for the banks and other financial institutions. So these are the some of the role of AI in the banking system. Okay.
Okay.
Sir,
Thank you, sir.
good morning,
Yeah.
sir.
Good morning.
As I have a more generic question, which is actually a concern. I am an assistant professor in Delhi University. And what I
Okay.
find is that AI is obviously very beneficial for us, but it is
Okay.
killing our creativity as well. All the students, when they're submitting the assignment, they're just using AI, and all the assignments are AI generated. So, what's your take on
Right.
that?
Right.
We are finding no way to kind of motivate the students to write it themselves. So, we are facing a big problem. What's your view on that, sir?
Yeah, it is a common problem to all professors, so now we personally faced in the classrooms also. So whenever teacher is talking about some topic, immediately students will Google about it and get the answers, and they'll compare the answers. Okay, and also that's one way is advantage, but as you said, I admit what you are talking. AI maybe may sometimes kills our creativity, and of course it's very difficult to motivate, because whenever nowadays in the teaching learning process, see, previously we used to take in the blackboard, so we using the chalk piece and writing all the algorithms, or interacting with the students. Now everything is online, so you can directly see the output, and people are putting very less effort in learning. Okay, only by they are not doing it all. First of all, they're only seeing and enjoying and writing it, but they are not doing it. Okay, I understand the practical, there are a lot of problems are there, but there is no other go, madam. Problem is we have to go with the technology, because one way we are actually motivating, technology changes, and we are inviting all these, we are welcoming all these things, but we are adapting it. So we have to modify ourselves, and of course we try to motivate students and to do the different things out of box. Okay, not only just taking the help of AI, but how to do the creativity. So, in the, for example, how many students are really writing games? Okay, many people are using games, but playing games, but how many people are writing games in India? Okay, so how many people are, students are doing creative projects in India? So I think we can train them in that aspect and take them to that level. And later on, it's up to them to decide whether they can do, because India is a large population. Okay, of course we have so many universities are there, many students are there. We try our level best to motivate them, and but we should tell them what are the ethical and legal, and and that is very, very important. What is the
Absolutely, sir.
limitations of
Absolutely agree
AI?
with you.
And so so these things are very, very important. We try our level best to motivate them. That's all I can say right now. That's all.
All right, so thank you
Thank you.
so much, sir. Thank you.
Thank you. Thank you.
Sir,
Yeah.
hello.
Yeah. Tell
Sir,
me.
I do have a small question.
Yeah.
How does AI and quantum computing work together? Will there be any breakthroughs if they work together? If yes, what could be those?
Yeah. Quantum computing essentially enhance AI capabilities. I definitely tell you that by solving complex
Mhm.
problems that are currently infeasible for classical computers together. Okay. So, for example, if you take drug discovery, I just give you two or three examples. Drug discovery,
Okay, sir.
quantum-powered AI models simulate molecular interactions to identify new treatments. Okay, so I'll tell you. Previously, suppose if you see, what you call drugs with the proteins. Okay, proteins are maybe D vitamin deficiency of vitamins. Okay, vitamins. So now they are mixing with different vitamins. Okay, that is one discovery. Okay, I just saw morning Magfall one drug actually, which comes with the magnesium and riboflavin, and also the D3. Okay, so all these are the different combination. Okay, so drug discovery basically this quantum powered AI model simulate molecular interactions to identify new treatment. So this treatment will solve the many problems, deficiency of vitamins. Okay, because riboflavin is not mixed with any other thing. Riboflavin is generally with the B12 and the other drugs. In the coming to the cryptography, quantum AI enhances security by developing unbreakable encryption methods. Okay, that is in the cryptography. And coming to the optimization problems, AI combined with quantum algorithms solves logistical challenges such as supply chain optimization and traffic management. And coming to the material science, for example, AI identifies new materials by analyzing atomic structure quickly. The fusion of AI and quantum computing is expected to bring breakthroughs in the healthcare and cybersecurity. So these are some of the examples of the quantum computing with AI.
Okay, sir. Thank you very
Thank
much,
you.
sir.
Thank you. Okay, madam. Any other question? If not, just can we wind up? Hello.
Yes, sir. Just for 2 minutes more, sir. If anybody of them have any
Yeah, yeah.
doubts, they can just ask.
Sure, sure, sure.
Hello.
Yeah.
Good morning, sir.
Good morning.
How does AI address us in decision making, sir? This.
Yeah. Decision making process is okay. Decision making process based on the generally AI always uses the history and data sets. So based on the data sets, for example, say I'm talking about a cancer, for example. Okay, so a person is identified a cancer in the third stage. Okay, then generally what happens is, in general, the data about that patient should be there in the clinic. Okay, so what is his habits? Okay, what is history of the family, or is structure? Okay, weight. Then what are the elements present? So this is based on the data. Generally, the prediction will happen. So generally, what happens? Any time based on the data which is already there. Okay, which is already there. Then based on that we can analyze the process, and based on that we can take a decision. Okay, except like climate also you can see. Okay, so day after tomorrow, what is the climate? This is a decision based on the history which is available, and based on that you can predict, and they take the decision. Be right, because I'm talking about predictive. Otherwise, based on the existing things, okay, you can take.
Thank you, sir.
So how it is, and all these things are already noted down. The data is available already. So based on it, it will automatically control and take the decision. So similar to that. Okay, the it's tailor-made decisions, or it may be predictive decisions. Okay, the enhanced decisions. Okay, augmented creativity. Okay, collaborative. So all these things generally comes into picture in the making decisions. Hello. Hello, madam. Can I leave now?
I guess
Hello.
everything is clear to everyone. So if that's the case, we can end the sessions.
Okay. Thank you all. Thank you, IIT Rookie, for giving this opportunity. Thank you, Mr. Pawan Kumar and Lee, for organizing the workshop. And thank you very much. Wish you all the best. Thank you. Leaving now.
Thank you, sir.
Thank you, sir.
Thank you. Thank you.
Thank you, sir.
Thank you.
Good morning, everyone. Welcome back to the session. Now we are having a session by Dr. Joshna Devi Bodapati ma'am. So Dr. Joshna Devi Bodapati is an associate professor in Department of Advanced Computer Science and Engineering and the head of content training at the School of Computing and Informatics with an MTech and PhD in computer science and engineering and over 16 years of experience across industry, academia, and research. She has published over 60 articles in high impact journals and conferences, earning recognition for her research contributions to the field of artificial intelligence and machine learning. During her tenure as a research associate at IIT Madras from 2013 to 2016, Dr. Joshna focused on integrating semi-supervised learning methodologies and within sequential models and developing deep learning techniques for machine translation and image captioning. Her expertise lies in semi-supervised learning for sequential models, deep learning approaches for computer vision, and attention-based neural network models for enhanced image representation. Ranked among the top 2% of the scientists worldwide, according to Stanford University's latest report released on September 16, 2024. Dr. Joshna's contributions to the field of artificial intelligence have been recognized on a global scale. As the head of content training at the School of Computing and Informatics, Dr. Joshna leads initiatives in organizing workshops, faculty development programs, and comprehensive training sessions on emerging areas of computer science. Having rich expertise in data science, artificial intelligence, and machine learning, she has played a pivotal role in developing the course content for the recently introduced BTech CSE AIML, Data Science, and MSc Data Science programs. Dr. Joshna is a passionate teacher, regularly delivers lectures on advancements in machine learning, deep learning, data science, computer vision, and natural language processing. She has been an invited speaker at renowned institutions like NITT TR Chandigarh, MANUU Central University in Hyderabad, and Tripura Engineering College, Tripura. Dr. Joshna's blend of research, teaching, and industry experience establishes her as a prominent figure in AIML, always open to research collaborations. We welcome you, ma'am. Now I hand over the session to you.
Thank you, Anu, for the introduction. Thank you very much. Confirm, I'm just trying to share my screen. Yeah, a very good morning to all of you. So as part of this AI for Future, the topic for this session is attention mechanism and transformers. And how I designed this session is rather than having as a continuous session. So I have divided that into two parts. So like part one, which focuses on the attention mechanism, like prior to transformers, how the attention. I hope my screen is visible and I'm audible to all of you. Can someone confirm, please?
Yes, ma'am.
Yeah, thank you. So that you will get an idea like what this attention is and how is it useful for applications. And as part of this part one, so I will be discussing about what is what is like attention, then what is the motivation behind it, and types of attention in detail. I'll explain. Then maybe with two case studies, I'll try to discuss about the attention mechanism. And this attention is basically, the foundation for the transformer models. Basically, you must be knowing that the ChatGPT we are using is a kind of transformer model. So if you expand the GPT, it's a generative transformer, a pre-trained transformer, right? That's a GPT. So that T stands for the transformer. So the transformer is basically having the attention mechanism, and that is how it became like, performance is good. So what is this attention? And the type of attention it is using is something called as self-attention mechanism. And of course, later we got like several variants of the transformers, and GPT is one such kind of transformer. And prior to that, like what is that attention mechanism? How was it? Was it not there earlier? And if it was there, how is it? And how is it useful? And with two different case studies, I'll explain that. And in part two, I have planned to, discuss about the details of the transformer and the like architecture of that and various modules of that. So that is how I have planned it. And this is a part 1 lecture. Maybe after 1 hour, I'll give like a brief, 5 to 10 minutes of break. Then we'll continue the second part. I can understand like having continuous 2-hour session. So it may not be able to take it. You may not be able to take it, especially it is online. It's like continuously I'll be, talking. So that is how I have planned. And in between, if you have any doubts, maybe you can interrupt me at any time, or maybe you can postpone the discussions till the end and you can ask me questions after 1 hour or so. Okay, let's see how it goes. And if you feel that I'm fast, then please let me know so that I'll make it a little slow. Yeah. So let's try to understand how the the basic difference between machine learning and the deep learning. I'll not discuss much about it. Just I'll spend 2 minutes just to bring all of you to this kind of the same level. So in case of machine learning, of course machine learning algorithms were doing good. So they were implemented for several tasks, but they could not reach the performance of the real-time application level. So the reason for that was they were hindered by the feature extraction stage. If you look at the pipeline of machine learning algorithms, so first we get the input data, then we extract the features, then we apply the model. Either it could be for classification or clustering or regression or whatever. But like the prediction task is at the end. And prior to doing this prediction, the learning from the model, so we need to pass the features that are extracted. And for this feature extraction, we use the handheld features. So that was a bottleneck in case of the machine learning pipeline. And the problem here is when the features extracted from the input data, if that is bad, then ultimately the performance of the prediction model also would be very bad. So that is a problem. That is where deep learning came into rescue. So where there is no, if you look at this pipeline, it's like you are just passing the input data, maybe an image or whatever, and then the feature extraction and the prediction task is done together itself. So you're not using an additional algorithm, and which requires a much human intervention. So in case of machine learning algorithms, so this phase requires like human intervention, and the features we extract also known as the handmade features or the hand engineered features, because of so much of human intervention, and it requires a lot of expertise, the human expertise in the specific domain. So if it is medical domain, then expertise in the medical field is required. So if without having that kind of knowledge, if you perform this feature extraction, then the performance of the subsequent task would be very bad. So to overcome that, these deep learning algorithms were designed, so which are capable of learning the representations from the data, and learning the representations, along with that, they do the prediction task also. So that is the advantage of deep learning, and that's how it became so popular and widely used, and less human intervention and with less expertise in the domain. Also, people they're able to get reasonably good performance and on par with human performance. So like community could solve several of the problems in the real time. So that's the difference between machine learning and the deep learning. And in case of the deep learning, as all of you are aware, so CNN is kind of a state of the art, and it leads to state of art performance. And I would say in computer vision, this is a game changer. And if you observe the learning, what is the kind of learning that happens in case of the convolutional neural networks? So in case of the convolutional neural networks, the model is designed with convolution blocks, which may contain, each block could contain some convolution operations and the subsampling layers. And of course, you will be stacking up of multiple such convolution blocks. And the role of this convolution blocks is the feature extraction. And at the end, there will be fully connected layers which do the job of the prediction task. So at the end, you can observe these are the fully connected layers, or the dense layers, you can call them. So these layers, the convolution blocks, are basically responsible for extracting features from the images you are passing. So here you are passing an image through the convolution blocks. So you can see initially the first layers, maybe at the beginning layers, initial layers, the model is trying to extract the features such as edges and lines. And when you move forward to the middle layers, then the model is trying to capture so parts like abstract details from the input image, and not like lines or edges. Now the basic features, it tries to extract features like parts of the images. And if you go towards like end of the convolution blocks, that is, which are close to this prediction, the fully connected layers, so they are capable of representing the objects. So here you can see when you pass a person image and this model is trying to, capture lines and edges here and here at the middle layers, it's kind of object parts. Now in case of the facial images, it could be eyes, nose, ears, something like that. And here at the later layers, the final layers of your convolution blocks, so they are representing, like when you pass an image, so it is trying to capture abstract representation from the images. So that is what the convolutional neural networks are learning, and that's how they became so successful, because of the less intervention or the less expertise of the domain is required. So even without domain expertise also, the models are performing very good and they became dominant in the industry, right? Yeah. So then several deep neural networks, the convolutional neural network architectures were implemented. And as you might aware, for the ImageNet dataset, so these are the list of the convolutional neural networks which stood on leaderboard over the years. So in 2012, it was LXNet with 8 layers, and you can see the top 5 error rate. And VGG19 later, then came the GoogleNet with 22 layers. Of course, VGG19, VGG was in 2 versions, 16 and 19, with one with 16 and one with 19 layers. Then GoogleNet with 22 layers, and you can see the error rate is like reducing over the years, right? Yeah. So the mechanism, like the layers that they were including and the deep learning concepts they introduced in each of these models, so aided them to achieve these kind of better performance. And ResNet, so it was introduced with residual connections or the skip connections. Of course, the same kind of VGG model, and then they have included the skip connections so that it could perform better than the earlier models. And so they can, with the skip connections, they could even increase the depth up to 154 layers and all. So like these are the models now with all these kind of techniques. So they could design the models which are having like hundreds and hundreds of layers. And without any problem, these kind of models were able to be trained on the like millions of the data. So that is how they were performing very good on the image data sets. Then GoogleNet version 4 was released later after the ResNet, and then ResNext. So which is kind of, a combination of exception network and the ResNet, and which is having the depth-wise convolution layers, and then squeeze and excitation network. So it is having a sort of attention, basically. They never called it as attention, but later. So when SCNet was introduced, it was never known that it was attention. They were calling it as squeeze and excitation blocks. And later it was like realized as an attention mechanism. So we'll see what that attention kind of mechanism. And if you observe, the CNN architectures were performing for various kind of tasks. Because of their rich representation power, they could reach the state-of-the-art performance on several tasks, like for classification tasks. I would say like computer vision is doing very well, like on the basic, if you don't take any specific data like with occlusions or with noise, unless otherwise, the models are performing decently good for the computer vision tasks, especially for the image classification, then the instance segmentation or semantic segmentation or the object localization, object detection tasks. So they were doing like they were producing state-of-the-art performance. So then what next? So of course, the models reach some point, but beyond that, they're not able to perform. So then the next innovation was the attention mechanism. So what was this attention and why this was introduced? So let me give some intuition about this attention first, then we'll go like the technical details about the attention. So when you consider the attention, so consider this page here. So this page is having some text, right? Yeah, so it's actually a dictionary. If you observe, I am looking for a word focus. So assume that you open your dictionary and open the word focus. Then when you are reading the word focus, so then your focus will be, or your attention will be on the word focus or on those 3 lines or 4 lines or the overall book. How it will be when we are reading a book, when we are reading a particular paragraph, and our focus will be only on those few lines. So though you can observe. So in your view or in your vision, the entire book would come, but your focus will be majorly on those few lines which you are currently reading, right? So that is how, like considering this human attention into view, so the attention mechanism was introduced into the neural networks also. So let's try to understand what this human and attention is. So human attention, of course, allows us to focus on specific parts while ignoring the others. Here I have given an example, right? Yeah, when you are reading a book, so maybe whichever part you are reading, so though the rest of the things are also into your vision, so you don't consider that. So you will be majorly focusing on the few lines which you are reading currently. So that's how our human visual system works. And of course, our human visual system can process very large amounts of data. So you cannot even believe it can process 10 power 8 to 10 power 9 bits per second in parallel. So that's the power of our human visual system and the visual attention mechanism. So how it works is it doesn't look everything with the uniform focus. So you can see now also if you try to understand, so you into your vision almost 270 degrees, whatever is there in the surroundings, if you like uh, up your head and then try to view, then everything around you will come into your vision. But on the specific thing, so say for example, you are looking into your mobile or the laptop to listen to this, like to listen to this lecture, then whatever you are looking at, so those things will be given more focus by our human visual system. And rest of things, so though they are into your vision, but you're not giving equal importance, as much importance as you are giving to this slide section, you're not giving the rest, right? So that is how the human attention works. So considering this in view, yeah, let me give few more examples here. Yeah, like some examples. Say for example, considering this figure on the left, so how many children are there in this image? If we ask this question, so quickly we have a glance on the entire image, but we just like try to focus on the children and we start counting 1, 2, 3, 4, 5, 6, right? Yeah, though we can like look at the entire image while counting also, we can like see roughly like what are the parts of the other parts of the image. But so we get better like we give more focus on to these parts of the children regions. So that is how our human visual system works. And maybe another example you can consider on the right side of the image. So what the teacher is doing. So that's a question. When this question is asked, so the way you look at this image is different, right? Yeah. So your focus will be majorly on the teacher only, not on the rest of the image. But still, your vision is on the entire image, but with little focus. So that is how the human visual system works. So considering that the artificial attention or the neural networks, the attention that can be integrated into the neural networks. Basically, attention is a mechanism which was introduced into the artificial neural networks. So that attention is known as the artificial attention or the neural attention, you can call it as. So what is this neural attention or the artificial attention? Let's try to understand. So attention is one of the most, of course, influential ideas in the deep learning community, especially when you consider the GPTs, no? The post GPT and prior to GPT, you can consider that as like, it's a game changer altogether in the AML era. So now, of course, what is a game changer? What is like a revolution? What made that as a revolutionary change is the attention mechanism. So of course, it's an influential idea, so which was introduced by deep learning community. And of course, you can consider it as a recent trend which can be integrated into the deep neural networks. This attention is a mechanism which can be introduced into your deep neural networks. And it specifies what does it say? What is this attention? It says, so which parts of the input need to be focused, more, and which should be ignored. So that kind of, mechanism is possible with this attention and automatically learns. Are you doing it like when you pass this input image to your model? Are you saying that, so look at this part of this image, are you marking this image and saying, or in this image, are you marking the bounding boxes for the children and you are saying that, so give more focus to these images? No, you don't do that. You will not be doing that. And you are allowing your model itself to selectively focus on the sections or the regions of the input image or the data, which are more important for the task in hand. So that's how the attention mechanism automatically learn to focus selectively on the like particular parts or the regions of the input data. It could be image, it could be text, it could be speech, or it could be video. Anything is fine. But So the mechanism works like this. And with attention, the representation power is also like enhanced. So altogether, when you are doing this convolutional neural network means what? So when you look at the convolution, all these convolution blocks, the responsibility is to extract the features only, right? And so in between the convolution layers, you can have the attention mechanism, you can integrate it. And by that, what happens is, so if you look at this CNN network, so the final layers are responsible for the prediction task, and the earlier layers are responsible for the feature extraction. And if you introduce the attention mechanism in between these layers, so the like the representation power of the model will be much better. So that's how they allow you to enhance the representation power of the mechanism also. And moreover, what we need to understand is this attention mechanism was initially introduced for the neural machine translation. So what this neural machine translation is? So machine translation is a task where one language, a sentence in one language is translated to a sentence in the other language. That's what the machine translation is. And what this neural machine translation is, when you are using a neural network, especially the deep neural networks, for accomplishing this task of machine translation, that is translating one language sentences to other language. And if you accomplish that with the help of a neural network, so it's known as a neural machine translation. And to achieve this neural machine translation, a specific type of models were designed, that is the sequence to sequence models. So if you try to understand like how they evolved, then you can better appreciate how this attention is like working on. So that's how I thought of, sharing these details. Yeah. So of course, how it is introduced, we'll discuss that shortly. And of course, not only for the neural machine translation, it was adapted to like several other tasks. So you can see your ChatGPT using attention, and even there is something like vision transformer. So for computer vision tasks also, not only for the NLP task, it is successfully adapted to the vision field also. So let's see how it evolved and how it was used for the neural machine translation task. And before going ahead, let's see what are the different applications for what you can use, like where you can use this attention mechanism. So basically, it can be used for natural language processing tasks and also for the computer vision task. Just to make it clear, so coming to the natural language processing, you can apply it for the neural machine translation, for speech recognition, for text summarization, for question answering, for auto completion tasks. For any of these tasks, it is possible to apply this attention mechanism. And the computer vision task, if you consider, so you can apply it for image captioning, visual question answering, action recognition from the videos, and the salient object detection in the videos, or it could be in the images also. So these are the different tasks where the attention mechanism like boosted the performance. Of course, all these problems were solved prior to attention also. But by integrating the attention into the models, which were designed for doing these specific tasks, so their performance boosted. So that's how the attention mechanism received so much popularity. So before we proceed further, let's also try to understand like the timeline, how these kind of attention was introduced. So you can see like sequence to sequence models were designed, for the machine translation tasks. It's like autoencoder kind of models were designed for several tasks, like maybe machine translation or maybe for text summarization. It's like sequence to sequence means what? You are passing input as sequence and output is also a sequence. So that's kind of models were known as popularly known as sequence to sequence models. So because they're capable of processing an input sequence and they're capable of producing the output as a sequence. That's how they are sequence to sequence models. And then align and translate. So they have designed a kind of, attention mechanism, and that attention mechanism was actually initially introduced in 2015 for the kind of tasks such as like neural machine translation. And two people, they have, separately introduced different kinds of attention. One is known as popularly, of course, on the name of the author itself, it is known as Bahdano attention and long attention. So these are the two types of attentions that were introduced, and we'll shortly see what these kinds of attentions are. And the visual attention, it is like the attention introduced for the machine translation was, soon extended for the computer vision field also. So in 2015 it happened. Then, so hierarchical attention, a variant of the attention was introduced in 2016 by Ang et al. And this attention is known as hierarchical attention. And then the next, next year, 2017, Vaswani, along with his colleagues, they introduced an attention that is known as a self-attention. And actually, this is a paper on transformers. This is the first paper on transformers, and the mechanism behind, the idea behind the transformers is a self-attention. So that's what the self-attention mechanism is. And then later, like several variants of the transformers, like BERT and other types of transformers. And the timeline I'll continue in the next part of the session, the second part. So I left it like for the transformers. We'll continue that in the second part. So these are the key developments in the area of like attention mechanism in the field of deep learning. Yeah. So because the attention was introduced for sequence to sequence tasks, especially for the neural machine translation. So let's try to understand how this is implemented and how we are like, we got the idea that attention is giving non-uniform focus to different regions. So what do I mean by that? So let's try to understand. So attention in sequence models. So what are these sequence models and how this can be brought? What are these sequence models basically? So sequence models are the models which are capable of, processing the sequence. It could be input could be a sequence, or output could be a sequence, or both could be sequences also. So the models which are designed to process the sequence type of data, or the data which is having ordering information. So such kind of data to process, you can use the sequence models. And how attention can be integrated in these sequential models, we'll shortly discuss that. And just as a recap, so prior to the sequential models, only feed-forward neural networks were designed. What these feed-forward neural networks? Maybe with all kind of, dense layers, or you can even design them with the convolutional neural networks also. Convolutional neural networks are also kind of feed-forward neural networks only. So here you can see I have the input layer, I have the hidden layers, and I have the output layer. And if you observe that every output here is independent of the rest of the inputs, and it is dependent only on the current input if you observe. Say, for example, I'm designing a model, maybe a CNN or any other prediction model for the classification task. Then I'm passing an input image. So here, say, for example, assume I'm passing an apple image. When you pass apple image, then the output would be kind of, so whether it's an apple or a banana. So that's what my classification task is. Then maybe assume that this is the first class, the second class, and apple is a class 1 and banana is class 2. Then we are expecting the model to produce the higher probability for this neuron, right, at the output layer. And of course, it doesn't matter. All these things are not much required. But if you observe, when you pass the image, the output that is produced by this model at the output layer is dependent only on this input image, right? Say, for example, I'm passing another image later as the next image. Then, so the model is producing the output considering the current image as input. It has nothing to do with the previous image you produced, isn't it? So that is how these kind of models, which are like the inputs and outputs are independent of each other, means the current output is dependent only on the current input, not with the previous or the future inputs, right? So that is how they don't have memory. And there are some tasks where this kind of memory is very important. And whenever there is some kind of dependency in the input, where your data is some sequence, then these kind of models are not sufficient. So they cannot, represent the dependencies among the data points. So they fail. So that is how this is the limitation of the feed-forward neural networks. That is how they cannot be applied directly for the sequential models or sequential learning tasks. So say, for example, I'm doing the auto-completion task. What is auto-completion? We are predicting the next word. So when you predict the next word is definitely dependent on all the last couple of words. Maybe if you have like the lengthy like words, like maybe last 100 words or 200 words, it is even more better, right? So that is how, because it is the next word that is going to be predicted is dependent on the context of the past. So that is how to design that kind of tasks is not possible with the help of the feed-forward neural networks. So this is a drawback. That is where the recurrent neural networks were designed. You can see, so this feed-forward neural network is changed to a recurrent structure. A recurrent, you can see, we are collapsing all this into a single box, and we call this as H, and we are calling this input here. So assume this is the input, X is the input, and assume your Y output is like the Y is represented as in the circle. This is producing the output. And this entire process in between is represented by this H. And in addition to that, we are introducing one more, connection, the backward connection. So that is what the recurrent connection we call it as. Now, if you observe, in this case, the current output is dependent on the current input alone, right? In this feed-forward neural network. But in this case of the recurrent neural network, the current output is dependent on current input, and also you can see the recurrent connection, right? So the previous inputs also, or previous outputs also, it is dependent. So that is how we are introducing a recurrent connection to the model, and that kind of model we call it as a. Of course, we are collapsing this into this kind of structure, and then the processing is like these fully connected layers are very well used as part of this hidden state and all. And we are, moreover, we are introducing this recurrent connection. This recurrent connection means from the past events, we are getting some feedback. So this recurrent neural networks, we can consider them as a variant of the feedforward neural networks. And of course, widely used for modeling the sequence data when your current output is dependent on the current input as well as the previous output. So that is how, to model such kind of data, we can use the recurrent neural networks. Yeah, let me show you the unfolded recurrent neural network. So if you consider this as a recurrent neural network, and what is this unfolding of the recurrent neural network is, this is like the recurrent connection, this W, this arrow, it indicates the recurrent connection. And if you unfold that, so you can see here in this case, of I'm showing only one state. But if you unfold every state, we are able to represent. That's it. Other than that, it's all the same. So now you can see xt minus 1 is assume that this is the initial input we are passing, and it is converted to a hidden state, and it is producing the output. Okay. And if you observe, this output is dependent on this input. And of course, initially there is some random input is passed along with the current input. And that is what the output you are getting. And observe, the same is repeated for several states. Now, what about this output? This output is dependent on the current input xt, and along with that, you are getting some connection along, from the past states. Can you see that? So now your st, this st is a state or the hidden state you can consider. And this hidden state is a combination of current input and also the past inputs. The past input data, the gist is passed as input to the hidden state, the current hidden state, and it is processed along considering the current input also, and the current output is produced. And now consider the next state. So what is the output at t plus 1 state? This output is dependent on the current input along with the, the input that you are getting from the past outputs, right? Or past hidden states. Maybe you can consider them as intermediate states. And if you closely observe, at every state, the model is doing the same kind of task, isn't it? So it's taking one input and producing one output, right? And so it is like processing and producing some intermediate output to the next state. So the intermediate state that is produced at every state acts as input to the next state, right? And to make the neural network, like it will be here, the structure is having the fully connected layers, and you are repeating it for several layers, several time steps. So to handle, how to handle this, like training of the model is, so you are sharing the weights across the states. The W is shared, and the V is shared, and the U is shared. So these are the weights. So because of this shared concept, it is possible to increase the, depth of the neural network, and irrespective of the number of states in your model, so the model will work without any issue. It is able to, it is possible to train the neural network with, theoretically, of course, the standard recurrent neural network. So can be extended to any number of states with 100 words or 1,000 words. So to any possible extent, you can extend it to the number of states. So this is about the unfolding of recurrent neural network and the unfolding of the recurrent neural network. So, but the problem here is when you are So now the state-of-the-art model using the recurrent neural network for the neural machine translation. Basically, so the neural machine translation, the backbone is the recurrent neural network, and the recurrent neural network is not used, once. So how is it used? Is used as kind of, encoder and the decoder. So in case of the encoder, you have one recurrent neural network, and the decoder is another recurrent neural network, and these two are connected with some context vector. You can see the intermediate value is a context vector. So how is it working is, say for example, I'm passing the start tag. Then my what is neural machine translation? So you are translating the sentence in one language to the sentence in the other language, right? Here, I love learning. So this is what the sentence in the source language, and you can observe there's a start tag that is attached and end tag that is attached, and this is what these are the set of sequence of words. So I love learning. And then the decoder, if you observe, the output MOL is there. So this is in Spanish language. So this is how the model is translating from English to the other language. And how we are doing the model implementation. So we call these kind of architectures as the encoder decoder models, because if you observe, the encoder is like state by state, it is reading the word, so like one word at a state, and it is capturing the details of all the words, and it is formulating a context vector, and this context vector is passed as an input to another network which is called as a decoder. And of course this decoder can be designed with the recurrent neural network itself, and here it is a recurrent neural network, or here it is another recurrent neural network. And now you can observe this context vector is acting as input to the start state of your decoder network, right? So all the entire gist or the information about your sentence, the source sentence, is wrapped up into one vector, and that vector is known as the context vector. And this context vector is the input to your decoder, and your decoder is taking that as input and producing the output in the other language. And here one more thing is the output produced at one state is dependent on the previous output also. So that is how for this decoder, the decoder part, we are making this as the current output as the, is dependent on the previous state output, right? Yeah, this is how it works. The encoder and the decoder modes. Now moving ahead. So there are some problems with this kind of auto encoder decoder models when you design them with the standard recurrent neural networks. So that is the problem. So what the problem is, let's try to understand. Then we can, how to overcome these limitations, and how attention mechanism is a rescue, comes to the rescue to overcome the limitation. We'll try to understand. And if you observe the entire, the information about the source sentence is captured by the context vector only, right? And this context vector is the input to this layer, this state. And for this state, if you observe this state, it is not directly getting the context vector output, right? Or one of the input is not the context vector. And this state is processing, is getting the context vector, and it is updating it. And then it is having the some flow of the context vector to the next state. And similarly, this state is also getting the flow from the previous states, of course, where the initial state is having the context vector input. And finally, through all these states, the context vector is flowed through every other state in the decoder, right? Of course, it's working fine, good. But the problem here is assume, so with 4 states, okay. So the length of the sentence is very small. I love learning, only 3 words. And in the other language also, in the target language also, only 3 words. So it's not a lengthy sentence or a paragraph. Assume that I'm going to translate paragraphs. Then in that case, how does it happen? So is it possible to use standard recurrent neural networks itself is for this case? So that is what the question here is. So there is a problem with the standard RNN or the LSTM networks when there is a long range dependency problem. Yeah, consider this example before we discuss the other details. So let's consider this example that is given in the last line. Despite originally being from Uttar Pradesh, as he was brought up in Bengal, he is more comfortable in Bengali. Here, if you observe, this Bengali is dependent on what word? as he was brought up in Bengal, is more comfortable in Bengali. So it is dependent on Bengal, right? Yeah. So here it is dependent on all like 1, 2, 3, 4, 5, and 6. So you need to have the context of all these words to get this word Bengali. So that is the problem. Here also it's only 4 to 5 words. And if you consider any sentence which is like tens and like hundreds of words, and one word is dependent on the past 2 sentences, then in that case it is a problem. So that is what the long range dependency I mean. Long range dependency problem I mean. The performance of the encoder decoder network degrades rapidly as the length of the input sentence increases. So that is a problem. And the encoder, if you observe in this architecture, so the context vector is having the wrap of all the information from the source sentence. And this is the only clue that you are passing to your starting of the decoder. So that's how it is working, right? Say, for example, there are some 100 states here. Then, so for the last state, do you get the context vector information, or by the time it reaches, the context vector information will be vanishing? So that is the problem with the standard recurrent neural networks. If you use the standard recurrent neural networks or the LSTM networks for this task of neural machine translation, or of course any other task for similar kind of task. So this is what the long range dependency problem is. Yeah. So let me show you. So how to handle this now? So this is the traditional architecture which we have already seen, and we are going to update. We'll discuss this shortly. Let's consider this, the encoder and the decoder part. And if you observe, one state is connected to the other state, right? And of course, the inputs and all are omitted, like to make this as the picture perfect. Yeah. Assume that there are inputs, there are outputs also. Here, the last hidden state of your input sequence or the encoder is connected to the output sequence. And so through this connection, the context vector we are passing, right? So there is a problem if the dependency is for a long range. So that is a long range dependency problem. And how to address this? What is the problem here? The context vector is passed only to the first state of the decoder. Rather than doing that, why don't we pass like a linear combination of all these hidden states to every state of the decoder? So if you can do that, then the problem will be solved to some extent, right? So here you can observe for S1, in addition to your regular input, we are passing. So like you take like H1, H2, HT, all these hidden state outputs, and you maybe in simple case you can take the average of all these hidden states and can be passed as one of the input to every other state in the decoder. You can see in the original standard architecture, the decoder is actually getting the normal input along with the previous state. But here in this kind of decoder, now the input is a combination of, or a linear combination of all these vectors of the, like the hidden, which are the hidden state outputs of the encoder. So this is what of course, this is what the attention mechanism, the basic terminology. So now you can observe this is the vanilla encoder decoder architecture, and this is the encoder decoder architecture with the attention mechanism. So now you can see, so it's a combination of, here we are passing to S1 or to every state, we are passing a linear combination of outputs of all the hidden states. Can someone mute the person who's talking, unless it is a question? Now let's see. Let's consider this example. Attention mechanism, I have given the idea now, right? So rather than passing the context vector to the first state of the decoder, we'll be passing a linear combination. So in the simple terms, this linear combination could be the average of all these vectors, like hidden state vectors. That's the simplest in terms of very simple terms, the attention mechanism. But that may not be sufficient. We need to have the soft attention. So let me give like justification for why do we need to go for this kind of soft attention? What do I mean by that? And what is hard attention? So let me explain that. Now consider this translation. I love coffee. And this Spanish translation is Me gusta el café. So this is Spanish translation for this word. And for this, if you use the standard auto encoder, like encoder decoder architecture, so the input you're passing, and these are the hidden states, and the last hidden state output is acts as input to the like first state of your decoder, and this is how it can be designed. So, and these kind of models are also known as the many-to-many architectures, because the input is a sequence, which is like multiple inputs it is getting. You can see I is one word and love is another word and coffee is another word. So different words you are passing as input, and the outputs also, right? So the inputs are multiple and the outputs are multiple. That's how they are known as the many-to-many architectures, autoencoder architectures. Now let's see what's the soft attention and why is it important to make you understand. Before that, let's consider this example. And I love coffee is translated to, it should be translated to Me gusta el café, right? And while translating it, so the word me is dependent on, so though there are three words in the input, is the word me dependent on I with highest probability, and the remaining two words are not that important while predicting the word me, right? Or while translating the word to the first word me. You can see I'm showing the distribution of the input words also. So you can observe it's the highest probability and the next probability and the next probability. These are the input words. And while we are predicting the current word in our output, I'm showing for the word me first, and remaining also we'll have a look. And what is the contribution of each words in the input sentence? That's what I'm showing in terms of the probability distribution. So if you consider I is having highest impact on me, and love and coffee have equal importance and very less importance compared to the word I. So this is how you can do. And then gusta. So what is this gusta? Me gusta el café. So L is a pronoun here, and gusta and cafe is actually a coffee, and gusta is my interest. So I'm interested in coffee. That's what the meaning of this in Spanish. Now let's see the word gusta. So the gusta here is dependent on the word loud compared to the other words. Of course, it is dependent on the remaining also. The context is important. May not be for this, but usually context is more important. And so how much contribution is required, or the highest contribution is by which word here for producing this word gusta is the loud, the word loud, right? It's having the highest impact, and the remaining words are having less impact. And similarly, go ahead. L is actually the pronoun, and for producing this pronoun, we need to have like all the three words. So that is how equally important all these are. And of course, coffee is like little dominant because it should be it's equivalent to the in Spanish. So that's how it is. And then it's a article. And then cafe. So cafe is next word, right? Yeah, the next word. So while producing the word cafe, it is dominantly, you can see it's dominantly dependent on the word coffee, right? And rather than the other words. So that is how while producing one word, it is not that you are giving equal importance to all the words in your input sentence or the input data. So it is required that while producing a specific word, your specific words of your input are more important compared to the rest. So with that in mind, the soft attention mechanism was introduced for, of course, the neural machine translation. Now let's consider it's an encoder decoder model only. So the encoder is designed with LSTMs, and decoder is also designed with the LSTMs. And now this input X1 and H1 is a hidden state, and the input word you are passing is how. Of course, directly we cannot pass words. We have to use some feature vector generation, maybe a Word or ChatGPT, any other language model you can use to convert them to the word embeddings. And then you are passing that word embedding in terms of X1 and all. Now, this is the encoder. Just ignore for the time being these arrows, the connections between encoder and decoder. And let's consider. And now, what about the output? So output is here you can see this part we'll discuss later. And this output is producing one word and what that word also. And this another part, another state and another state. So these are the different states. Now, if you observe, actually, in case of the non-attention mechanism, all the outputs or the last output of the last hidden state of the encoder is connected to the first state of your hidden state. And that was the problem with the long that introduces the long range dependency problems, right? So to overcome that, we are passing weighted vectors. Here, this is what the attention here is. The attention here is alpha 1, alpha 1, alpha 1t, so on and so forth. So depending on the number of states, the alpha numbers will be, the number of alphas will be varying. And a combination of all these will be passed as a context vector. And this context vector C1 is passed as input to this S1. And similarly C2. And similarly C3 and so on, the last context vector. So the context vectors are no more the same. It is different depending on the input and the word to which word you are passing, the context vector will be different. And now please look at this here. Yeah. What is context vector? Is the context vector changing for different states? No, right? It's the same. Every state is getting the same context vector, and also the context vector is passed only as input to the first state of the hidden state, the decoder, right? So that is how it is. Now let's see. So now this previous one also we need to understand, right? The attention I have introduced, yes. Here you can observe what is this context vector here. So here there's a problem. The long range dependencies, they may not get the context vector and it get diminished or vanished if you have a long sequence in your decoder. So that is why rather than having the output state is connected to the input state of the decoder part. So what we are doing is we are taking the combination of all these hidden states and we are passing the same to all the states of your decoder, right? In this case, the context vector is the same, is it not? It's a linear combination of all the hidden state outputs only. So that is passed as input to your every decoder you are passing the same, right? Yeah, this is what we call it as a hard attention, and hard attention cannot be part of your neural network. We will shortly see that also. Now, what we are looking at is a soft attention, because certain words need to be given more focus and the remaining need not be given that much emphasis. So that is where the soft attention was introduced. And what is soft attention? For every state in the decoder, the context vector you are designing is different. It is not the same. So it is different for every state in your decoder. So now this context vector is different, and this context vector is different, and this is different. And how is it possible to design such a different context vector for all the different states is because of this soft attention mechanism. Basically, this context vector is a linear combination of all these hidden states. And moreover, you are giving the weightage with these attention scores. So that is what the soft attention is. Maybe mathematically I'll show. Yeah, here we'll discuss that. One more slide. We'll discuss and then we'll see the mathematical notation for that. Try to understand this encoder part, and of course it's a bidirectional encoder which is designed with RNN. It could be a unidirectional also, that doesn't matter. And so now this is what the encoder part is, and this is what the decoder part. And these are the hidden states. Of course, the input will be coming here, and these are the hidden states. Okay. And now, what is this? This is the combination of all these hidden state outputs, right? And this is passed to every state. And in addition to that, you are passing the attention weight also. What is this attention weight? How do we measure this attention weight? So for this attention weight, you need to have all these hidden state weight vectors, and the sum of all the attention weights should be summed up to 1. And these attention weights will be multiplied with the hidden states at each state, all the hidden states. And that is how you are getting the attention-based scores, not the scores, attention-based hidden states you are getting, and that will pass as a, see, every hidden state, they are getting the same kind of attention vectors. The context vector is different, and it is dependent on the current states of your inputs. Now let's see what is the mathematics behind it. How do we design your context vector? The context vector, you can see Hj is the hidden state at the jth state. And we are designing this attention score, right? Yeah, this is what we call it as a mixture weights. And those who work with statistical models, they can understand the terminology. But otherwise, we can simply call it as attention score itself. And here you can observe at every state, the context vector Ci is different. And how is it designed? It is a linear combination of all the Hj's, that is all the hidden states, but the alphas are different. You can observe that, right? Alpha ij. So now these alphas, how do we get these alphas? These alphas can be designed using this expression. So it's a exponentiation of Eij by summation over k equal to 1 to Tx, exponentiation of Eij. Softmax scores only. So once we get the Eij scores, we convert them into the softmax scores. And how do we get these Eij scores? So Eij score is that we are passing to a model which is actually producing these assignments, which is actually taking this assignments, that is a past input and the current hidden state, and we are passing it to the attention layers, and that is what is producing the Eij value. And this Eij value will be passed to this softmax scores, and that will be producing the softmax weights. And those softmax weights are different for every vector you are passing. And that will be used in computing this context vector. And that's how the context vector is different for every state you are using. This here you can see for some neural machine translation task, if you observe, how is it different? Am I audible? Yeah. So now for this translation task, this is a translation from a foreign language to English. Now you can observe what is the attention scores. You can see the heat maps. While producing this European economic, and while producing this, you can observe economic European. These two words are much more important. And by producing the European, and of course, this is important. And by producing the economic, this word is important. And all the rest of words are not that important. And here you can see while producing environments, it requires, it is dependent on three different words. So DL environment, these three words. So for different words, how it is we are showing. So you can see the heat maps here. And while producing it, so it requires a little bit of this and a little bit of the word Q also. So this is how the soft attention can be enforced, or it can be integrated into a neural network model for the neural machine translation task. Now let's see the varieties of, attention mechanisms. There is something like global attention and the local attention. So here I'm saying that these attention scores are computed considering all the hidden states. So if the length of your input or length of the hidden states is small, that is okay. But if it is longer, then is it really required to consider all the hidden states? It's not required, right? Yeah, when you consider all of them, then we call it as a global attention. And when you use only a window of the hidden states for computing the attention vectors, then you can call it, you can consider it as a local attention. So this is what the global attention and the local attention are. So you can see at a particular state, here you can see this is the HT tilde. So this is one state of your decoder. And this is the output. And this is actually dependent on this HT, the current output. Oh, sorry, the previous output. Yeah, this is HT, and you can see the AT. What is AT? AT is basically designed from all these context vectors. And this is the decoder actually, and this is the encoder. And the encoder part, all the states are considered to compute your attention scores. And once you get the attention scores, you are getting them multiplied with these. So So this into the corresponding attention score, this into the corresponding attention score. That's what the CT is. And this CT is used along with this HT to get your current output. So this is what happens in case of the global attention. And now you look at this local attention. In case of the local attention, in the encoder also, you need not to consider all the states. Only these three are fine while producing the current state output. So that is what the local attention is. The global attention, which considers all the hidden state outputs, whereas in local attention, from the encoder, you are considering only a window of states. So that's the difference between global and the local attention. Yeah, here you can observe this is the work by Yoshua Benjuo, which was presented in NIPS 2015. And here for different translation tasks, how your attention mechanism. So with the neural machine translation and without neural machine translation, how it is. And everywhere you can observe that neural machine translation is performing decently good, right? So it's giving here the highest translation score. And here also on English to German, English to French, and English to just language. And on the WMT 15 and 14 datasets, both the datasets, it's giving the highest translation score. So this is about the soft attention mechanism. And I'm showing the blue scores also in terms of the blue scores and in terms of the H-test scores, how it is. So I can observe this is the word error rates. It's not the error rate, right? Yeah, this is the error rate. And here you can observe the blue score is highest for the model, which is using the long attention. So here, this is the attention that is applied for the machine translation task. And this is designed by Luong in 2015. And here you can observe it's 30% blue score. And here you can observe the error rate. So error rate, of course, is diminished, from 21.84 to 16.16. The drop is kind of, 5%. So that's how the model is performing. And now let's see the attention for neural machine translation task I have shown you. That's an NLP case study. And now let's see quickly how it can be applied for the image captioning task, how the attention mechanism can be used for the image captioning task also. So what is this image captioning task for those who are not aware? Just a recap kind of. So when the image is given as input to your model, your model is supposed to generate a sequence of words describing the content in the image, and it should be more semantically meaningful also. Syntactically and semantically meaningful sentence should be generated by the model. And such kind of models, we call it as image captioning models. And the sequence of sentences generated are the captions for the image. And this is what the image caption task is. Yeah. So when we implement this image captioning, basically image captioning task is a kind of, combination. It requires knowledge of both natural language processing and the computer vision expertise, because your input is an image and your output is a sequence of words. Again, it's a sequence only, and you are dealing with text. It's a natural language processing. But what is the kind of input you are passing? The input is an image only. So the image can be passed through any of the pre-trained models like ResNet, Exception, all these kinds of models. You can, you can use any of the models you can use, and you can extract the feature vectors. Maybe when you are using the VGG model as a pre-trained model and pass this input image and get the feature vector from the fully connected layer, say for example 2048, and this is a basic version of the image captioning, not like advanced version without attention. How is it? I'm just showing the architecture to make it simple. So now this the feature vector is passed through a linear layer, and then it is passed through LSTM, and then it is producing some start time. You can observe. Then it is connected to the next state, and of course there is no attention, but still there is a connection from the previous state. So you are passing word embeddings, and then you are getting the output at every stage. So this is a typical, basic image captioning architectures. Now let's see what happens. So the same way, right? So for producing lengthy sentence, the context, what is the context here? The context is this. This is a context vector. The image is passed to CNN, and CNN is producing the feature vector. And the feature vector is passed through the linear layer so that the dimensionality will be reduced. And this is what is passed through the LSTM network, the recurrent neural network. And if the sentence is lengthy, then if you observe the input information, the image information is passed only through the first hidden state, not to the rest of the LSTM states, right? So that is the problem again when the sequence length is large. So to address this, one thing is the hard attention mechanism we are using, and take the combination of combination of all the inputs, and then you pass that H to every LSTM network. So rather than passing the context vector, what you have prepared, of course, without attention only, but just this context vector, rather than passing to this LSTM alone, why don't we give a connection to this, to every LSTM state? So that is what the, change that can be introduced to address the long range dependency problem. But still there are some problems. The performance was not that good. Then they have introduced what you call it as a attention mechanism. Yeah, let me show. Again, I'm showing the basic version only. Here to apply the image caption, like attention in the image captioning. So this kind of basic single feature vector, extracting from final layer may not be sufficient. That is why we are moving backward basically in your pre-trained model and extracting the features. So not one feature, you are extracting multiple features. Here you can observe the image. From the image you are capturing, like you are passing it to CNN model, and you are getting some D features. Then this is a hidden state, the first hidden state. And for this hidden state, the input is your features you are passing from the CNN. And then the first hidden state, you're passing first word, and you are getting the distribution over the vocabulary for this word. So the output. And similarly, you can see the next word, that is how the entire sequence of sentences will be generated. And now, if you do this way, what happens is the features is single vector only, right? That may not be good. That is where we are taking the feature maps rather than the features from dense layers. We are using the features which are from the feature maps, from the last convolution block or so, from any of the pre-trained models, then we have the L by D features. Now, all these features are passed the attention mechanism. So we get the attention vector. See, so this is the first hidden state is passed to that. And then we are passing to the attention module, and the attention scores are computed. And once we get the attention scores, so we use it as a weighted features. So we use the attention features to multiply with the feature maps. And the feature map we are getting are the actual weighted features. So this is how it is possible to implement the attention mechanism in case of the image captioning also. As another example where I'm passing, Z1. What is the Z1? Z1 is actually hello. I lost connection. I hope I rejoin. Hello. Are you able to hear from me?
Yes, ma'am.
Yeah. Thank you. Now this is how you are enforcing the soft attention for the image captioning task. So basically, for the first hidden state, you are passing the features, and then you are computing the attention scores for that. And how we compute that we'll understand shortly. So the attention scores, once we get the attention scores, and these attention scores will be, the in number, they should be equal to the feature maps you are getting here. So here it's like, if you assume there are 9 different feature maps, and we should get that 9 feature scores, and we'll be multiplying the attention scores with the corresponding feature maps. And those feature maps, the attention incorporated feature maps, will be passed as input to the next layer. So this is how those are known as the Z1. The Z1 is actually a linear combination of these attention scores with the feature maps. So this is one input along with the next word. You can see this is the first word. Along with that, the attention aligned feature. I'm showing more details about it. How do we do that? The image and the CNN. And from the convolution block, we capture the feature maps. So maybe in case of the BGG16, it could be something like 7 by 7 by 512. That's the shape of the last convolution layer, right? Yeah. So now we have 512 different features. And let's assume that there are only four feature maps. So they are the A, B, C, D, and the feature maps. And these feature maps will be passed through a layer, and then we get the probabilities like the attention scores. So this PA, PB, PB, PC, PD are the attention scores. Basically, by 4 means there are 4 features. If there are like 512 features, you should get 512 different probabilities. And why I'm saying this is a probability distribution, because it should be summed up to 1, and the value should be between 0 and 1 only. So that is how these are known as the probability scores only. And using these two, what we call it as a context vector, means this A will be multiplied with PA and B is multiplied with PB. So A is not a single letter or single value, right? It's a feature map basically. It's of size 7 by 7 or 11 by 11 or whatever. So that will be multiplied, and that is how you are getting. So now this context vector is basically your Z. So your Z is PA into A. So this is multiplied with this is multiplied with this, so on and so forth. And that's how your attention score, these are the attention scores, and these are the attention infused feature maps, you can see. And in this case, you know, when you would like to apply the back propagation network, if you design your Z and these properties in a hard manner, whether you have 0, 1, something like that, then is it like my connection is lost again? There is a power cut here. I hope I'm audible. I'm still having the connection. Yeah, please let me know if I am not audible. I hope I am still with the connection. I am connected with my mobile. Yeah. So these are the attention infused features I'm getting. So once you get this, if you use the hard attention, say for in that case, derivation of the vector may not be possible, and that is how the hard attention implemented can be used as part of this, you know, the neural network part. So that is where for the soft attention, and we don't use the hard attention. Hard attention cannot be implemented with the neural networks, and the attention that we use is a soft attention only. That is how we apply. And here are some of the, you know, that you can, when the model is applied, like the soft attention is infused in the model, then how the network, you know, focuses on different regions. In case of the soft attention, you can observe here. Yeah, this is what the soft attention is. You can see it is, you know, focusing on the bird and the wings part. And yeah, different feature maps, of course, not one feature map, and different feature maps. And all exactly on the bird and the wings part, right? But wherever hard attention is used, it's not doing properly, because only one specific region it can attend, not multiple regions. But whereas in soft attention, you're giving little focus to the rest of the regions and higher focus to one of the region. So that's how here you can see this feature map. So it's produced, in this case, it is giving emphasis to the wings, and here it's to the, because of this it is visible as a bird. So this is a bird image basically, and this is how it works. And while producing the bird A, the focus is on the wings, and bird, so its focus is on, like, can you see, it's higher emphasis on the region of the center where the bird beak and all is there. So that is how the focus is when you are generating, while generating soft. Maybe some of the examples with the soft attention for image captioning, you can have a look. Yeah, here you can see the man is shooting it. Some examples I'm just showing here. Here you can see a woman is throwing a frisbee in the park. And when you apply the attention-based mechanism, the frisbee, while frisbee, if you, generate the heat map, you can see on the frisbee only, this region, the attention is given. But of course, rest of the regions also there's little focus, but the focus is more on the frisbee. When you are generating the word frisbee, here the attention scores, like the heat maps were generated while generating the words with underlining. Here frisbee for this word, generating this word, the model is giving more emphasis to frisbee. And similarly, dog, you can see this region is given the emphasis. And stop, the word stop sign, right? Yeah. Now this is the region. And similarly, the giraffe, so giraffe region. So this is how, the attention mechanism is helpful for various, tasks like image captioning or neural machine translation and several other tasks. Yeah, the same old thing I'm showing, like how it is the soft attention. And for video analysis tasks, see, when you are passing not the video, video captioning task it is. So you can see not one single frame, it's multiple frames. And these frames, because of these frames, your input is also a sequence. And output is a caption or any summary or something. So now your each frame of the video will be passed to the CNN, and that's how we get these vectors. And your attention score is basically a linear combination of all these frames, where this alpha IT is again the attention score. And how do we compute? We already seen how to compute. So that's handwriting recognition task also you can be using that. Generating the words with handwritten sentences. And this is the first part. And the second part, so I hope, it's better to take 5 to 10 minutes of break so that we will be dwelling into the transformer. And before I start part 2 of this session, if you have any doubts, maybe you can, I'll try to clarify. Hello? So we will continue with transformers with the break of 5 minutes. Now it is 1:05. So 1:10 we'll start the session. So I'll give you the overview of transformers and what are the details, the mechanism that is used in transformer architectures. And Yeah, welcome back. So continue with the session on attention mechanism and transformer models. And we have seen in the first session, part 1, what is attention mechanism and how it evolved, and the attention mechanism prior to the transformer models we have discussed, and how it aids to improve the performance of the models in terms of like context vector design, the context vector, soft context vector, like soft attention, global, local attention, and the 2 case studies such as image captioning and neural machine translation we have seen. And now we'll see more into the attention. Basically, the transformer is the one which is the a kind of game changer in the NLP, right? Yeah. So now what is the foundation for this transformer is the attention mechanism, and especially the kind of attention that is used in transformer is a self-attention. I hope I am audible and you can see my screen. Is it visible? Am I audible? Hello?
Yes, ma'am, you're audible and screen is visible.
Thanks. So now let's go ahead and see what these transformers are and how this self-attention mechanism is useful in transformer and how it can be implemented. What are the applications of transformers and all. So as part of the second part, we'll discuss about introduction to transformers, some very basics, because we already had the discussion on the attention. We don't need to spend much time on that. And what are the core components of transformers, and what is self-attention mechanism, which is part of the transformers, and the multi-head attention. What do we mean by this? Something like multi-head attention. So the same self-attention is replicated several times, and how that can be done in case of the transformer, and the classification of the transformer models. Of course, maybe we may not be able to cover the last 2 in the interest of time, but we'll try to, continue with the remaining topics. Yeah, let me talk about the introduce a very brief about the transformers. Basically, the transformers were developed to solve the machine translation task only. So I have already discussed about machine translation task, right? The attention mechanism we have seen was developed in 2015. In continuation to that, and that after incorporating the attention also, it was a problem with the long range dependencies. And I have shown you what long range dependencies are. And now to overcome that limitation, to some extent, it was addressed by the attention mechanism introduced by Long and Badanu, but it is not completely addressed. So that is where the transformer were introduced, and they could, address to the best of it. And it can do not only the machine translation task, it can do many other tasks also. And just like listing few of the transformers which can do varieties of tasks. But the basic transformer which was introduced by Vaswani et al. So that was for the machine translation task. Then it was adapted to several other tasks also. Say, for example, visual transformer by Josowitsky for the computer vision tasks. Vision transformer, it was introduced for the vision tasks. And then the best performing transformer for classification, image classification task is the COCA transformer. Then is for semantic segmentation in 2023, FD Swin was introduced. Of course, a transformer based architecture suitable for the segmentation task. Then another transformers was introduced in 2023 itself for the object detection task, that is a FD Swin V2G, a Swin transformer architecture basically. And these kind of transformer, they have produced state-of-the-art performance and several applications, not only for the machine translation task, but also for the computer vision task and for the conversational chatbots and for the improving the performance of the search engines and all. So that's the power of the transformers. And if you look at the timeline, I've already left till here, right? Yeah, I have shown till here, BERT, till the introduction of BERT. So it was RNNs and with little bit of attention mechanism, Long and Badanu attention till 2015. And then came the transformer architecture with the self-attention mechanism, and that was introduced in 2017. And then came the BERT, a variation of like, these are the language models basically, Elmo, BERT, GPT. It was introduced in 2018. Then Robota and GPT-2 was introduced in 2019. And GPT-3 another variant of GPT, and the DBATA was introduced in 2020. And the Chat GPT, what we are introducing, was first witnessed in 2022, and the working model basically. And then GPT versions. So GPT 4.0 also is now available in 2024. So this is the timeline you can observe, like the rapid changes you can see in terms of the attention mechanism and the transformers, and how they revolutionized the field of the natural language processing. And they brought the applications, like they could solve several of the real-time applications because of the self-attention mechanism. Yeah. So of course we have already seen, like the neural machine translation task can be implemented in terms of the encoder decoder model, but when you pass it without attention, when you connect the last state of the encoder model to the first state of the decoder model, so if the sequence length is large, then they fail to capture such kind of dependencies, because the context is vanished by the time it reaches longer dependency towards the end of the sequence. That's the problem with the regular encoder decoder models without attention. Then came the attention, right? The soft attention, or the hard attention, or the local global attention that we just have discussed. So I'm not giving the review of it. But the problem is there could be like dependencies, long range dependencies that is possible. Just consider what is attention mechanism. I'm giving a good example here. As aliens entered our planet, and of course there are several words in between. I'm just missing out that, and began to colonize. When this particular word "and" is produced, it is dependent completely on planet. And the word "began," it is dependent on again planet. And "to" is dependent on "began," and the "began" word is again dependent on "entered" also. That's how. Here you can see extraterrestrial. So what is this extraterrestrial? It's related to the aliens. You can see that long range dependencies, right? So to capture this kind of long range dependencies only, we need the attention mechanism. Yeah. So in case of, okay, the context and all, it's done, right? Because the transformers were introduced for capturing this long range dependencies, and which words need to be focused while producing the current word, and the RNNs could not, capture the dependencies when the sentence length is too large. That is one problem. And also RNN's models, they could not be parallelized. They could not be executed in parallel, because they can capture the sequence relationships. So parallelizing is not possible. So that is another hindrance in the training. So faster training could not be possible because they could not be parallelized. Whereas transformers, they are leveraging the soft attention mechanism, and they allow the model to see different parts of the input sequence while producing the current word. And also it's possible to process the execution in parallel, and this leads to the faster training and inference times when compared to the RNNs. That is how the transformers were much more successful. So not only because they are addressing the challenge of the long range dependencies, but also they are addressing the challenge of training problems, training limitations of the RNNs. Yeah, this is about the transformers. Maybe let's start the discussion with the transformers. The transformers are, of course, a type of the neural network architectures only. Maybe you can consider them as a variant of the neural network architectures. You can consider them as an encoder-decoder architecture. You can see this is the encoder part, this is the decoder part, and encoder, of course, is having the connection to the decoder. And not only one such, you can have like several such stacked encoders you can have. And of course, it contains only attention mechanism, and all are fully connected layers. There are no convolution layers, and there are no recurrent connections. So that is how parallel processing was possible, and the advanced training mechanisms could be used. So training was more rapid compared to the RNN networks, where the recurrent connections were there, and the transformer attentions were the backbone. So now they became the backbone for several of the computer vision and the NLP tasks. Not only for the NLP, and they are like producing state-of-the-art performance for the computer vision tasks also. And if you would like to see the advanced, I have already mentioned several of these in the interest of time, like I'm not reading through the slides, just go ahead to the topic. And what does this transformer can do is, in terms of, tasks, it can perform question and answering. It can be used for sentiment analysis. It can be used for information extraction. And of course, it can be used for image captioning. It can be used for object recognition and instruction following, like, what virtual assistant kind of tasks. So it can do several more tasks also. I'm just listing out few of the tasks. And initially it was designed for the basic transformer was designed machine translation and can adapt and was adapted. You can see it, not the original in its original format. It can be adapted to several other tasks also. But if you observe what kind of data can be passed to your transformer, means it could be text, it could be images, it could be speech, it could be structured or unstructured data. Anything is possible. You have to like translate, get the embedding vectors, and then you can pass to your transformer, and you can, apply it for several, use it for several different tasks. So that's what the transformer can do. And what is like, of course, they are capable of doing several different tasks in the real world, and they're producing state-of-the-art performance, which are on par with the humans. Then what made them so successful is the self-attention. So we need to dive into the architecture of the transformers. Basically, if you look at the architecture components, there are four primary components of the transformer: the input embeddings, the positional encoding, and the self-attention mechanism, or you can even call it as a masked attention mechanism, and the layer normalization. You can see these are the four major components of the transformer. And you can see here the encoder part alone. I'm showing you the encoder only because the decoder is just, a variation of this, a little variation of the encoder. And you can see here, this is the input, and this will be tokenized and the embedding vectors. I'll just go into the details. Before we well into the details, let's try to understand the overall architecture, the encoder architecture of your transformer. And after tokenizing and embedding, then we incorporate the positional encoding. So the positional encoding will be added to your embedding vectors. Then the positional encoding integrated embedding vectors will be passed as input to your encoder. Now, this encoder is having different components. You can see here. And there's attention mechanism and the add and layer normalization. So this is a layer normalization. You can see this can be considered as a skip vector kind of. So that is the layer add and layer normalization. Then the linear layer is there and the add and layer normalization. So this is one layer of your encoder, and you can see this N cross indicates you will be having several such kind of layers. This entire block, you will be having several such blocks. It could be like 10 times you can repeat or 16 times you can repeat. You can repeat it for any number of times. This is the basic encoder and encoder architecture of your transformer. Let's go into the details. The first one is the input embedding. How do we design the embedding vectors? First, we need to convert this embeddings means we are converting the input words to the input embeddings. Say, for example, I have text. I'm passing my input as a text. Of course, cleaning, transforming, everything like lemmatization, stemming, all that we do. And finally, we need to do the input embedding. So once we get the input, because at the end of the day, your machine learning algorithms or the deep learning algorithms works only on the numerical data, not on any other data. So that is where you need to convert your text data to the vectors. So now you are converting them to the vectors, right? Yeah. So you can use either TF-ID of vectorization or NGRAM or any other advanced BERT. Other transformers also can be used for vectorization. So once you get the vector representation for every word, you can pass those vectors to your next state. Yeah. See, once you get the vectors, then you have to integrate with the positional encoding. Yeah, this is a real complex thing. Let's try to understand what this positional encoding is and why do we need to do that. Basically, we need to apply the positional encoding because there are no recurrence connections. There are no, which word is which. There is no sequence information, right? That is where here you can see, hi, how are you? You are just passing the input embeddings and you are not saying that is a first word, second word, third word, fourth word. You are not passing that sequence. So that is where to get that kind of information incorporated in or integrated to your embedding vectors, we do the positional encoding. So positional encoding is the thing which incorporates that kind of information about the position of each word or each patch in your input. Say, for example, here, because this is a text, we are saying is the first word, second word. Assume that is an image. So when it is an image, you need to divide it into patches. And patches also you need to have the positional encoding. This is the first patch, second patch, something like that. And for that, we use this kind of embedding. The equations that, the mathematical expressions that we use the sine and cos functions. The sine and the cosine functions we use to convert the embedding vectors to integrate the positional information. So what this positional embedding, how it works is, here in these expressions, the K is basically the position of an object in the input sequence. What is the position? I'll show you with an example. Don't worry, even if you don't understand at this point in time. Let's try to capture whatever you can. The next 2 slides will be clear. And D is the dimension of your output embedding space. So already like we have converted them to the embedding vectors. Now we are going to convert to the position encoded in encoding integrated embedding vectors. So what is the dimension of that vectors? That is what the D is. And N is the user-defined scalar. And as per the paper, where the transformers were introduced, that is the attention is all you need. As per the paper, it is 10,000. Even if you can change that number, that doesn't make any problem. So then what is the value I? So I is the value that you are using to mapping the column indices. So 0 less than 0 less than I less than D by 2. So if D is your dimensions size, then your I varies from 0 to D. D by 2, not D. It's D by 2. Why we are doing that? That also I'll come back. So the sine and cos functions you are applying, and these are the expression for it. Okay, let's go ahead and let's consider this example for the positional encoding embedding matrix. Now this is a sequence. I am a robot. So these are the sequence of words. And if you observe the first 0th word, first word, second word, third word, right? That we can like easily understand. So once we have that, these index of the tokens or the index of the words, we need to formulate this kind of positional encoding matrix. What is positional encoding matrix? So D is, assume that D is your embedding vector size after positional encoding. So now P is 0, 0. So this is like a column and row with row index. So 0, 0. So 1, 0, 2, 0, 3, 0. And this is P0, 1. This is a column, right? The column and the row values. Just formulate this kind of matrix. Assume your D value is something like maybe 64 or 128 or something like that. And how do you get this like 0, 0 value or 1, 0 value or any other value is using this expressions. So K comma 2I, K comma 2I plus 1. That is for one column we use, of course, I value will be repeated. So this is for this column, if you use a sign, and for this column, we'll be using the cos, the same I value. So that is how I said I will be repeated from 0 to D by 2 rather than 0 to D. Because on one column you are applying sine, on one column you are applying cos with the same I value. Now let's go ahead into the example. So these are the mathematical expressions we use. And let's consider I am a robot. And these are the index of the tokens. And these are the like position embedding vector, embedding matrix index values 0, 0. And this is 0, 1, 0, 2. And you can observe here, I'm setting I value is 0 and I value is 0 here also, right? And I assume that just for the sake of simplicity, D is 4 and N is 100. Okay. So now what is P00? How do you compute? Here, 2I, right? 2 into 0 means 0. So now we can use the sign for this computation. Maybe we'll better consider any of these. Yeah, maybe P21. Let's consider this P21 value. How is it computed? So 2 into I plus 1 means 2 into 0 plus 1, right? So 0 plus 1. So when you are using K, it's K is 2, yeah, 2 comma 1. So to compute this, we are using this cos of K by N power 2I by D. What is K here? P value is 2. So 2 by N is 100. We set our value as 100 just for the sake of simplicity. 100 power 2 into I. What is I? I is 0. So 2 into I would be 0. N power 0 would be 1. So K is 2 by 1. and 1 by 4, right? Yeah. So now it will be 2 by 1, and the value, when you pass it to cos, it will be minus 0.42. So this is what you are getting at P21. And this is how we fill the embedding matrix. So once we fill the embedding matrix, we multiply that with the, already we got the embeddings in the previous, yeah, this is the embeddings we got, and those will be multiplied with this position vector, embedding encoded vectors, and that is how we get it. The positional encoding integrated vectors. So once we get that, we go to the next stage. What is the next stage actually? The next stage is a self, we are done with the input embeddings, we are done with the positional encoding, and we will be discussing about the self-attention. What is self-attention? The self-attention itself is a big thing actually here. It is having several internal layers also. We need to understand that in detail. Now, let me give the overall overview of it. So when it is a transformer, and I'm considering the case study for the example. So I assume that the transformers are used for the machine translation task. What is machine translation? So it's an encoder. We are using the encoder decoder. Then of course the transformer itself is an encoder decoder model, and assume that this is a transformer, and you are providing an input. So in some language, and I'm expecting the output to be in English as just so Swiss etudiant is the output is the equivalent output is I am a student. So this is what the output I'm expecting when this input sentence is passed. And for that, I'm using transformer. Assume that I'm using a transformer. So for the time being, we assume that it's a black box. Now let's see what is there in the black box, the transformer. Let's go zoom into this transformer and see. If you look at that, it is having actually the encoder and decoder. The encoder is the one which is getting the input, and the decoder is the one which is producing the output, right? So encoder will be mapping your input words, like sequence of words, and it will be converting some to some latent vectors, that is Z1 to Zn. So your X1 to Xn, the sequence of words will be translated or transformed to the latent vectors Z1 to Zn, and that will be passed to your decoder, and your decoder will be producing the output sequence of words. So this is how typically a transformer as an encoder decoder it works. And again, zoom into the encoder and decoders. So the encoder is not a single encoder. If you observe, if you zoom in and go to the details of it. So if you use a magnifying glass, assume that, then your encoder is not a single encoder, and some multiple encoders, and your decoder is not a single decoder, right? That's a multiple decoders, and the last encoder output will be passed as input. Please observe that, because we need to have this idea when we are discussing decoder. So in terms of difference between encoder and decoder, that's the basic difference between the decoder is getting, in addition to the previous state decoder, it is getting the output from the decoder also. Sorry, the last state of the encoder also. Yeah. So the last encoder output will be passed as input to every decoder, and remaining things are as usual. So like we start with our understanding, we are using for the machine learning task, and it's an encoder decoder module, and we'll be getting not one encoder, one decoder. There will be several layers of encoders and several layers of decoders will be getting. And let's go ahead and see further details and how one encoder, of course, all the encoders are replicas only. So now if we understand one encoder, it's enough. So now let's go and zoom into one of the encoder and see what are the parts. So now one encoder will be having self-attention and feed-forward layers. So these are the two layers. And again, of course, again, if we go into the details, so many more we need to understand. But basically the encoder is designed with two layers, that is self-attention and the feed-forward. Whereas the decoder is having the self-attention, encoder, decoder, attention, and the feed-forward layers. These are the three layers. Okay. So now you can see the self-attention is common. And in addition to that, the encoder, decoder, attention, because it is getting the encoder input also, along with the previous layers, output, and the final feed-forward. You can see the self-attention is most the same. Only thing is different here from the encoder and decoder. Yeah. So let's go into the details of how the encoder, decoder works. So the text is just whatever I am speaking. That's it. That's why I'm not reading the sentences. Yeah. So now what is the role of the encoder here? So the encoder receives the list. Here you can see we are passing. I'm zooming into the encoder part, and I'm just showing it how this output is an input to the next encoder also. And the first encoder will receive the input. I'm just showing only 2 words, but it can be extended to any number of words. So assume thinking machine. So embedding and already positional encoding is integrated, assume that. So now this is the position integrated embeddings of the vector, like words thinking and machine. They are passed. And now to the self-attention. And self-attention will be transforming them to some latent space. And they will be passed then to the feed-forward neural network. And they will be transformed to another kind of vectors. Let's call it as R1, R2. And that will be passed as input to the encoder 2. And this will be repeated like encoder 2, encoder 3. Maybe there are 16 different encoders. And then the final output of the encoder will be having connection to the decoders, all the decoders. So now the encoder is done. Now let's see the self-attention. In the encoder, the first module itself is self-attention, right? Let's try to understand self-attention. And before we understand self-attention, why do we need to understand? Let's see. So now this self-attention, you can see here these set of words. The animal did not cross. Of course, they're all like, fragmented. The animal did not cross the street because it was too tired. And if you observe, among these words itself, I'm considering only the input. This is the input sentence only. I'm not talking about the output. But in the input sentence itself, the word it is much dependent on these words. You can observe the animal, animal did not, the animal, right? So it refers to basically the animal did not cross the street because it was too tired. This is the example. And in this word, the word it is dependent on the animal, right? So that is what is captured in the self-attention. So in the input sequence of words itself, what is the role of different words when we consider specific words, a specific word? Here the word it is dependent on, of course it is dependent on all the other words also, but it is more dependent on the words animal and the, right? That word relevance will be captured by the self-attention. Okay, so now this is how this is what the higher level abstraction of the self-attention is. Let's go into the detail. See, I'm showing like a different zooms, like the different magnification levels where we are in the architecture. So on the left hand side, I'm showing the encoder decoder architecture of your what you call it as the transformer. And then in the transformer, we have encoder and the decoder. And in the encoder, in each encoder, we have the multi-head attention. That's what the self-attention, and then add and normalization, and then feed-forward add and normalization. So what this multi-headed attention module consists of, you can see the multi-headed attention is having actually the scaled dot product. And of course, these are the V, K, Q, these are the matrices. We like, of course, the value key query values, how we get, we'll shortly discuss. Then the scaled dot product is the operation we are doing. And then it does the concatenate. It is repeated for several times. You need to understand that. That's what the multi-headed, not only one head, multiple times it is repeated. And that will be concatenated and will be passed to a linear layer. And that is the output of this multi-headed attention. And then the add and normalization. And the scale dot product, we can see like these are the, how do we get this VKQ? I will discuss that shortly. But what happens inside the scale dot product is this thing. You can see the scale dot product is actually when you pass VKQ, these two value gets multiplied and then they are scaled. Then a masking is applied, which is optional. And then the softmax score is applied. Then V is multiplied. That is what the output we are getting out of the single dot product, scale dot product. And this operation is repeated several times. And that is why we call it as a multi-head attention, not one single time, multiple times. So that is why the name multi-headed attention. So that is what the, it would be H number of times or any number of times. And this is the encoder, this part of the encoder. And there are several such encoders tagged one on top of the other. So this is about the self-attention. Yeah, let's go into the details, what these V, K, Q are, and how do we do this operation. If we understand this, then that is done, right? Like, then the rest of things are like repetitions of the same. Let's try to understand. So assume that thinking is the embedding vector. Of course, the position integrated embedding vector. So assume this is the thing for thinking and this for the machines. And we have like, we need to get this QKV values as per this. What these QKV values, how do we get that is, we have three different matrices. So one is for query. So here Q stands for query and K stands for K and V stands for value. QKV values. And the weight matrix, the key matrix, and the V matrix. So these are the three matrices we have: WQ, WK, and WV. These are the matrices we have. And these are like the weights, but similar to the weights that we use in case of the neural networks, the same. But we have different matrices. And of course, initially they will be filled with random values, and over the training, the values will get updated and all. So now your thinking value will be multiplied with WQ. Then I get the query value for the word thinking. And similarly, this embedding vector of machines is multiplied with WQ. Then, of course, matrix and the vector multiplication will result in a vector only. So now this is the query for the word machines. And similarly, the WK is multiplied with thinking, the embedding vector X1. So that results in the key value for this word. And similarly, the key value for machine also. And similarly, the WV, the word matrix, like the weight matrix, the weight matrix for the V is multiplied with this X1, which results in V1 and the vector, and similarly the with X2. So this is how we get our QKV values, the query, key, and the value. I hope you understood this. Once you understood, this is almost done. Now, how do we get, like, you need to understand. So the matrix multiplication operation of Q and K. Then the scaled version. We need to scale them up. And then the masking, then the softmax. So, and then we are multiplying this output, the scores, the attention scores actually. Whatever we get, that should be multiplied with the V value, the actual value, right? V stands for the values. So we are going to do that. So let's see in detail. Once we get the WQ, WK, and WV, this is just the explanation of the same thing what we discussed. So what this Q, K, V values represent is, so Q represents what the word is looking for in other words. So here I have shown you the example. So it is basically is dependent on other words. So similarly, the Q value represents what the current word is looking for in the other words within that sentence itself. And similarly, key value represents what other words have to offer in terms of the information. So the animal should offer some information to the word it. So that is what the key values, and the value represents actual information that will be passed to the next layer. And of course, while passing that, it will be weighted by how well the query and the key matches. So we multiply them so that the similarity between them we consider, and then we take the the softmax score of that, and then we multiply them with the values. That is what will be passed to the next level. So the information that we are passing to the next level corresponding to this word. Yeah, now let's see what we are going to do. So we have the embedding vector, and we get that I already shown, right? Just another representation, that's it. So we multiply with WQ, we get Q1, and we multiply with WK. So each embedding, this word embedding, X1, X2, assume there are like 3 different word embeddings. Then how it happens. So multiply with the WQ. You can see across all the words, the W, WQ, WK, WV are shared. The shared weight concept that we studied in convolutional neural networks. So now the Q, K, V values we get, and these values are different for every word, because though the weight vectors are weight matrix is common, we are multiplying them with the corresponding embeddings of the words. So now we get different QKV values. So now let's try to understand. We will be multiplying Q and K. The similarity, to get the similarity between these two. How do we get the similarity? That's an inner product only, right? Yeah, that's what we are doing now. So the inner product between these two we do, and that is what we get the score, single score we get, right? That's the inner product between two vectors is a score. So the score we get. And similarly, the score is computed for every, every word. The corresponding to every word we get the scores. So once we get these scores, now we do the, we compute, we apply the softmax. Softmax we apply on the scores we obtained. So we have, please try to understand a picture of that. So for every word, we got the word embeddings, and we have taken like a WQ, the weight matrices for Q, K, V. So 3 weight matrices which are shared across all the words or all the states. Then Q, K, V we got. Once we get this Q, K, V values, we multiply K and Q. So the similarity, how much information it requires from other words and how much information the other words are offering for this. It is offering for the other words in that terms. So Q and K we are multiplying so that we get the score, and this score will be normalized. The score could be any value, but we would like to have a probability distribution of the scores so that we can, have the attention scores. So for that, we are doing the softmax operation. So like the score, whatever we got, by the square root of dk, where dk is a dimension of the key vectors. So key vectors, say for example, it is 128, then we take the square root of 128. If it is 64, then we take the square root of 64, that's 8. So we divide by 8 and then we apply the softmax of all the weight scores. So that is how we get. Then we need to, get the latent representation of all these words, right? Yeah, that should be passed to the next layer. And once we get these alpha values, we multiply them with V values, because the V value is actual information that should be passed to the next layer. So this V will get multiplied with the scores, the normalized scores, not the actual scores, the normalized scores, that is alpha and all. So this V1 is multiplied with this, and the V2 is multiplied with this. And this, you can consider this is the Z as output. But Z is basically the, a weighted vector only. So weighted combination of all the V values. And how do we get these scores? These scores are obtained by QK values. And after that, a softmax was applied. Yeah, this is the big picture. Maybe as an example, I'll take one example and show you into a detail about how we get those scores and all. Yeah, consider this word thinking and the word machines. We have two different words, and assume this is the embedding vector and the query key value. I have shown you how do we get this, right? Once we get the vectors, we take like 3 different matrices and we multiply them. We get this QKV values. Assume that the score when we multiply Q1 with K1 is 112. I'm going to get the score for thinking, the attention scores for the word thinking alone. Assume there are only 2 words. Then how do we get that? So assume this Q1 into QK1 will be 112. And when you would like to get the score for, the word thinking, so then in that case, you need to multiply the same Q1 with this K2. Then Q1 into K2 you will be getting, that is 96. And now we need to divide these values by square root of dk. I assume that dk is 64, so it is dimensionality of the k. So 64, and in that case we get 8. So 112 by 8 and 96 by 8, the values are 14 and 12. So once we get these weights, we take the softmax of all these. So softmax of all these, it's like I have two, only 2 words, thinking and machines. So for prediction of the word thinking, the word thinking is having 0.88, of course, right? The same word only. That's how it's 0.88 dependency. Whereas on the word machines, it is having the impact of 0.12. So you can see these scores are, should be summed up to 1. So now 0.88 plus 0.12. Then you can see 0.88 and 0.12, they're summed up. And we need to get the V values, right? Yeah. So what is the Z1? We need to get Z1 for every embedding vector. I'll show you that. Where is that? Yes. So for every X1, you need to produce one Z1. So how do we get this Z1? This Z1 as a linear combination of all the vectors. So that formulation we are going to look now. When there are two words, we get the attention scores for these two words. For the word thinking, what is the impact of machines? That's what we are looking at here. And this value is multiplied with V1, and this value is multiplied again with V1, and the combination of a weighted combination of these will be Z1. And the Z1 is the embedding vector. It's kind of a transformation of this X1 is a Z1. Z1 is a transformed vector of X1. And the transformation has been taken place with the self-attention. See, this is only for the word thinking. And the same way for machines also. For machines, we have Q, K, V values, right? And this Q2 will be multiplied with K1. Q2 will be multiplied with K2. Then we get two different values, the scores. The scores will be divided by 8. And then we get the, softmax. And that is what the softmax values. And those values will be multiplied with V2. Then we take the weighted average of them. That is what the Z2 is. So this is how we get the Z1 and Z2, which are transformed to the next. Yeah, I'm just showing you the animation of the same. You can see here. Maybe when you assume there are 3 input words, then, Q, K, V, you can see Q, K, V values. And only for this embedding matrix I'm showing. Yeah, for the first embedding, you get the query and the this key and value are multiplied and you get the score, and then you divide them by, the size of K. Yeah. Then you multiply with the V value. That is what the final, the summation of all that will be the output. See, for 3 input embedding vectors, you are passing 3 output embedding vectors, like transform vectors. And see, this entire block is known as self-attention. I hope you understood about the self-attention mechanism and why we call it as multi-headed. It's not like once, we are repeating it like several times. But repeating it several times, how is it different? It is different because the Q, K, V values will be different. That is how it is different. Okay. Yeah. And once we get these different scores, we take the average of that. That is what will be, you can see scale dot product attention. And these are the H heads we'll be getting Z1, Z2, Z3 for the second head, right? And similarly for every head we get. And there are something like residual connections because maybe there's a possibility of losing information. So to make sure that it is bypassed through the skip connection, similar to your ResNet, whatever the skip connections or ResNet connection, like residual connections. So the self-attention layer also has this kind of, add and normalize. So it's a kind of identity addition of this previous layer, and then we have the normalization task also. So this is how we, we use a self-attention in case of the transformer models. So I hope you got the idea of the self-attention that is the heart of the transformer. So once you understand, the rest of the transformers are the variants of this transformer only. Maybe I stop at this point. I have given like very heavy lecture with all the heavy details only. If you have any queries on the topic, maybe I would be the happiest to take. Yeah, this is kind of, it will be too much for you. So 2 hours may not be sufficient to cover the entire thing. So I stop at this point. I have given enough details, whatever is required for the transformers to understand the transformers. Maybe you need to understand like different transformers now. So if there are any queries, maybe I would be the happiest to take. Hello? Hello?
Yes, ma'am. We'll just wait for 2 minutes if there
Yeah.
are any queries.
Yes, sure, sure.
And then later on we'll wind
Yes.
up the session if we don't have any.
Yeah. You can share your questions in chat also if you would like to. Yeah, thank you, sir. I hope it was clear. I have given sufficient details and from like the very basic detail to the very complex. I have covered about the tension and the transformers. Thank you.
Ma'am, I think that the session is very clear and there are no more queries, I guess.
Yeah. Okay.
Thank you so much for joining, ma'am. And also, I guess we have another session with you today.
Yes, yes. We have a lab session that is on model deployment. Basically, machine learning. We do it in Jupyter notebooks and all. Then, how do we design a web interface for that? I will talk about that. How to deploy your machine learning models and using Streamlit and Flask, if possible, both or at least using. Yeah, I think 2 hours is sufficient to show both using Streamlit and Flask. They both have their own advantages and disadvantages. So how to use design web interface kind of stuff for the machine learning for the deep learning models. That's what my talk is about in the afternoon, 5 to 7, right? I guess.
Yes, ma'am. From 5 to 7, you have a session again.
Yes.
So thank you for joining us for this hour, ma'am. Again, we'll meet
Yeah,
at
sure.
5 to 7 session.
Thank you. Thank you all.
Thank you so much. Thank you so much, ma'am.
Thank you. I thank the organizers of this FDP for inviting me for this session. I hope you all have got some information. I hope it is relevant to the theme. I thank the participants also for their patience listening. Thank you.
Thank you so much, ma'am. And also to all the participants, the next session will start at 2:45 p.m. So please join before 5 minutes. Thank you so much. Good afternoon, everyone. Welcome back to the session. Now, the further session will be a lab session, which is going to be on the topic using GANs for image generation, which is an hands-on approach. It will be carried out by Dr. K. Devi Priya. So we'll first know about our resource person. Dr. K. Devi Priya is an associate professor at Department of Computer Science Engineering at Lucky Reddy Balireddy College of Engineering from Mailavaram, Andhra Pradesh. Dr. K. Devi Priya is an accomplished academic and researcher with over 16 years of teaching experience in CSE. She currently serves as an associate professor, a dedicated educator. Dr. K. Devi Priya earned her PhD in computer science from JNTUK, Kakinada in 2021. Her areas of expertise include machine learning, cloud computing, big data analytics, and deep learning. Dr. K. Devi Priya has made significant contributions to research, having published numerous papers in reputed journals and conferences, including Springer and IEEE platforms. She is also an active mentor for student innovation projects such as the Smart India Hackathon, CSI in-app words, etc. A resourceful professional, she frequently conducts workshops and guest lectures on advanced computing topics, fostering knowledge sharing among students and educators alike. With a strong technical foundation and leadership qualities, she continues to make impactful contributions to academia and research. We welcome you, ma'am. Now I hand over the session to you.
Thank you, madam. Is it audible, madam?
Yes, ma'am, you're audible.
Okay, thank you, madam. Madam, I hope my screen was shared. Is it visible?
Yes, ma'am, it's visible.
Thank you for the introduction, madam. And good afternoon, one and all, the respected coordinators and who are arranging this workshop and given the opportunity. I am very thankful to each and everyone and the faculty members who are participating in this FDP. Good afternoon, one and all. Today, I would like to share a GAN approach for image generation for laboratory hands-on exposure. So before going to discuss the hands-on, first I would like to give the brief on 15 to 20 minutes brief on what is the GAN approach and how we can do uh, uh, the image generation using the GAN, what are the various components will be required. So those will be theoretically I will discuss later on, and I can share the how to implement all those. So GAN, we know that the GAN will be a generative adversarial networks. So last 3 days onwards, we have the FDP is going on the various concepts like artificial intelligence, machine learning, deep learning, and currently we have shifted to the another exposure related to the AI, which is generative adversarial networks. So artificial intelligence is make a dominant, it will be giving the more applications we have implemented with the help of artificial intelligence. Currently, the trend will be fully equipped with the AI only, and ChatGPT, which makes a lot of effect on the social media applications or searching, whatever we would like to do, that will be easy with the help of ChatGPT and the latest AI tools. And further, they have using the concept like generative AI. AI is a different variations will be there. AI is an artificial intelligence which have an expert systems. With the intelligence, they can do the activities. And under the AI, next we have a domain like machine learning. Machine learning to predict any classifications or to predict any applications like health related or agriculture related, like the soil is good or not, or in a particular soil, whether we can do a particular crop is suitable for that soil or not. For finding those ingredients, to finding those patterns, we can use the machine learning. And after that, there will be another subdomain like deep learning, what yesterday sir was shared. In the deep learning, with the help of deep learning convolutional models and whatever the neural networks will be there in the deep learning, we can do the automated process for predictions, and we can be work with the huge amount of image data whenever the data will be large, and if you want to identify any patterns among those data and as well as predictions, and all those will be possible with the help of deep neural networks. And the GAN is also a deep neural network, which is a sub process of deep neural network. Whatever the basis we have learned in the earlier from the experts, that will be all those are basis for this GAN network, which is a generative adversarial network. So what is the main use of this GAN, why we can use this, and what's the difference between deep neural networks and this GAN approach? So whatever the deep neural networks we have, variant models will be there, BGG16 and AlexaNet, and as well as ExaNet, DeepFaceNet, and we can define our own models to identify whether the patterns will be okay, or to predict whether the particular, if I am taking an image, whether the person have a CT scan image, based on that CT scan related to the chronic kidney disease, whether the person have the CKD problem or not, that will be verified, that predictions will be verified with the help of deep neural convolutional neural networks. And coming to the GAN approach, the main motto of GAN approach is, it is not for the predictions. The main motto is to generate a data based on the existed data. If the data is not yet sufficient, or I have a lot of image related, health related data, heart related images will be available with me. But those images related to the children's, but the problem, the heart related problem is more for the old age people or above 50. Those are facing the problems. But nowadays, the even after the COVID pandemic, even kids also facing the heart related problems. But the data will be, the data which related to the kids are very limited for me. So I want to work on those data. How can I generate? Because the data is limited. Only few samples are there. So to generate a new samples from the existed with an accurate samples generation, that will be possible with the help of generative adversarial networks. So which is useful for the main motto of GAN network is, so which identifies, which generates a new samples from the original database. Whatever the original samples will be existed from me, with me, from those samples, I will generate a new samples will be generated from that. So which is a purely, these GAN is not a new approach, not a new neural networks. Whatever the neural networks we have learned, so based on those neural networks, based on those convolutional networks only, we can implement a GAN approach. So the base for the GAN is a deep learning, which is the main motivation is to generate a new samples. For my applications, if the samples are not yet sufficient, samples means we can generate a text-based samples, we may generate a image-based samples, we may generate a sounds, we may generate a videos, whatever the samples we require based on the applications, so we can generate that. So in the GAN networks, so mainly it will be two components will be there. So whenever I would like to generate any images or any videos or audios, So in the GAN, so the name indicates we need a two networks will be required. So one is the one component will be a generator. So from the diagrammatic representation, we may see this. So GAN which have a two important components, two networks will be there. So which one will be called as a generator. So this is a neural networks. It is an architecture which generates an images. So whatever the existed images will be available. From those images, we can generate a new images. The generation of fake images will be done from a network called generator. And we have another important network called discriminator. So discriminator which checks whatever the images will be there. So whatever the images will be generated by the generator, whether those images are real or fake, that discrimination will be done by a network called discriminator network. So when we would like to implement a practically for any CKD images, or today we can work with a built-in handwritten digits database, MNIST. So if you want to work with any our own research area related database or built-in databases, so we need to define two components, two architectures will be required. So one architecture will be a generator and the second architecture will be, second component will be a discriminator. So generator which creates a fake data and the discriminator or adversary, so which checks whether these data, the responsibility of discriminator is to clearly discriminate, to clearly differentiate the real data from the fake data. So based on the iterations, based on the number of iterations, number of executions, finally the generator need to generate an images which is not identified. Even those are fake images that will not be identified by the discriminator. So we need to design the model in those manner. So these are the simple words. The generator who is an artist, so trying to create a pictures, and a discriminator, he is a art critic. So examining whether whatever the picture will be drawn by the artist, so is it really whatever the, if we want to draw a cat image, so you draw the cat image. So whether is it really cat or some other, is it appearing as a cat? Really it should be appears like a cat, or it will be like other animal like dog or donkey or some other. So that critic will be done by a discriminator component. So this is the two models we have, two architectures we have in the GAN network. One is a generator to create images, fake images, which will be like a real, and we have a discriminator. So tell whether those images are real or fake will be done. So which will be, the GAN will be based on an algorithms, based on a concept called deep learning algorithms. We can design the components completely with the help of convolutional neural networks, convolutional based generative adversarial networks we can design, or based on the applications, simply we will go to the neural networks by using a dense layers. So with the help of dense layers also, we can design the GAN model. So this is a simple, very simple example. So we, as per the discussions, we have a generator and as well as the discriminator. The generator want to create a cat image. So generator want to generate a fake image cat. So in the first attempt, so generator randomly takes some noise data, some data. Based on those samples, he draw the image. He generated an image. If you have observing that in the first attempt, the main objective is the generator want to create a cat. But in the first attempt, the generator generated an image. It is not like a cat. It will be looks like a snake. So if we have seen this first attempt, so in this attempt, the generator drawn some image. Okay, based on the image, immediately the discriminator will verify whether is it real image Is it real image or fake image? So clearly, so in the first epoch, in the first iteration, there will be clearly indicated that this is not a uh, real image, it is not a cat, it will be a fake image. So discriminator will clearly identify it is a fake image. And in the second attempt or third attempt, after few attempts, after 15 epochs, or after we know that epochs, whenever we are developing a deep learning algorithms, so immediately with one iteration we can't decide. So we can train the model number of iterations. Maybe it will be 50 epochs or it may be 500 epochs. So sometimes we need more number of epochs also to train the model properly, to control underfitting and as well as overfitting. So variety of parameters will be considered. Among those parameters, epochs is one parameter. So in the training phase, after maybe 10 to 15, the generator will generate an image. Maybe the image blueprint will be a cat, but it is not completely looks like a virginal cat. Just a blueprint will be, the shape will be generated as a cat image. Now again, discriminator will verify that. So after verifying, it will be, in this example, it will be discriminated as a, it will be considered it is a fake image only. And after even few attempts, after again based on the discriminators evaluation, and again the generator will update the parameters. It will update the parameters. Then it will again it will again generate a image, which will be, if we have observed in the last, so it will be generated an image. So even it will be fake image, but the discriminator will not be discriminated. It will not be classified. It will not be considered it is a fake image. It will be considered as the whatever the image will be generated by the generator, that should be considered as a real image only. So this is the, in this way, by updating the weights, by updating the inputs from the discriminator, by taking the data from the generator, so both will be generates, the generator will generate the images, the discriminator will classify, based on that the weights will be updated, and finally the generator will generate a perfect fake image, which will not be identified as a fake image. It will be identified as a virginal image only. So the main goal of the GAN network is a generator who wants to generate a fake images, but it must be looks like a real images. So the goal of generator is they want to make a they want to make discriminator as a fool. They need to consider, even they are generating the fake images, that should be identified as it real images. The goal of the discriminator is they want to clearly differentiate what are the real images and as well as what are the fake images. So this is the main components will be there. So here, if it will be a simple example. So now maybe I hope that what are the main components will be there whenever we want to design any applications. So we need to write the two components. One is the generator component, generator architecture, and the second one will be a discriminator component. And we need to train the model for the generators, and as well as we need to train the model which is a discriminator. And so how the discriminator and how the generator, on which basis the generator will generate, say, fake images. So initially, what it considers, what type of data it will be taken, and how it will generate, say, fake images, how the discriminator will verify that. So this is the fundamental architecture. So initially, the generator network, whatever the neural network we are creating, whatever the component we are creating, that component main objective is to generate a fake image. If we have observed like here, so it will be a black image will be there, which is a fake. And we have another database, so which is a real images also will be there. So here there will be a real image will be there, and also the generator will take in a generated a fake image. How this fake image will be generated? So there will be a random input, random noisy data will be considered for initially epoch 1 for starting stage. The generator network will take say some random noisy input. So here we can consider there will be a seed called random noise seed, which is also called as a technical word latent vector. There will be a one-dimensional vector, which is a random noisy seed. So based on these seed values, the generator may generate a fake image. So it will be one. So once these fake image will be generated, that will be given as an input to the discriminator. So the discriminator need to classify whether it will be real or fake. And also we can supply. Discriminator takes two types of inputs. One is fake images, and also there will be real image. Real images also will be given as an input to the discriminator. So those images also will be taken as input, and it need to be classified whether it is a real or fake. So it will be considered two types. One is it will consider an input as a real image input will be considered, and the role of discriminator network is whether is it real or fake, and also it need to take the discriminator will also takes a fake image which is generated by the generator network, that will be considered again whether is it real or fake. From these observations, if we may consider that the generator network is a unsupervised learning, because based on the random noisy data, based on those random data patterns, it will generate say images. There is no need of any labeling data also. Just it will takes the random data, random noisy data as an input and generate a fake images. So generator network we will be considered as a unsupervised learning. And coming to the discriminator network, which classifies whatever the input it is taking, that will be classified as a real or fake images. So discriminator network will be comes under a type of learning called supervised learning. Supervised binary classification problem. So it will be either it will be a real or fake. So initially we need to supply a random noisy data. It will be an input. It will be an input to the generator network. So it will generate the images based on the feedback from the discriminator. The gradient values, the back propagation, the mathematical algorithms, weights will be there. Based on the given discriminator feedback, the values will be updated. So both are independently will be done. So this is the main architecture. We have seen them when we would like to apply the GAN approach. If our data is very limited, we have lot of applications like when we are going to the health related data, certain image data is available, more data will be available for some cases. For some type of health problems, data is very, very limited. So in those cases, to generate even the data is very limited. From those limited data, we can generate a accurate data with the help of GAN network. So for that, this is an approach. So initially we need to supply some seed value. Based on seed value, it will be, this approach will be working. So generator which gives input and which generates an output, that will be taken as a discriminator and it will classify. So what is the main steps will be there? How we can design the GAN approach? So first we need to based on the applications, whatever the layers. Yesterday I have seen the whatever the lecture will be explained by the sir. So there we have sir has taken the healthcare related images and image processing was done. So based on that type of applications, we need to define the architecture. So the architecture will be for two components. So one component will be a discriminator component and the second component will be a generator. So first we need to define the architecture. GAN architecture is required, and once the architecture, number of layers, number of epochs, number of parameters, weights, all are defined, then we need to train the discriminator. So we need to train up the discriminator to discriminate, to distinguish real data versus fake data. And also we need to train the generator. The objective of a generator is so to generate a fake data which will be considered by the discriminator as a real data. So that is the main objective. Train the generator to fake data, to generate a fake data which should be identified as a real data by the discriminator. So the main objective of generator is to make a fool, to make a discriminator to be a fool. That meaning is he discriminator network can't be differentiate whether is it real or fake. That confusion or even fake data should be identified as real data. So we need to design the layers, we need to add the layers in that manner. And so continue the training process, continue the training process of discriminator and generator for multiple epochs. And once if the generator generated a good images, and which will be very difficult to identify by the discriminator, then we can save that model and we can store that a new related data. And after once the data will be stored and updated, we can apply different models, whatever the models will be there, deep learning models, or if it is text data, or if it will be numerical data, we may apply the machine learning algorithms based on the type of data. Various models will be applied. So this is the main 5 steps of GAN. Define the architecture, train the discriminator, train the generator, and continues the discriminator and generator for multiple epochs, and finally we can save the models. So these are already we have discussed. So the main responsibility of GAN is high quality, realistic data will be need to be generated. So from real world data for the real time applications, so the high quality data will be generated. And unlike the traditional models, the main objective is not for predictions. It will be the main objective is generation of the data. And where we can use these GAN model, we can use the GAN model for the media, entertainments, healthcare, design to generate a new images or to improve the quality of images also. To improve the quality of images, to edit the images, or to from the images to from the photos to emojis, or from emojis to photos, or videos generation. In so many applications, we can use the GAN network. So as per the discussion, so GAN will be operated on a framework unsupervised learning, so which does not require any data, any label data. And GAN under a component called generator component, and from the discriminator we can use the component type of learning called supervised learning. So here some more additional applications will be there. So we can enlarge the data with the help of GAN. We can increase the data size. We can improve the quality of data also. If some patterns will be missed, if some quality will be lagging, so for that also we can improve the quality of images with the help of GAN by tuning a parameters which are regularization like that. So these are already we have discussed what is the generator and what is the discriminator. So it will be, the generator will be identified as a, we have taken a notation, standard notations, which will be G, which takes some random data. So from that random data, the generator function will be applied. So which will need to give an output as a image. So JET will be a noisy data. We have applied the generator architecture. From that generator architecture, we need to get an image. So the discriminator role is identifying real or fake. So the discriminator role is the probability of, if I have given an image as a real image, what is the probability of that will be classified as the image is real? If I have given an image as a fake image, already we have seen the fake image will be representation is G of Z. If I have given a fake image, how it should be? What is the probability of? What is the probability of that image will be considered as a fake? So these are some mathematical basic notations, generator training and discriminator training. So we will be considered, the metrics will be considered as an accuracy and as well as the loss. So that we will be considered the generator loss and as well as discriminator loss we will be considered as a parameters. So it will be the basic theory related to the, before going to the practical approach. So we need to understand the basic, how it will be trained. I hope it will be clearly understandable, and we will go to the theoretical practical approach. So this is the main important architecture. So for discussion of the practical approach, so this is the seed data, random noisy data we will be considered as a initial seed value, and generate the fake images, and real images also will be there. The discriminator will be taken an input as real image and as well as fake image. Then it will need to be clearly identified, is it real or fake. So we can know that for the implementation of GAN networks or deep neural networks, deep learning models or machine learning. So there is a compatible API will be available, which is a Python is a compatible API programming language for us. So with the help of Python frameworks like Keras, we may use TensorFlow or PyTorch. Based on different frameworks, we can develop these networks. So I have taken a TensorFlow and Keras for implementing these architectures. So initially our application will be, so I can do in a two-way approach. First madam, is it visible, madam? Hello.
Yes, ma'am, it's visible.
Okay. So I will be discussing a manner how the generator and discriminator will be working with each and every line, and later we will be completely discuss for how it will be the completely, what are the consider, how the discriminator and generator will be coordinated, what are the evaluation parameters will be generated, how we can consider whether the images quality is good or not, that will be discussed. So here the standard application is I have taken a data from the handwritten digit data set will be there. We may take our own data set based on our research application. We may take our own data set like a chronic kidney disease data set. I am working on a area like microplastics. So microplastic detection is my area. So in that the plastics identification is easy, and we can get them more samples related to the plastics. But microplastics identification and getting the data related to the microplastics also very tough. So for that also, we can use these GAN to generate a bead samples, to generate a microplastics related to a category fragment, to generate a samples related to the bead. So we can use the network called this network. So here our application is, we are working on a, we would like to generate a new data set which will be based on an existed database MNIST. The MNIST is a data set which have 60,000 samples related to the digits, handwritten digits from the 0 to 9 handwritten digits data will be available in this data set. So which is a built-in data set, the Python which provides so many built-in data sets like iris data set, cancer related data set, and CRF data set. So many built-in fashion related data sets are available. So I have taken a handwritten digit data set. So first we can import the relevant packages, TensorFlow, and network will be a collection of neural networks, which will be a completely, we may use a convolutional based neural network we can use, like how we can design our deep neural networks, deep convolutional networks. We can use convolutional based neural networks, or if application is a simple, we may go to the neural networks only, which is a dense based layers also we can use. So for that we have imported from the Keras, we have imported layers and as well as sequential. To add the layers to the models, we have imported all this. NumPy will be there to generate a random input, because initially the generator will take say noisy data. So for that, to generate a random data, we can use the methods from the NumPy. And a visualization for that, we have taking the matplotlib, or we have some other APIs like Seaborn or other APIs also there for visualization. So once the relevant packages are imported, so we can take in the, we are loading the data. So further loading the data, so we have used the TensorFlow.keras.datasets. We are using the MNIST.load_data, which loads the data. But here, if you have observed, earlier cases, we are taking 4 parameters. Whenever we are loading the data, we are considering training data, test data. For input training and as well as test will be required. For prediction purpose, the training data and as well as test will be required. In the earlier, either machine learning applications or deep learning applications, we required 4 parameters: training, test, and as well as train and test. But it is not a prediction. It will be a generation of new data. So there is no need of any test data. Test samples will not be required. Any testing Y train or Y test or X test is not yet required. Just for training purpose, based on the given data, new images will be generated. For that purpose, X train will be sufficient. So that's why here X train only one variable will be considered, remaining all will be empty. So we have loaded the data. And once the loading will be completed, so the generator network we have seen. So the generator network will be considered the input as random noisy input. So we need to, if we have observed, it will be a one-dimensional vector will be considered as an input, then it will generate say image, fake image. So for this case, so we need to reshape whatever the data we are taking. First we need to normalize. We are considering our images are a grayscale images. we need to normalize those images to them for a scale of 0 to 1. In some cases, they are considering them normalization to the scale 0, 1. In some cases, we can consider the scale of normalization to the -1 to 1, because the pixels will be in the range of 0 to 255. We are scaled down those pixels to the -1 to 1. So we are normalizing that. We are normalizing, and after that we need to convert our images into the one-dimensional vector. So we are reshaping that. Whatever the data normalized, and those normalized data will be reshaped to the one-dimensional vector. So it will be, what is the 28 by 28? It will be our image pixel width and height, which will be converted into a one-dimensional vector. And now, so we have imported the packages. We have loaded the data. Only X-train is maintained, and the images are grayscale images. And it will be normalized to the -1 to 1, and it will be reshaped to the vectors, single dimensional vectors. Now we are, but for the training purpose, we need to set the batch size. How many images? The total images of in the existed data set, 60,000 images will be there. So for a single batch, we can, what is the batch size means? How many images we will be generated as an input. So for that, we have taken a batch size is 64. And the inputs also not sequential order. The inputs will be, from the 60,000 inputs, randomly it will pick for every batch. As a batch means 64 random images will be picked. In the second iteration, some more 64 random images will be picked. So that will be, we can, that shuffling will be applied. Not a sequentially we can get the data. We can get the data in the random order. Shuffling will be done. Now it will be an important component called, we need to define. So there is a component. We need to define a generator. We need to define another component, discriminator. So we have defined a function, build generator. In this build generator, we defined a layers. So here, if you observe here, there will be no convolutional layers here. Simply, we are using a layer, some dense layers. Dense only we have applied. There will be no convolution. You can also, we can define the generator with a fully convolutional layers also, we can define that. There is no problem. We can use the only dense layers based on the application. We can also add convolutional based layers also. So here we define the dense layer, dense will be there, and with 8 neurons called 256 neurons. And we have added a to identify dead neurons, to identify the dead neurons, to improve the performance, to control the regularizations. And so for all those, we have added a activation function with a learning rate 0.2, leaky rectified linear unit we have added. We have applied another normalization function, batch normalization. Again, we have, for the next layer, we added 512 neurons with a point to learning rate, again normalization. And next layers, we have added 1024 with learning rate, activation function and learning rate. And finally, we have generated an image of 28 by 28 with an activation function, tan, various activation, softmax activation function, tan, sigmoid, various activation functions will be there. We have used the tan H. If you are observing here, build generator, which takes the latent dimensions also. What is the dimensions in the random? If you are seeing this, in these random noisy, how many values are there? 1, 2, 3, 4, 5. So the dimension is, so one row, in one row, how many values are there? The image will be generated by one row along with 5-dimensional values. That will be supplied. What is the dimensionality? The dimensionality will be considered as an image. So it will be a simple architecture of generator. Now we need to check. We are not at training here. Actually, training also will be required. First, we defined only a generator network. We have defined a generator network. From the generator network, so I don't want to train it. Training will be in the separately. I can again show that. So how the generator will be generates an images. So once the continuous same code I have repeated here. We define the network. And now how to call the generator. So for that, so how we can how we can give the input for that. So we need to give a random seed input will be, we need to supply these values. So initially random noise seed latent vector will be given as a input 0.1 minus 0.3, 0.6 minus 0.7. Randomly we need to supply those values. So for that there will be a uniform distribution in the NP numpy random function with a different types of distributions, Gaussian distribution, uniform distribution, different types of distributions are there. We have used the uniform distribution normal with a mean. What is the, in which range the values will be generated? What is the mean value will be 0 and standard deviation will be in the 1. So how many images will be there? How many images the generator want to generate? In supplying your input, each row having how many values, the latent dimensionality will be considered. So we can be execute these. So I will execute. For this function only, I will explain. So if you have observed this output, it will be only for generating a random values. So why these random values are required? Very, very important. So initially for generator, we need to give a random input. Noisy input will be given as a input to the generator. So those random values will be generated with the help of np.normal, mean scale of 0 and standard deviation. So these are the different values. So up to here, it will be one vector, one image. And again, actually we have considered for the 5 images we have considered. So these are the values for the one image. So these are the values. How many values we have given? Actually, in each vector, 100 values are there. So up to here, one image, one row, one image with 100 values. Next, second image with 100 values. The next one is third image up to here. For the fourth image here, and for fifth image this one. So here that we have generated without any training, just we are from the random input. from the random input, we are generating the images. So for that, what is the random input? Random dot normal. How many images? I need 5 images. What is how many values we are supplying? Latent dimension. The dimensions we have supplied in the below we have supplied the dimensional value as 100. The dimensional value we have supplied as 100. So in the range of 0 to 1 mean scale and standard deviation, we have supplied each image having 500 values. So based on those data, one random image will be generated. So we printed the random images. So, and after that, these random images will be given as an input to the generator. So these are given as an input to the generator. So generator dot predict of random underscore latent underscore vectors. So it will generate a images. Again, those images will be a rescale. So this is the process for we have designed a generator. From that generator, for that generator, we are giving an input as a random vector. We have given the input, and after that, from those random input as a passed as a values to the generator, it will generate an images. Those generated images will be displayed. So this is the logic for displaying the 5 images. So what is the latent value we have taken from this actually execution? So latent value, each image having a dimension of noisy vector, which is a value called 100 values. One vector, one image, which have a randomly having the values called 100 values with a range of 0 and 1. How many images we generated? 5. Build the generator. Build the generator of we passed the 100 values. So generator function will be invoked. And once the generated function is invoked, we can, for the display purpose and image generation, we have seen that image generation function here. The generator will return say value. The generator which returns a value. So for that, from the returned images, we can display all these. We have called generated images and as well as displaying of image. So here, one important thing is we are not at generating, we are not at training the generator, just we are created a generator and we have given randomly an input to those generators. Based on the input, even we did not given any epochs also. Based on the input, it is generated in image like this. It is not a handwritten image. Just whatever the input we have, random input we have given. So it will be considered, generated if fake image. Image 1, image 2, image 3, image 4 and image 5. So randomly 5 images are generated. Now we can also, one more component, discriminator component will be there. The discriminator also, what the discriminator will take. So this is how we are supplying the input is an important case here. The generator which takes a random values as an input and generates an images. What the discriminator will take? The discriminator will take either fake image as an input or real image as an input. Need to classify. So discriminator will take image as an input. So further, discriminator which takes the image as an input, and here also we need to define the model. Convolutional model will be added and activation functions. If there are any dead neurons are there, we can remove the dead neurons. Again, we have added them convolutional neural networks with initially we have added them 64 feature maps with the kernel size equal to 4, and the number of movements will be, striding rate will be 2. The pixels will be, actually the convolutional layers are required to accurately identify the patterns of images. How accurately we are identifying the patterns of images. Feature map we are selecting. So for that we can use the convolutional neural networks. So by using the convolutional 2D, we can collect the features of whatever the either fake image or real image. We need to identify the patterns. So for that identifying the patterns, so this will be the parameters, how many feature maps we are considering, what is the kernel size, how it will be moving, is the input will be before processing and after the processing the input will be same or not. Those parameters will be added. Again, dead neurons and activation function. And here we have increased the feature maps to 128. And here we are increasing the feature maps to 256. And here we are increasing the feature maps to 512. And finally, at the end, it will be again considered as a single dimensional. So which will be converted as a single dimensional with the help of Platon, and we are checking whether it will be real or fake with the help of an activation function called sigmoid function. So when we are defining one important thing we need to remember here is how we are taking the input of generator, in which format we are taking the input, in which format we are giving input to the generator. That is an important task we need to identify, and which format we are giving input to the discriminator. Discriminator takes the input in the format called image format and identifies the features and considers whether is it real or fake. And coming to the generator, it will be considers the random noise as an input, the random noisy as an input, and from that input it generates an image. So we have defined the model. And here also we have taken some images, not MNIST, even in the earlier tab we have taken the MNIST images just for loading purpose, but here we are taking the real images as a random value. We have taken 100 samples and generated fake images also we are creating. Randomly we are creating real images, randomly we are creating the generated images, and we are calling a discriminator. The role of discriminator is to identify, to classify whether the image is real or fake. So for that compilation, we are using a lossy binary cross entropy. We have using that lossy function, the probability of how it will be real, the probability of how it will be fake. For that, the binary cross entropy is considered as a lossy value. Optimizer we have added. We are considering the accuracy also. For the whatever the images we are taking randomly, so real images and generated images, we call the discriminator, we compile the discriminator, and for the real images, because it is a classification task, the discriminator role is classification. So we are adding a label for that. So for the real images, we are giving the label as 1. For the fake images, we have given the label as 0. We are giving the label as 0 for the fake images. And now we are training the value also. We are training the discriminator. We are training the discriminator on real images. We are training the discriminator on generated images. And finally, we are printing the what is the loss value and what is the loss value for real images. What is the loss value for fake images? What is the accuracy for how the discriminator exactly identifies? These are the how much percentage the real images will be identified by the discriminator. That is a real accuracy. And how many fake images are exactly identified by the discriminator, which is the accuracy of fake. We are considering two types of accuracies. One is a real images accuracy, fake images accuracy. A real images loss and fake images loss value also. Again, I will be repeated because defining the generator function is an easy because it is taking a random input and randomly it generates an image. That will be an easy task. But writing the discriminator is as a if you are new to this is somewhat confused. Writing the discriminator logic is different from the generator because it will classify whatever the input we are passing, that will be classified as correct real input or fake input. So for that case, so we are designing a discriminator function, and the parameter it takes is an input, image input with a shape value is 28. 28 indicates the image width and height is 28 by 28 dimensions, and 1 indicates the image color is gray images. These are images, gray images. If it is RGB color, we can give it as a 3. But it is a grayscale image. The input shape of image is 28 by 28 and the color of image is 1. Now, to accurately or to retrieve the features of images, to retrieve the patterns of hello, hello, madam, hello.
Yes, ma'am.
Is there any problem, madam?
Oh, no, ma'am. You can continue.
Okay. To identify patterns from the images, we can take it as a we can define the network with the convolutional networks to identify the features. How many feature patterns we are identifying? So 64 feature maps are there. So defined with a kernel size and stride rating, how it will be moved, how many pixels it will be moved, and whether before processing and after processing, is the image size will be same or not, and activation functions and dead neurons removing rate. So one by one we have added layers. So we have added 1, 2, 3, 4. 4 convolutional layers we have added along with other hyperparameters. And finally, the entire convolution will be converted into the flatten. It is defining only the discriminator. Now, how we can call those discriminator? So for discriminator calling, what we need to supply? We need to supply either fake images to check the whether is it fake or real, or to check whether is it fake or real. Either fake images we need to supply, or we need to supply the real images we need to supply, or we can supply the fake images. For that purpose, in this example, the images, real images also randomly generated. the real image values also. How many? The dimensional vector is 100. 100 dimension vector, latency vector with a size called 28 by 28 in 1. And similarly, how many generated images also we randomly, 100 samples we have randomly generated. And call the discriminator, compile the discriminator, and consider the real labels. Consider the real labels and as well as fake images. And give the, once the compilation is completed, we need to check it. We need to apply whatever the training we have done, train the discriminator on the real images and as well as fake images. So here real images and real labels, generated images and fake labels we have given, and generate the accuracy. If you have observed this, the discriminator real accuracy is for on real images. On real images, the accuracy is 70.99. 70% of real images are correctly identified by the discriminator. So this is the loss value. And similarly, the accuracy of the discriminator for fake images, the fake images identification, the discriminator has performed 35% only. That meaning is the discriminator accuracy is reduced means what the observations we have gained, the discriminator accuracy is less means the generator generates a realistic images. The generator that generates a realistic images. So for that reason, the discriminator has a confusion whether is it a fake or real. So it is giving even fake images will be considered as a real images by the discriminator. So that's why it have only 35% of fake images are correctly identified as a fake, and remaining fake images are identified as real. So these are the parameters we have considered. And here one more again, here we did not apply any training approach. The generator is not learned. Just initially we designed the networks. We have designed the networks and we have given an input. In the first epoch itself, without any training, it is generated randomly images. And discriminator also, we did not given any training. Without training, just we defined an architecture and we have classified how it is, what are the parameters it is taking, what is the loss parameters, how it will be labeled, what are the accurate metrics will be considered. That will be we discussed in this example. So again, we will go back to the architecture. Once if we are checking, we are focusing on these architecture, now we can have some clarity. So generator network is a convolution based network or any neural networks which takes some random values as an input initially and generate a fake image. And now a discriminator network, it is a discriminator network which takes input is either fake image or real image. It will take as an input. Images will be considered as an input, and the responsibility of discriminator is it will be classified as either real or fake to evaluate whether it will be. So for any model, we need to evaluate the performance. For the evaluation of performance, we are considering the discriminator loss and as well as discriminator accuracy. And similarly, we have another metric called generator loss and as well as generator accuracy also will be there. But in this example, we have considered only we executed only discriminator loss and discriminator accuracy. Now we will go to the another example. So I will be run these ones. The data set was downloaded. We have normalized. The model is executed. Generator, which generates some random images. Input is one-dimensional vector and output will be an image. And discriminator will be there. NP.1s automatically added. For the real images, the label will be added as a 1. NP.zeros for the fake images, the label will be added as NP.zeros function itself, the label will be added as a 0. So if you observe now again, in this execution based on again the training and the random values generations based on the input, the accuracy will be again the discriminator real accuracy also. But on real images, the accuracy will be 61%. Our real images are correctly identified and 30% of fake images only identified. Now we will be go to the, this is the basic, the 5 steps of GAN. 5 steps of GAN. We have done the first step. Define the GAN architecture based on the application. Without training, just we have, without much more training, we have taken only one epoch and generated the fake data. And we have created a discriminator and identified whether is it real or fake with by considering the evaluation metric, which is accuracy and discriminator loss. Now we will be go to the how to train, how to continue the process, how we can take the multiple epochs, how we can save the model and create a new realistic fake data that will be discussed. It is also the similar whatever we have discussed. It will be in the similar way, but we can train the model. For that, we will check how it will be trained and how it will be generated. Also, we will check that. So purely, it will be this example we will be working on MNIST data. Even earlier also we have taken MNIST loading purpose only, but we did not use those data anywhere. Just we have taken the parameters only. For discriminator, randomly we are generated the real images, randomly we are generated the fake images. But now we will see the complete example. So already we know the packages required for importing, and we loaded the data set. So it will be no need of any testing samples, just for only training purpose to create a new data set. Just we require that training samples are sufficient, and reshape that to normalize the data to the scaling factor of -1 to +1. So for that we are rescaling these, because why we are multiplying and subtracting with the 127.5, because the range value 0 to 255. So if you are doing, so if we are performing with these value only, we can get the values will be in between -1 to 1. And we have reshape our image to the one-dimensional vector, and the batch size will be 64. Batch size will be 64. And for the generator or discriminator, we are giving the inputs randomly. For that, we are applying the shuffle operation. The bill generator. So we are creating a generator in the same approach. So what is the dimensional? So single image, each image having how many values, that will be supplied as a dimension. We are adding the layer neurons, rectified linear unit as a activation function. We applied the normalization. Again, we have added 512 neurons. Again, we have added 1024 neurons. Finally, we are converting the input into two-dimensional input, one-dimensional vector into two-dimensional image. Sequential dense layers, activation functions, input will be converted into two-dimensional vectors. And now discriminator will be there. And earlier we have observed in the previous, the discriminator will be also have the convolutional neural networks. So that is, if you want to go with the convolutional neural networks for effective feature extraction, we may also add convolutional neural networks. Convolution 2D we may add, or if only neural networks are sufficient, you may go with the dense layers. So dense layer with the neurons. So always it will be take the input as an image 28 by 28, comma. We did not supply any value here. That meaning is it is automatically taking a channel value as 1. And activation function we have added, dead neurons we have removed with the learning rate. Again 512, 256. Finally, the sigmoid function will be used as an activation. Just it will be a definition. We did not executed anything. We defined the models only. And now initialize the model. So what is the dimensional value? So each image with 100 values, we have supplied the value set 100. Generator, we call a function bill generator, and we call a function bill discriminator. And to execute that, to identify that, we need to evaluate the metrics. So we need to write the lossy function, and as well as we need to add the optimizers. Writing of the syntax is different. We can go to the different approaches. At a time, we can, in the compilation itself, we may mention the metrics, or we may mention the metrics as a separate also. Binary cross entropy will be added, and optimizer added with a learning rate. So all these are different hyperparameters for effective neural networks. So we have added these two, and now we train the setup. For training setup, how we are passing the real, we have defined a function. So these entire function, it is an important, these entire function will be, so the entire function will be useful for training the discriminator, and as well as training the generator. And also we can update based on the discriminant values. based on the generated images, we can update the parameters. So based on the discriminated, the parameters will be updated. So for that, we have written here. So we are taking training, what is the batch size? So what is the input will be there? Input, it will be an input. So generated fake images. So generated fake images which takes noisy data. Noisy data. In the previous, we have directly taken the noisy data with a value. But here, the noisy data we have taken with a images, batch size, 64 batch size. So, and initially, the dimensionality will be 100. We have taken that noisy data. Training is required, true. And label for real images and label for the fake images. And now train the discriminator. So we can train the discriminator to classifying the real images, to train the discriminator to classifying the generated images. So we have considered the lossy value for real images and lossy value for fake images. And after that, we can update the parameters based on the loss value. We can update the parameters. This will be for, this is not yet there in the earlier code. We are not yet updating any parameters for the discriminator. We are not yet updating any parameters for the generator. Now we can add it based on the loss values. We can combine the loss value and we can update the parameters using the back propagation algorithm. Internally, the mathematical logic is back propagation, and we can train the generated images, train the generator by taking a value, noisy value as an input, and we can find the lossy value by considering the real labels, and as well as whatever the output will be generated by the discriminator, whatever there is an interaction, whatever the lossy, what is the output will be generated by the discriminator. Based on that, it will calculate the values and update the parameters. So these two are updation of parameters and training them based on the data, train the parameters. And now we can save the images based on the epochs, whatever the images will be generated, that will be saved. So all these are functions only. We did not call these functions earlier. It will be for loading, it will be for generator, it will be for a discriminator, initialize the models. We have calculated the values and it will be a training setup only. We have defined a function, saving images, train the loop based on the epochs, whatever the data we have supplied, it will be iterated. It will be iterated multiple times. It will be iterated multiple times. Training loop. So we have taken the generator data, 10 images, and images will be calculated, and the discriminator will be verified. And finally, the data loss and everything will be generated. So number of epochs we have given 10, data set we can pass. So if we clearly observe this, in the epoch 1, based on the data. So these are the images generated by the generator. These are the images generated by the generator, handwritten images only in the epoch 1. And here the discriminator loss and generator loss will be there. And in the epoch 2, these are the images. In the earlier example, the images are randomly displayed. There is no training. But here the images are based on the data set, based on the input, based on the updations. The images will be like in the epoch 1, it is not yet proper, but maybe some digits like 0. In the epoch 2 also, not that much more clarity. Coming to the epoch 3, maybe it will be considered as a 4. It is 3. Remaining are not proper. 4, 3, epoch 5, epoch 6, epoch 7, 8. When we are coming to the 8th epoch, 4, 3, 0, 9, 1, 0, 8. Epoch 10, 4, 7, 4, 1, 0. So I have given actually only 10 epochs, but the minimum for these handwritten digit, it is better to give at least 50 epochs. So surely we will get a good output for at 50th epoch. In 50 iterations, based on the updations, it will generate all these are images generated by the generator, fake images. The discriminator will evaluate what is the loss function and as well as generator loss and discriminator loss. So always the goal is maximize the discriminator loss and minimize the generator loss. Minimize the generator loss. Generator loss is minimum means the images are good. Always maximize the discriminator loss when we are going to the equation. The discriminator loss will be maximized and the generator loss will be minimized. I will be execute again step by step. We may check it how the output will be created. So these are the packages for the PyTorch also. If in advance, we can use that PyTorch also. So our goal is the generator goal is training the goal for the generator is to maximize the probability of discriminator making a mistake. So the main goal of generator is to maximize the probability of discriminator making a mistakes. That meaning is even generator generates a fake images that will be considered as a real images by the discriminator. That is the main goal of generator. What is the main goal of discriminator? The main training goal for the discriminator is to maximize the probability of identifying real versus fake images correctly. So the main goal of discriminatory, so to maximize the probability of identifying whatever the real images will be there, so we need to identify correctly. Whatever the fake images will be there, that will be identified correctly. That is the goal of discriminator. And discriminator and generator evaluation metrics will be identified with the help of discriminator loss and generator loss. We have imported the relevant packages. We imported the data set, shuffling the data set, build the generator, build the discriminator, initialized models, initialize the hyperparameters. We train the setup. The values will be we have executed the training data set. We have executed from this statement onwards, the number of epochs are 10. We are passing the data set and epochs. It will be go to the data set and epochs. And now random input will be given. So the training will be there, which takes some time. So meanwhile, once I would like to recap these, because now we have some clarity how it will be executed. So whenever we have a requirement like to improve the image quality or to generate new images, or we can generate a face generation deep fake, or creating a new sounds, or image generation from the scratch, or text generation, whatever the applications we have, we require. For that, we can use the generative adversary network. So these network which have, it will be purely based on the deep learning network, convolution based network. Based on your application, you may add the convolutions, or purely you may go to the deep neural networks also. So identifies the patterns in the input data and enabling the model to produce generator and discriminator. With the help of that, it will produce the new samples which are feasible and resemble like the original, which have mainly two components, which are generator, always create images, discriminator learns to tell real images apart from the fake. So the main role of discriminator is generates a fake images. The main role of that will be role of generator, and the main role of discriminator is division. So we have a generator and discriminator, which is general words, artist and art critic person. So is it possible to generate a good image, accurate image in the first attempt? No, it is not yet possible. So we need to improve. The generative performance will be improved in the based on the number of trainings and updation of parameters, weights. So for that, more number of iterations will be required. So it will be sample examples we have seen. In the earlier also, we did not get the digits properly. So later on, the current example shows the digit in the proper manner by applying the training and applying the weights updations. So it is the first attempts, after few attempts, after certain attempts. Here also there may be a problem like in the tail face part, okay, but in the back side maybe not it good. So some more iterations will be required. So how it will be? What is an architecture? What type of input we need to supply? What is the output will be generated? The input we need to initially supply to the generator network is random noise, and later with the random noise and the discriminators feedback, it will update the weights, because discriminator which takes the image as an input, based on those parameters and loss values, it will adjust the parameters. So it takes the initial data as a vector and which generates a image. Those images will be considered as an input to the discriminator. It will be considered as a either a real or fake. The evaluation parameters are discriminator loss, generator loss, discriminator accuracy, generator accuracy. So when we want to design any applications, we have we require a GAN. First, we need to define a proper architecture. Then we need to train it. We need to train the discriminator. We need to train the generator. And not in the single step, we can train the generator and train the discriminator in the multiple epochs. And once if you feel that the metrics are good, then we can save the model, save the images. Those images will be applicable for the improving our model performance. So generator is actually an unsupervised learning concept which does not require any data. Any labels will be required, and discriminator which will be comes as a combination of actually it is a supervised binary classification which requires a label data for the discrimination. So it will be the mathematical format will be on a random noisy data when we are applying the generator logic which gives an image. Discriminator, whatever the data it is image it is taking, the probability of identifying whether is it real or fake. What is the main goal? The goal is always the discriminate generator goal is minimize the generator loss by producing realistic images. Minimize the generator loss. What is the discriminator? It is maximize its loss by correctly identifying the fake images. So for that, we have, now we may see that these are not an existed images. We are not yet fetching from anywhere. These are the images generated from the, based on the, our generator logic and based on the discriminator parameters we have used, training we have given. It is generating these. Even here also, in epoch 5, I correctly identified 8, 5, 7, 3, remaining not yet identified properly. So this is the way for applying the generators and as well as discriminators for producing the new images. It takes some time to produce. So actually, when we are working in some applications like my research area, we would like to, we are working on the environmental related microplastic classification and health related also. So for that, actually we are applying the microplastics classification categories like in our areas, not only in our areas, currently there will be more plastics usage will be there, and not only plastics, those plastics again split into the microplastics, and from the statistics, from the analysis, those microplastics also in the form of like when we are taking any water or food, we are pouring the microplastics in the environment that will be moving towards the soil or rivers like that in the water. We are without knowing that we are taking those waters, even in the bottles also, we are taking the water that will be indirectly injected in our health, in our blood also, from the environmental related uh, analysis. We found that in our body also, blood samples also, there will be very uh, mm, minor plastics will be there. Even maybe currently it will not be harm, but maybe we don't know whether it will be harm or not. So for the treatment, we have considered we are taking some samples, we are collecting some samples, and we are working on that. But we did not get in the data sets also in our current repositories like Kaggle or UCA or some other repositories. We are not yet getting the data properly because that will be that type of research are somewhat less, and we did not get the proper data. We got the data like a fiber and fragment. We got some data, but for the bead, we did not get any data. Only 6 to 7 samples only we got. For that, we are trying to the performance of the fiber and fragment. We applied so many models like we trained the models. We have applied our own architectures, and we have applied an architecture like efficient net, Inception V3, ResNet 101, MobileNet V3. So these architectures we have applied, which gives the good accuracy also, 80%, 90%. It is giving the good accuracy. But coming to the particular metric like bead, it is not yet, if we are considering the individual accuracy, it is not yet giving the proper precision or recall or something related to the bead, because the samples are very less. Now we are continuing the work with the generative GAN approach. We are trying now. We are trying to increase the samples of bead from 8 samples to 20 samples or 30 samples. We are trying to improve those samples for the better identification. So we are including whatever the architectures we have discussed now, we are practically applying those to our models. Even if you have any data like this, if you are having any limited data sets related to our specific research problem like health related or some other stock market or some other language conversion or like this, if you have any limited data sets, this is a GAN approach which will be very useful for generating the increasing the sample size, or even if the quality is not yet good, we can improve that. But we need to GAN itself, defining the architecture or defining the model with the layers itself can't give the accuracy. We need to focus on multiple parameters like what are the optimized parameters we are using, how we are controlling the, how we are generating the random values, how we can control the overfitting, how we can control the underfitting. All these are different variety of things we need to be considered, but which will be very helpful if we have a data properly. We have a good data set. If the data is we are getting the data properly, then there is no worries. But nowadays, lot of so many in our country, in our places, we are facing the problem with data only. We have a good model. We are good with the designing models. We are applying the models, but we are lagging of in certain areas. We are lagging with the data sets. So in those cases, it will be very helpful, which is not only for image generation. In the same related concept, we may apply for the text generation or video or speech, audio, that type of generations also we can use. So here we will be, okay, 5, 3, 7, 3, 6. So these are identified. It will be like real
Hello.
images. Hello. It will be appeared as a real images. For some more epoch, some more training, we will be get some a good quality of images. And madam, from my side, the content and whatever I want to share, it was completed. If any clarification, I will try to give my best. Madam,
Yes, ma'am. We'll just wait for some time, ma'am. If anybody have some queries, they'll ask, or else we'll wind up the session.
okay, madam.
Ma'am, I guess there are no queries to anyone.
Then
I
shall
think we,
madam.
I think we can wind up the session, ma'am.
Okay, madam.
Thank you so much, ma'am, for joining today.
Thank you, madam, for giving out
And to
everything.
all the, thank you so much, ma'am. And also to all the participants, the next session will be starting at 5 o'clock. So please join accordingly. Thank you, madam, once again.
Thank you, madam.
Good evening, everyone. Welcome back to the session. Now we are in the last session, which is the lab session, which will be held by Dr. Joshna Devi Bodapati ma'am. She has already joined us in the previous session. Ma'am, you can take over the lab session, ma'am. Thank you.
Yeah, thank you, Anu. Give me 1 second. I'll share the screen and start the session. Am I audible, Anu?
Yes, ma'am, you're audible.
Yeah, thanks. Is my screen visible?
Yes, ma'am, it is visible.
Yeah, thanks. Yeah, good evening, all the participants. I hope all of you joined. 53. Okay, fine. Shall I start? Is it okay to start now? Do I need to wait for others to join?
Ma'am, you can start the session by 5:05, ma'am.
Yeah. Oh, okay. Yeah. Okay. I'll wait for 2 more minutes then.
Ma'am, you can start the session, ma'am.
Yeah. Yes. As part of this lab session, we will see how to deploy machine learning and the data science models that you have designed. And basically, when we design the models, we develop them either in Jupyter Notebook or in Colab or in Kaggle. But we don't design the web interface, and we need to, right? So you cannot directly show the, or you cannot deploy your model, or you cannot allow your customers to use your model in Jupyter Notebook, right? So you should provide an interface to that so that your customers can use it. So it will be attractive for the customers to use it. So what kind of model it is, that's a different story. So this lecture is not about, designing the models, but still I will show like one like development of one code at least, one model at least, so that that same model can be deployed using Streamlit, using Flask, and of course in cloud also, how do you deploy it using GitHub. I will not be touching upon, cloud resources such as Amazon or Google Cloud, because we need credit card access and all. So it's very sensitive. There is a possibility that, within 2 hours that may not be possible to complete that. So I thought better don't touch that. So now let's see, as part of this session will be, maybe initially I'll explain all the details and then we'll go to the demonstrations of each. 3 different demos I have planned, one for Flask, one for Streamlit. Of course, as part of Streamlit, again, I will give you multiple demonstrations. That's a different story. But at least one demo for Streamlit, one demo for Flask, and one demo for how to launch Streamlit, deploying the model in your GitHub also. So this is a plan for today's session. So the outline of the session is what is model deployment? Let me, for the very beginners who do not have any idea, I'll just discuss what model deployment is, and then what are the tools and frameworks that you can use it. And when you are designing the model, you better save the model. So how do you save the model already, which is trained, so that you need not to run your model again and again? And how to use Flask for model deployment, how to use Streamlit for model deployment, then comparison of these two, which is better, and when to use what, and the live demonstrations like training the model, saving the model, then deploying the model. And at the end, also I included, I'll show you the demonstration of cloud deployment using GitHub. It's not other cloud resources, but GitHub, how to deploy your model without executing and all. Let's see that. So what is model deployment? If you have any doubt, any point in time, please interrupt me so that I'll clarify your doubts right there itself. It's not a regular, theory session, but still I wanted to explain all the details. Then I will go to the demonstration. In between, if we switch back and forth, it's waste of time only, I thought. So I'll give you every detail related to the session, and then I will proceed to the demonstrations. 2 hours is more than sufficient, I feel. Yeah. Deployment means integrating your we design our machine learning models, but we don't launch it as an application as such. So typically what we do is we develop them as second. I'll just show you. So maybe in Colab, I'm like designing this model. And if I would like to predict, I will just pass a sample here and call the predict and all. So this kind of interface, you cannot, use it for your customers, right? So there's a Colab environment I'm using, or Kaggle, or we use our Jupyter Notebook in our desktop and all. But that cannot be, user friendly. And how the user cannot type your commands and execute, that is another story. So that is the problem for your models when you train using these Python environment, different frameworks of Python. So that is where this deployment of the model is important, where you are creating your application. As an application, if you would like to deploy or deliver, this will be helpful for you. And it enables the model, the trained model, to generate predictions or perform specific tasks automatically. That is, once you deploy your model, the customer can use the application any number of times. I just show you what we will be looking at so that you will get some interest. I don't have others, but at least this one. It's taking time. Yeah, see, simple house price predictor, maybe given the size of the house, I'll call predict price. See, that's saying this is the estimated price, and this is the like some chart. What is it? What is the meaning of all these things? I'll discuss later. This kind of web interface. See, in the browser you are running this, and the nice interface. The user can enter. Like whoever. If you share this link, then your customers, then your customers can directly enter the house price and then click on this button, predict price, and then they will get what is estimated price of the house. This is a size of the house in square feet, and maybe in case of the what you call the heart rate prediction, something like that. So in that case also you are entering all the details, and then when you click on the button, whether the diagnose button, then your application need to determine whether the person is having, the patient will be entering all the details, and then he will be getting whether the details, like whether he's having the heart disease or not. So such kind of applications interface you would like to design, then this will be helpful. So that is another idea about it. Yeah, it enables your model to generate predictions or perform specific tasks automatically. Like you need not to run any code right there and then and there. So directly you can use it. So this could, of course, you can even create the APIs also, or you can build your web interfaces. So using these frameworks, so that is how it is useful. And the purpose is to make your model operational and accessible to your end users. So you are designing a machine learning model means, unless it is for some academic research, even for that also, if you like to demonstrate for your project, like project expo kind of, if you are a student and if you would like to give a demonstration for your project expo and all, then you cannot show it in a Jupyter notebook or something. So you have to build up as an interface, then web interface basically. So then that would attract many end users. So that is where it is. That is one of the purpose of the building up, deploying its model, and facilitates real-time decision making. And based on the test inputs you are giving, you are entering like the house price, and then you are getting the decision. So that is how it will be useful. And where do we use it? This kind of applications means what kind of applications you will deploy any machine learning model or your data science, like data science application you are designing, that can be launched as an application, as a web application, or as a mobile application, or as a cloud platform. In the cloud platform you can launch it. So you can use it for healthcare, you can use it for finance applications, retail or real estate, or healthcare applications. So in healthcare, maybe you can use it for patient risk analysis or heart disease prediction analysis. And maybe you can, in finance, you can use it for fraud detection systems. In retail, you can use it for personalized recommendations to get the recommendations. And in real estate, you can use it for house price predictions, I just have shown. And I will be, demonstrating heart disease prediction and also the house price prediction. These two case studies, I'll show you how to, develop the applications. And the model deployment, if you consider like a few case studies, if you look at maybe a scenario, I'm just giving you one scenario. Healthcare company have developed a model which predicts the patient readmission risk, say for example. So after the patient has discharged, then what is the chance that the person is going to be readmitted into the hospital? So then what do we do? So we deploy the model. So the model is, we already trained a model, and it is integrated into the existing, like already we have a web application, like electronic health record system the hospital is managing, but we would like to integrate our machine learning model as part of that. Then how do we do that? So the one good example is you can use Flask, and then you can you can design the web pages related to that, and you can integrate your machine learning model code. You can load your model and you can integrate that, and you can make it as a part of the existing system. That is one thing you can do. Or otherwise, directly as a straight away, you can create your own application. So the application is not available, but still you would like to design from scratch. You can design that. Streamlit is sufficient, like for simple applications, of course. And if it is already existing, maybe the hospital is already maintaining a health electronic health record system, then you would like to design such kind of application, you would like to launch one web page which will find the readmission risk of a patient. And of course, that can be integrated as part of the existing website. So that can be done. And what is the outcome? So real-time analysis of the patients is possible if you deploy this kind of models as part of the existing systems, or if you design a new system. So this is the case study that maybe you can consider as a simple scenario where you can use it. And what are the different stages involved in the machine learning model deployment is, first of all, you need to train a machine learning model. So unless you have a machine learning model, I hope all of you have some understanding or the basic familiarity with the machine learning model. So, and I'll also take very simple example only using scikit-learn. So because this is not about the machine learning model, nothing to do with machine learning model development, but if you have already the model, how do you, deploy the model? So I will just take a simple example. And the first stage is we need to first train the machine learning model. And once you train the machine learning model, whether it's a deep learning model or the machine learning model, that's a different story. Anything is fine, but I'll tell you the differences. Like if it is a machine learning model, what kind of how do you deal with that? And if it is a deep learning model, then how do you deal with that? What are the differences? I'll give some insights about that also. But the first stage is training the model. Then once you train the model, you need to save the model. So the reason is, once you save the model, you need not to iteratively train your model. Say, for example, a real-time application, if you design with large amounts of data, the model training will take, maybe in some cases, if it is a complex task, if your data is huge, then it might take weeks also for training the machine learning model. So you cannot afford to, train your model every time you are going to use your model, isn't it? That is where you better save your model. So once you train your trained model, then every time you would like to use your model, then directly you can load your existing model, which is already saved in the second stage, and then you can use the model directly. So that is where the saving of the model will be helpful. So train the model, then save the model, and then install the required libraries, and then whatever you are going to do. So this is the third stage. I'll show you either Flask or Django or Streamlit you can use, and then create the applications. And or if it is already existing, you just enhance it. If it is not available, then maybe you can create from scratch. So these are the 4 different stages that you can follow for the deployment of a simple machine learning model. Yeah, if you look at this different stages of your machine learning model. So deployment of the machine learning model, of course. Yeah, the first stage starts with data collection. Just as a review I'm giving, I'll not go into the details of it. For those who do not have the idea, maybe it will be useful. That's how I've included initial details. Yeah, so you just collect your data and the data set is available. Then you do the pre-processing of the data, like imputation, data imputation, or whatever the sort of pre-processing techniques that you would like to apply, you just apply them. And after doing this data processing and analysis, you do the model selection, like you choose the suitable model for your application, whether it's a deep neural network model or SVM or any other model like KNN or whatever. So you choose the model and train it. And if you are okay with the performance of your model on the test data or the validation data typically, so if the model is doing good on the validation data, then so you report your results and proceed with the model deployment. That is not the case. So where this model deployment exactly fits in your machine learning pipeline, that's what I'm trying to explain here. Yeah. So you collected your data, you are doing all the pre-processing stuff, and then analyzed the data, and you did all the exploratory data analysis and all. Now you understood about the data, then feature selection, feature extraction, or whatever. So it is done. Then you selected your model and you started training your model, and then you applied on the validation data. So if you are happy with the model performance on the validation data, then you can go ahead and deploy it. Otherwise, then what do you need to do? You have to tune your parameters, or maybe if it is underfitting, then maybe you need to increase the complexity of the model. If it is overfitting, maybe the techniques that are useful for handling the overfitting of the model that you need to use. So somehow you try to, enhance the performance of the model depending on the present conditions of your model. Then again, train the model and apply it on the validation data. If you are happy, then proceed with deployment. And this cycle, like continuously, you have to iterate through this cycle as long as your model is not satisfactory. Once it is like good and it is on par with the real-time data or on par with your expectations, then you can proceed for the model deployment. So then the end you can deliver it to the end user. You can give the access of the model to the end user. End user will be using. maybe that data, whichever the user is entering and the predictions, that you can again add it to your data set, or like you can augment your data set or whatever the things that you would like to do. So this is about the typical, pipeline of the machine learning model or the deep learning model, and even data science model also, of course. So this is the, model deploy. This is where the model deployment stage comes. So prior to this, you need to do all these stages. You need to have the data, you need to do all the pre-processing, and then you need to train the model, then evaluate the model, and then finally comes the deployment before you give it to the end user. Once you deploy it, you can give the access of the model to the end user, right? So this is how you will be doing it. Yeah, let me go to the saving a trained model. Let me show you. Before you start saving, we should understand how to train the model, right? For those who do not have any idea, I'll just quickly go through it. I have taken one simple example for the sake of understanding of the beginners. Yes. Those who already have experience, I need not to explain that. So here, this is about the house price prediction, which is the very basic, simple example so that everyone can understand. And I'm using a very simple model, the logistic regression model only. And I just imported all the required libraries, like the data set is available here in this link in my drive. So I just loaded it, and then it is in the data frame, loaded into the data frame. And then I have imported the logistic regression class from the scikit-learn's linear model. And then I would like to divide the data into trained test splits. So I have imported scikit-learn model selection package. I have imported this method also. So, and of course, I would like to apply some pandas library function. So I have imported that also. Yeah. So I just displayed the data. I just visualized the data. You can see the tabular form, and these are all the different, attributes like age, gender, CP, test TBPS, cholesterol, FBS, so on and so forth. You have different, right? Yeah. And the last, you can see the target. So when you look at the target itself, you can see, 0, 1, and we all are much familiar with this data set, right? So this is about the classification, right? So either the person is having heart disease or not. So it's a classification data set. It's two-class binary class problem. And then I just wanted to separate my train data, test data. So you just do whatever you would like to. So it's just like simple pandas functions you can use. Separate your features and the target values. Then you call the train test split method, pass your train data with the features, and then the target is the labels. And I would like to split the data into 20%, 80%, like 80% for training and 20% for testing. So that's for like validation data basically. So I'm splitting that way. And then this method returns the train features of the train data, then features of the test data. Here you can see labels of the train data and the labels of the test data. I hope you can see my pointer, the mouse pointer, and I hope you are able to follow it. If you feel any difficulty, please let me know. So now we would like to apply now the data is ready. And on the data, I would like to apply the logistic regression model. So just for the sake of simplicity. So the logistic regression object, the class object I'm creating. So LR is the logistic regression class object. Then once you have the model object, what you can do is you just need to train the model. For model training, we are calling the fit method. So fit method will do the training. And for that, we need to pass the train and the features and the labels we are passing. Then it's like you can observe it's trained. Then you can see. Yeah. So I would like to test the model. How is it doing on the validation data? So I'm passing the validation data without the labels. Then I get the prediction values, prediction probability values, or the class labels I get. Then I check the mean square error. It's not mean square error is not required actually in this case. Yeah, accuracy score, because it's a classification task. So the accuracy score I am computing using the method from scikit-learn metrics. I have imported here. Then calling the accuracy score method by comparing your test, the ground truth and the predicted values. So these are the labels predicted by the model, that is Y predict, and the Y test is a ground truth. So by comparing this, we'll get the accuracy, and here you can see it's 78. I'm not happy, so I'll be changing my model parameters, and then I do the I improve the model. I assume that I have done everything. Okay, I leave that to you. Then we are going to save our model. Okay, because what happens is when you start training your model, it might take, depending on the complexity of your model, it might take days or weeks or even months also. Right. So every time we give, say, for example, I'm giving this kind of model for this customer in the form of this interface. If I deliver this and every time it is taking days, means the customer cannot wait for days, and there's no point making him wait also. That is where you better save your model, the trained model. Once you save the model, you can load the model, and then you can allow the users to make use of the model. And for that, we are using Pickle. And model training is done, right? Where is the model object? Model object is in LR. Okay. And then we will be saving the model. So we will be saving the model. And you just go through this code. I'll explain like all the techniques of what are the different ways of saving the model and all. So what we are doing is we are using Pickle. So Pickle is one approach, one library, which allows you to save your Python, especially the scikit-learn, the conventional machine learning models, which are trained. If you would like to store, Pickle is a better library. So you just import Pickle and you can call pickle.dump, and the model name you have to give. And once you give the model, the second argument must be your file name. You are going to save your model, right? And for that, you have to open your model and then you have to save your model. You have to pass your model name, which you already trained. And here, what is the model name we are giving? Hard disk model.pkl. Here, .pkl stands for pickle. So that file name we are passing, and that file name we are not simply passing it. We are calling open a file name comma wb. Means here you are writing the file in the form of the byte stream. You are writing your model, and this is W stands for the write mode. So the mode in which you are opening the file. So the meaning of this command is you open the file hard disk model.pkl model in the write mode, and you write this file, the model LR, in that file hard disk model in the in terms of the byte streams. So that is the job done by the dump method, and these are the different arguments you are passing to it. So this is how you can save your model. So this is the model for the hard disease prediction. This is for the classification. Let me show you one model for the regression task also. So that is for the prediction of the continuous value. So regression, the simple linear regression I have taken, and for the house price prediction only we are doing. So here you can observe. Yeah. So here you can observe, we are just importing the linear regression class and remaining all the same. And this California housing dataset is part of your scikit-learn datasets. And from there itself, you can, import the datasets, scikit-learn datasets import, fetch California housing. So now once you have the dataset and you store that dataset in your housing object, just create an object of that. So that will load your dataset. And once you have that, you separate your features and also the labels. Here you can see these are all the different features related to the house. Of course, it's having latitude, longitude, average occupancy, population, average bedrooms. All these are different details related to the and how old is the house is. All the details are available. And you can see the Y values, the labels, or the predicted, the target values. The target values are continuous, so I cannot use any classification algorithms, right? We need to use a regression because it's a continuous value, the value to be predicted. So now we are calling the linear regression. You are creating the linear regression object. Of course, we already have the split of the train, test, everything is available. Then the linear regression class object we are creating. Simple. I'm not making the stuff complex. It's very, very simple. I just want every one of you to understand it. And you can create like any complex model the same way. And we are passing the X train and Y train by calling the fit method so that the model will be trained. Once it is like trained, then we are calling the predict method. So it's by passing your test data sets, you can call the predict. So you'll be getting the predicted values, and that we are storing here. And because it's the regression model, you need to use the metrics as the R square or RMSE or any MSE, anything you can use. And here we would like to use the MSE value, and the MSE value is applied on like by comparing your y-test and y-predict. The mean square error we are comparing, and here it's 0.5. I'm happy with that model performance. I'm happy. If I'm not, then I need to change it. Then once the model is trained, what do we need to do? We need to save the file again. So I'm using Pickle library, and I would like to. So the first one is a heart disease prediction. And here I'm saving the house price model dot pickle, house price model dot pickle. So the model will be saved in this file, which is having the .pkl as the .pkl is the pickle file name, and of course in write mode. So that is how you can save it. So far we have seen how to save the model and how to train the model and how to save the model. Let me go into the details of saving the trained models. I hope that is clear so far. So we have seen in this process, of course, data collection, we are already taking like data from which is available in sklearn. But if it is in real time, you need to do all those things. And the data engineering process also, I'm leaving it to you. So model training, a simple model we have chosen, and then we have done the what you call the training of the model, and the model deployment is the stage we need to, and we need to save in between, right? I have shown a saving also, but further details about the saving. So why we are using pickle? Is it pickle for every type of model? Is it suitable or not? That details I'll now give you. So when you are saving your machine learning model, there are 3 different libraries that I suggest you. One is a pickle, joblib, and keras. When you are using pickle, means it's a data, if the model is small, and if it is conventional machine learning model, then you can go with pickle. But there is a version compatibility problem. If you say, for example, I'm using Python so-and-so or pickle so-and-so version, and you saved it, and with the same version only you have to open, otherwise this will not be opened. That is the biggest problem with this pickle file. And joblib, when you are working with that, when you are working with moderately complex problems, models, then you can prefer joblib. I'll explain more details about it now. And keras is another library which can be used for saving your models, especially the deep learning models. So if you have, trained any of the deep neural network models, then you can prefer using the keras library. So once your machine learning model is trained, you can save it, so that you need not to, train every time your customer is using the model. So to avoid the retraining of the model, you are saving the model. And these are the different libraries that support your saving and model, loading the model. Once you save it, later you have to load the model also, right? So these are the 3 different libraries that can be used for it. Now, let's see when to use pickle or how to use pickle. And I have shown the commands, right? How to save the model. Then once you save it, then how do you load it? Let me give more details about each of these libraries now. So let me start with pickle itself. So pickle is the Python module which allows you the serialization and deserialization of the Python objects. Say, for example, I have a Python object or Python model object, basically. You can store any object, basically, using pickle. You can store a list or dictionary or any other Python object, even a single integer also you can store. But here we are using for saving the models itself, the model weights. Model means model weights only, right? Yeah, so to parameters of the model, we can store using the pickle. And this pickling, serialization, deserialization means they can be called as a pickling. So basically, serialization means saving, and deserialization means already saved, you are loading into your Python environment, back to your Python environment. So that is what the deserialization is. Serialization and deserialization. So pickling and unpickling, both are the same. So pickling is also known as a serialization. Unpickling is also known as a deserialization. So what is this pickling? Pickling is converting a Python object to a byte string. So you are converting when you are writing your file. So that is why when I have shown here, you can see WB, right? The byte string. B stands for the byte string. So when you are storing your Python object to a byte string, right, as byte, in terms of bytes, if you would like to write, then you can use the pickle. So that is pickling. That process is called as pickling. Then what is unpickling? Already I have saved. So here we have already saved the file, right? Say for example, in this house price model.pkl, I have trained today and I have stored this model. Then later, after 10 days, I wanted to test for one of the customer, I would like to make use of it. Then how can I use that? You have to load this existing model and then you can use it directly for the prediction task. Yeah. So now let's see how do we install. It's a library, Python library only. It's open source, of course. Then how do you install it? You can install this library using the pip install pickle. Pip install pickle is the command you can use. So this command can be executed either on the command prompt or by prepending a not symbol. You can even run it using the Jupyter notebook also. So this is how you can install any of the library. You can say simply pip install the library name. So here pickle is library. So you are using pip install pickle. Then once you install, nothing will happen. Just your library is installed. But how do you load it to your Python environment is you have to call import pickle. So then only you can say like pickle.dump, pickle.load, everything can be done. So all the library functions can be used only once you import it. So how do you import pickle library? You can say import pickle. Now, let's see what is serialization and deserialization. Of course, serialization we understood saving. Deserialization is loading the model. Then how do you do that using pickle is, so you are importing pickle. So import pickle and file name equal to model.pkl. So you are importing pickle and your file name is model.pickle. I just have shown, right? Pickle.dump is the file name you have to function name you have to use. Dump is the function name which helps you to save the model. And what are the arguments you need to pass? Model is the first argument. This model must be a trained model, already a trained model. And you have to open the file and then you have to pass the file name here. So open a file name. What is your file name? You can include that here, and WB is the mode because you would like to write in terms of the byte streams. Then once you say, for example, I have stored this model and I would like to later load the model. Then how do I do that? So you can call load method of pickle.load. So pickle.load of open of, you need to open the file, right, to read it from the pickle. So file name, what is the file name? You already have the file name object, so that you are passing, comma, now it is read mode. So you need to pass the argument as read binary string, RB. So now in the read mode, you are opening the file, the loading the file. Then the loaded model object will be getting that loaded, whatever is loaded. So this is how you can save the model and load the existing model. That is done now. Pickle is like how to use pickle, we have seen. And there are some pros and cons of this pickle. Let's quickly see what are they. So it is simple and easy to use for any Python objects, either it is a list or dictionary or a model, machine learning model, you can use it. And it is widely used with the machine learning libraries. As I already told you, if you are designing any model, training any model using scikit-learn, like something like KNN or your decision tree, something like that. If you are using that, then you can use ROS. Okay, then you can use the pickle. And then what are the limitations or what are the cons of this pickle library is there is a security risk because when you are loading along with that, it can load the untrusted pickle files also. That is the problem with the pickle library, and it is not very efficient for large data sets also. Say, for example, you are designing large and complex models like deep learning models and all. Then this is not a good item. Like you better don't use pickle, and it's Python specific only, and it may not work cross platform. So it's not like platform independent also. So these are the limitations of pickle library. So that is where we will be using the other library, joblib. So joblib is an alternate to the pickle library. So of course, it also supports the serialization and deserialization of the Python objects. You can save the Python objects, you can load the Python objects, and it is optimized for the large models and data sets. So you can store large models also, not like pickle. Pickle means only small sized trained models you can use, and even models even with data sets which is large in size, that also can be stored. And the key features here is it is efficient for large numerical data. So when you are storing NumPy arrays or sparse matrices, then it is very much efficient. So this is one feature, and it is faster and more memory efficient than Pickle for your large ML model. When you are using, when you would like to store large ML models, then this is more efficient. And of course, it also supports, it comes with compression also, so it saves your disk space. So this is about the joblib. But how to use joblib is, so for saving a model in joblib, first of all, you have to import. I'm not showing here installation, because it's simply pip install joblib, that will do. So now saving the model, again the dump method only, but you need to import it, the dump method from joblib. From joblib import dump. So now you can similarly, here you can say dump of model. Now you need not to open the file and all. Simply you can say the file name here, model.joblib. Right? And here you need to observe PKL is the extension for pickle file, and joblib is the extension for the joblib. Now it's saving. Once you saved it, then how do I load it? The same is simply you can say load. So and this method need to be imported before you use it from joblib import load. So now you can import, once you load it, you can call the load method by passing the model name so that it will be loaded. Then you can use it for your predictions. So this is how you can save your model and you can load your model in joblib. And the next type is the Keras. Keras is another interesting library which can be, widely used for saving and loading models. And the process is also very straightforward. And especially when you are using deep learning models, this is very much useful, efficient also. And you can store, model weights and also architecture if you would like to store. Say, for example, I have developed my own object detection model rather than using the existing YOLO. I would like to save that model also. Not only the model parameters, I would like to save the architecture. That is also possible with the help of the Keras. That's the beauty of Keras. So you can, it provides various functions to save model weights and also the architecture along with weights and optimizer state. So that is what you can do it. Let me show you what are the different methods that suppose this. So if you would like to store the entire model along with architecture, weights, and optimizer state, then you can call simply model.save. Of course, you have to import it. So install, I am not showing it because it's straightforward. Pip install Keras you can do. So then you have to import model. Then from Keras, you have to import. And then you can call model.save. So once you save the model, it's like model name.hy. So you're saving the model. So once you save the model, here you need to observe H5 is the extension. So here H5 indicates HDF5 file format, and that should be the file name when you are saving the model using the Keras. And not only the model, it's like architecture weights and optimizer state. Everything will be saved when you are calling save method. And if you would like to save model weights alone, then you should say model not save weights. So saving weights, save underscore weights will save your model weights alone, not like it doesn't include any architecture or the optimizer state. The same way you have to pass your model name with the .h5 extension. So this is about Keras saving the model. Now I have saved my model, then how do I load it? So you can load again. We have seen how to save the model weights alone and model weights along with the architecture. So there are two different functions for loading the model also, right? In that case, so you have load model. The load model is the method that is part of your from keras.models import load model. This is what you can use. And similarly for saving also, you need to actually import it. Yeah. So now load model. So load model will load the existing model which is already saved. And similarly, load weights is the method which allows you to load the weights of the model. So I would like to load the weights of the model. So I can say load underscore weights, the model underscore weights.h5. So now this is how you can load the weights of the model. I have shown you how to use Pickle, already shown you the demonstration how to save the model. And Pickle you can use, when to use Pickle, when to use joblib, when to use Keras. So if you have a conventional machine learning model which is already trained, then better to use Pickle, but it is having compatibility with the versions problem. And also if it is a large data set or the large model, then it is not suitable and there is no compression while saving. So it occupies large memory. Those are the problems with Pickle, and the extension is .pkl. And that is where joblib can be used, of course, with storing any type of Python objects, especially useful for large objects. And the extension is .joblib, and you can use it for storing your large models, the complex models also you can store it, and it does with the along with the spacing, like compression, so that it will be doing the saving in an efficient manner. Then comes the Keras. Keras is like it is much useful when you are storing your deep learning models. Okay. Then what are different formats? I have shown you here .h5, right? And here joblib, and here I have shown Pickle. Then what to use when? Can I use Pickle with Keras, or like how to use that? Let's have a look at that briefly. So the format you can use is a Pickle or joblib, Keras. This means H5 you can use, and HDF5 you can have. .keras also, of course, you can have JSON or YAML format, PyTorch format, protobuf. These are the different formats you can store your models. Then what is best for what? These are different libraries basically. So then what is best for what? So if you would like to store Python models and the small machine learning, conventional machine learning models like KNNs or regression, simple linear regression or the logistic regression, then Pickle is fine. And it is related to the Python scikit-learn. Right? For ML also, the conventional machine learning models are also part of scikit-learn. And if you are storing large ML models, large NumPy libraries and all, then it's joblib. And if it is deep learning models, it's Keras. And if you're storing large data sets and Keras or TensorFlow models, then HDF format is very good. Of course, in Keras, .h5 or even also is possible. And then I'm using JSON or YAML. If you are storing the data sets or Keras models, then you can use H5 format. And PyTorch can also be used to store the models, and it can be used with .pk or .pth format. These are not formats, these are the libraries basically. And specific to the PyTorch models, you can use these file extensions. And protobuf also can be used for TensorFlow model deployment. And when you are using TensorFlow model deployment, you can use protobuf. So this is about different types of libraries that support and the model file formats that can be used. And hello, what happened? So if you would like to use Pickle and joblib, traditional machine learning models, if it is Keras like HDF5 or JSON or YAML, stop. It's my screen. What happened? Hello?
Ma'am, your screen is not visible.
Now, can you see there was some problem? Suddenly, somehow it was showing screen sharing stopped. Again, I will share. Is it visible now?
Now,
I'm getting the message you are sharing. Yeah, thank you. Protobuf and PyTorch are specialized formats for the TensorFlow. So this is briefly about the different formats which you can use when you are saving your models. So let me show you the deployment framework. So we have seen like how to train the models, how to save the models, what are the different file formats that can be used, and what is better with what. And now I would like to I have trained my model. I have saved it also. That's available. I have loaded my model also. But which framework I need to use? Whether I need to use Streamlit or any other format, that is what I need to know, right? Yeah. So typically these are the stages when you are deploying your model, training a machine learning model. We are done with this. Saving is done, and then we need to choose which framework is better for my application or for my conditions. So these two things we need to do. So once we choose the perfect framework, then we can install and then we can create our education. Yeah. So these are the popular tools and frameworks that are, helpful for ML model deployment. Of course, I'll not be touching upon everything. I'll give overview of the few frameworks, and I will explain in detail the demonstrations about Streamlit and Flask. Yeah. So Flask, Fast API, Django, Streamlit, Flask, RESTful, TensorFlow serving, serve, MLflow. These are the different Docker, Kubernetes, and industry is using very well this widely using Kubernetes and Seldon Core, Google AI or Google AI platform or Vertex AI you can use, and GitHub you can use, AWS SageMaker you can use, Azure ML you can use, any of the Amazon cloud you can use, AWS. Yeah, this one, right? Yeah. So any of these cloud services or the other frameworks you can use. These are the different tools and frameworks that are, widely used for deploying your models. So let me talk about, introduce few of these frameworks, then we'll jump into the frameworks. Okay. Yeah, I think it will take another 10 minutes. Streamlit, if you consider Streamlit, so it's a framework. It's a web framework for data science applications or the machine learning applications. And for what it is best is to create your interactive data visualizations or dashboards if you want to create, and if you would like to give any machine learning demo. So then Streamlit is a good option. So I don't have any existing application basically for my machine learning. I'm going to give it as a startup or my own, like from the scratch. I would like to develop a web page for my machine learning model visualization or for my machine learning model deployment. So then Streamlit is a good one for you. So you need not to have any experience with the existing HTML or JavaScript or CSS, or nothing is required. So directly on the go, you can start from scratch and you can develop the interfaces for your machine learning models. So that is where Streamlit is useful. And what are the features? Basically, it focuses on rapid prototyping. Like quickly, you can wrap it up and start from scratch, wrap it up quickly, and then you can design it. And for prototype applications and visualizations, it is useful. Of course, it is easy, and it provides interactive elements like buttons and all, colors, color codes and all. So that's how it is good. And it's great for sharing data exploration and model results also. So you can share your model results, like whatever the model result you are getting, and building a dashboard to explore data or to showcase your predictions or simple interfaces. I'm telling you, it's simple, and also to create simple applications only, the Streamlit is preferred. Yeah. The next kind of framework is a Flask. These are like very widely used. This is a micro framework basically, and for smaller projects and to create the APIs, microservices. And when you need flexibility and control, then you can go with Flask. And Flask is you should have like existing HTML knowledge also, because say for example, if you already have a web application and you would like to add this your ML model as integrate as part of the existing application, then I suggest using Flask. And if you'd like to have the database connection, that also is possible with Flask, but with Streamlit, it's not possible. And the features are minimalistic and easy to learn, highly extensible with many third-party libraries, and great for building RESTful APIs and all. And building a simple web application with few web pages, not like very like Amazon and all, or Facebook kind of. So that kind of web applications, it's not possible. For that kind of applications, we have Django. Actually, Django is another framework. It's like full-fledged from like a complex design is complex, of course, and you can design any complex web application, web interface, or website itself. You can design similar to your Amazon or Facebook or whatever. Yeah. So now let's see the Fast API, another framework. It's like modern and high performance, as the name suggests, no, Fast API. So it's a high performance framework, and it is for the APIs to design APIs or to deliver microservices. When you need speed and efficiency, then Fast API is the go. So it's a better option. And what are the features? So you can build speed and asynchronous programming, then you can prefer it. And automatic API documentation generation is possible with the Open API, and strong data validation and type hints. So these are the features of Fast API, and creating high performance API for data intensive application. So when your data is huge and you are expecting high performance APIs, then you can use Fast API. Django. So Zango is another framework. It's a full-fledged framework. It offers like several services, and for large complex project, if you would like to design, and Zango is a tool for you. And when you need built-in features and structure, and you are designing full-fledged website for your college or for your startup, then Zango is the best option for you. And the features are like batteries included approach with built-in ORM, authentication and admin panel, etc. So it's having like a lot of features so that you can extend it for your web application development. And it promotes like compared to the other web frameworks, this is the Python framework basically, and rapid development is possible with the help of the Zango. And it can be scalable to any enterprise level application also. I told you, right? For like kind of Amazon kind of applications, like websites also are possible with this kind of Zango. So now maybe any social networking site or any WhatsApp kind of, or Amazon kind of, or Flipkart kind of, you can use Zango. And what to use when, basically. So I have shown several, and among them I have chosen very few which are widely used and for different, not like widely used alone, which are used for different purposes I have shown. Right? Yeah. Now let me give a summary of when to use what. So Zango, when you would like to, do the full stack web development or enterprise grade application development, like full-fledged website, then Zango is a robust platform. It provides you backend management, everything. So that's how Zango is the option. And if you're like moderately complex application and high performance APIs or microservices, you can go with Fast API. And if you would like to design customization of the existing web application or a moderate kind of application, if you would like to design with the database support and all, you can go for Flask. And Streamlit is the one which can be used like on-the-go dashboards or interactive applications with minimal effort. Then Streamlit is the option. So this is about different frameworks which can be used. So Flask and Streamlit, I have chosen only these two. Why? Because I'll tell you that also. So like the time is less, that is one thing. And also, so Flask provides robust backend support for building REST APIs to serve predictions. That is one thing. You can use Flask. And you can use Streamlit for designing user-friendly applications, especially useful for data scientists. Like you are a data science or machine learning expert, you would like to deploy your model quickly for your machine learning model, then Streamlit is option. So that's the difference between these two, and you can see many differences here. So type of framework is Flask is web framework. Streamlit is only data application framework. So if you would like to have a simple interface for your data science or ML frameworks or interface for dashboards, then Streamlit you can use. And ease of use, coming to ease of use, Flask is moderate and Streamlit is very easy. And high is not complex, it's like very simple. The customization means highly customizable, and moderately customizable Streamlit is. And that's the difference. And the best use cases, you can design not full-fledged, complex applications you can design, not full-fledged like Amazon and all, but a moderate kind of complex applications you can design, and the APIs also can be created. But Streamlit, very quick, few web pages you would like to design for your ML application and the dashboards, then you can go for Streamlit. Yeah. So maybe what are the prerequisites when you would like to do all these things is, so a little bit of Python programming and the data science models and HTTP basics. All these are required when you would like to, design. If you have this, then it will be easy. Even if you don't have also, you can do it, of course. But you will struggle a little, but otherwise, it will be advantageous if you have these, prerequisite knowledge. Python programming is required for coding Flask and Streamlit applications. You have to design the applications, right? That is where. And data science means you are going to deploy a machine learning model or the data science application. So that is where your data science knowledge is required. Maybe right from collection of the data, then your what you say, the data engineering task, pre-processing and all, then choosing the model, training the model. So for all that, your ML and data science expertise are required. And once you have that, then the HTTP basics like client server connections or creating your, the data transfer and all. So for that, HTTP, very basic knowledge is fine. So this is about designing. Now let me, maybe in another 5 minutes, I'll start the demo for Streamlit. let me give few details of Streamlit before we use it. Streamlit is very simple, straightforward, and you need not to have any of the existing knowledge. If you have, if you don't have any knowledge, a simple Python knowledge is sufficient. If you would like to design, 4-5 pages or few pages of interface for your model or the dashboard you would like to create with some charts, then Streamlit is the best option for you. Yeah, let me give few details about Streamlit. Yeah, of course, Streamlit is an open source framework for web interface design, and it's quick and easy to create interactive data-driven web applications. And it's developed by Adrian Trello and his friends and introduced in 2018, and ideal for data scientists and machine learning practitioners. And we already discussed, just to summarize. No front-end development required. Directly you can, float the web pages. Fast deployment and integration is possible. Then supports various UI elements. I'll show you what are the different UI elements that are supported. You can, include charts, you can include tables, you can include input forms like, form elements also, like buttons, radio buttons, choice boxes, menus, all that are possible. Yeah, here you can see how do you install Streamlit. Pip install Streamlit. This is how you need to install. So once you install Streamlit, then you can run Python script using, of course, you should have, Streamlit code. Once you have the Streamlit code, then you can run it using this is the way you can run it. So Streamlit run is a command. Streamlit is a command. Streamlit space run space your file name, and it should be a .py file. So in Streamlit, everything is a Python only. So a Python file. And here is an example. Say for example, I have sample.py. I can use it as Streamlit run space sample.py. This is how we can execute. Done. So now I would like to show some of the functions that are part of Streamlit so that you can use it when you are, developing the interface. So to display the content, say for example, I would like to write something onto the web page. Then I can use these elements like Streamlit. We have imported here, right? Yeah, you have installed. Once you install it, you have to import it. Import Streamlit as st. Once you do that, you can. If you would like to display some content, then you can call st.write. If you would like to design a table on your web page, then you can say st.table. Some static tables and some line chart. If we would like to design, then you can say st.line chart. That is how you can design display the content onto the web pages. And if you would like to, say for example, Ola, Uber, that kind of application I would like to design. And in that case, you have to show where your vehicle is in the map, right? So to launch the map kind of thing, then you have to use st.map. So then the map will be displayed. Then you can set up your page title and page icon for your, when the web page is launched, what is icon for your page and what is the title for your page, that can be mentioned here. And st.title. So this is for the title of your application. This is the title of your, the browser tab itself. Yeah. So if you would like to have some radio button, you can call st.radio. And if you would like to have select box, you can say st.select box. This is how you can have the drop down menu and all. And user inputs, if you would like to, extract the user input from the, I already have shown, right? Say, for example, this one here, you'll see, I am actually including something like this. It's a text input. So to get this kind of, to read the data from the user, then you can say st.text input, and you can even allow the user to enter the file by using st.file uploader and st.image to display an image. So these are different, functions that are useful for including in your web interface. And I am giving few more elements like form elements if you would like to design. So these are the elements, it's a description, and I'm giving an example also. Say for example, text input. You would like to design, I have shown the text input. So where the user is allowed to enter text, a single line of text, then you can say st.text input method. Here's an example. Let's do a text input of enter your name. This kind of text, if you would like to have, then you can call this. And st.number input means if the user is allowed to enter a number, then you can use this st.number input of enter your age. So this is the title that you will get, label you will get. Along with that, you will be provided with the entry box also. And minimum value is 1 and maximum value is 100. And here, if you observe, no, plus minus you are getting. So there you can mention what is the minimum, what is the maximum. I'll show you maybe using an application, then you can better understand what is the minimum value and the maximum value for that entry. That range also can be given by using these arguments. Then select box, a drop down menu. Say for example, male, female. This is a select box, like options can be selected from the menu and multiple choice options. Say for example, hobbies, reading, sports, running, something like that. Multiple options are allowed to choose. Similarly, options will be given, but only one option, that radio you can say, sd.radio. And sd.slider, if you would like to have the slider in that specific part of the window, then you can have slider. And file uploader, st.file underscore uploader, so you can say. And here you can say the label also. See, so for everything we can have a label, and then you can allow the user to do the controls. Then st.button, then st.button is to click on the button to handle the button events. You can, if you would like to handle later, you have to create the button. And similarly, st.write submitted, like the st.write is just to display the message, that's it. And st.date input means it allows you to pick a date, and time input to it allows you to pick a time. So that date picker, time picker also you will get date controls and all. So this is about different elements that are possible, and you can use any of them. Now let me show the demonstration of Streamlit. I'll show you where my files are so that you can understand. I hope it is visible to all of you, my screen. I've already shared my screen so that it will not be a problem for you to check. Yeah. So here in one folder, I have a Streamlit demo. Okay, I have prepared for this workshop. So Streamlit demo is the folder. And in this folder, I have like several PY files. I'll open them and show it. Here you can see these are all the VY files, and here already I have trained a model because deep learning model, no, it will take long time. That is why I haven't shown, and it will also require some understanding of the deep learning model building and all. So I didn't discuss about model training, but I have discussed, the model training of house prediction, house price prediction, and the heart disease, right? So those pickle files I have saved here in this folder itself. Okay, make sure that your Streamlit files, all are Python files only, are available in the same folder so that you can easily access them. And if you don't have them in another folder also, it's fine, but that will provide full path, that's it. Other than that, you can have it anywhere. And now house, this is house price, and here BGG16, this is like a model for chart classification that is in the task. We'll see. And how to provide various controls. I'll show each of them. So now we are in downloads, Streamlit demo, right? Now let me open using Visual Studio. Visual Studio provides good editing possibilities, so I prefer using. You can use any other, like simple Python also is okay. You can open. I'm opening that folder. Streamlit. Oh. And that is Streamlit demo. Okay, see. So I hope that is visible, or do you want me to increase the font? Is okay, fine. Otherwise, I will increase. I hope you are listening, and I did not get any questions so far. Okay, fine. Yeah, these are the files. Let me start. Let's start with simple write. So each file is separate only. There is no dependency. I'll show like how to create different elements. Then we'll see like how to, use the machine learning models. This is a simple write.py. So here I'm importing Streamlit as ST, then importing pandas also, so that I can display some file like here you can see st.title, st.write. So this is the title of the web page, and this is you're writing some message, and I am creating a data frame, and this will be displayed. I would like to display this also. So just similar to your HTML. There is no HTML code here. Let me show you how to run this. So where is it actually? It is cd Streamlit. So I am in that folder. There in this folder, so you can observe it's C users admin downloads Streamlit demo. In that folder, we have all these files. Okay, these are the files. And just Visual Studio, I'm just using for for editing purpose. That's it. Now let's run the Streamlit code. I have already installed. Okay, Streamlit is available. If you don't have any more systems, you can say pip install Streamlit. That's it. So now we would like to call which file we will run first, write.py. Streamlit space run space. You can select, just give a tab after typing few letters, write.py. Now see what happens. Automatically it will take you to the browser. It's open. You can see setting title for the web page. This is what I have given, some scrap, that's it, random text. So this is the title because you called it with the check your code st.title and st.write. So this is sample write, and next is showing a data frame. Some text I would like to display. You can see this interface, right? Web interface you are getting. And we'll show you how to design this kind of interface also later. So now this is the data frame. You can see once you load the data frame, so you can actually, can you observe here the output? So sorting is also possible. It's valid. You can see, right? Yeah. When you click on that column number, so automatically the data is like sorted. That facility is available. Please observe. So in between, if you get any doubt, please let me know. So this is how you can create simple interface. Just the title. We have displayed some text and table. Next, let's proceed and see how do you include a radio button. Yeah, I will discuss how to include the controls. Then later we will see how to include the, integrate the model as part of it. Yeah, here this is the file which allows you to create a radio button. So radio button, you are importing Streamlit as st, then st.radio. So this is a radio button. And here you can see this is the label for it. And I would like to ask, what is the genre, right? What is your favorite movie genre? Comedy or drama or documentary? And if genre is comedy, the user selects this, then we will be writing you selected so and so, right? That is what I have done. And also we are including one control, that is select box. So one is a radio button and the other one is the select box. And on selection of this, we will be, st.button of print. So we are including one more control, that is print. Just showing you how to include different controls in your web page using Streamlit. This time, the file name here is radio drop down run space radio drop down. It will automatically, take you to the browser. I didn't do anything. So it will automatically diverted to your, this was the earlier one. I'm closing that, you can close it. So now this is like here, you can see what's your favorite movie genre. It's asking radio buttons, the text, and you selected. So we selected comedy by default. So it's showing you selected, yeah, I'm changing it. See, you didn't select comedy. So that is how I want it. Whatever you want, you can do it according to your code. And how would you like to be contacted? Through email or home phone or mobile phone? So that's what I'm asking. So I've chosen mobile phone, and print, I'm printing. So you selected documentary, mobile phone. So documentary is the first option and mobile phone is the second option from the menu, right? Or how to like handle the button click event. I'm showing that, okay? Yeah, so this is how. So if st.button, then you can say this is. So this is how you can handle the button click events and all. I will show now what else. House price will come back. Yeah, line and chart and map. How do you handle that? Let me show. Chart data. I think we have this. Let me give it a try. Okay, chart data is like we are creating a chart here, so that will not be a problem. Yeah. Here you can see the chart data we are like creating data, and with that, that's we are creating a chart data. Let me run that now. Line. So yes. It's loading. Take a moment. Yeah, you can see. So this is the data, the map. You can see the map, right? And these are the points I just overlaid. If you would like to, you know, design Uber kind of, and you would like to place your car movement, if you'd like to track. So this kind of map designing you might need. So this is how you can do it. Okay. So this is how a map can be included and a line chart. I'll just show you the code. Here you can see a data frame we are creating, some random numbers with the columns as A, B, C. We have like random numbers we created. And then we are calling line chart. So directly you can do it. So it will automatically does it. You pass the data. You need not to pass a chart diagram and all. So st.line chart of chart data. So it will automatically create the line chart. So here you can see there are 3 columns. So it's creating for all 3 separate. Then one more. Yeah, so one more data frame we are creating. So with random numbers and latitude, longitude. So these column names are latitude and longitude. With these latitude and longitude values, I would like to create the map data. So this is a map data object I created, a data frame. And then I'm calling st.map. So with those longitude and latitude, the map will be displayed. So that's what happened here. You can observe. This is the map. Right? Then now we'll quickly jump on to file upload also I'll show quickly. Then we will go into the machine learning model deployment. Okay. Yes. File text upload.py. So here you can see we are going to create the control which allows the user to upload a file. Here you can observe, right? File upload demo. So now you can upload any file. I'm uploading. Wait a minute. Here you can see here requirements name error it's saying. Why is it saying? Because I have set the limit to 200 MB file and also .txt, .csv, .jpg and PNG, JPEG. Only these files I am allowing. So the format is not supporting. That is why it is showing an error. Otherwise, it will do it. Let me show you uploading the PyFile. PyFile is not allowed. JPEG is fine. There's some other card that is available in my system. See, it's displaying. So this is how you can, upload. Let me show the code also. So here we are just writing this message for the title of the web page, then upload file. You are calling the control st.file uploader, and the message you are giving is a label as a choose a file, and the types. What are the types that are allowed? That can be mentioned. Okay. And if upload file is not none, so when you don't upload, then so you display this message. So if uploaded file is Python file.type equal to text or plain, then you give this message. This is the type of error you can show. So this is how you can do. And text area also is that part of this web page. I didn't observe it actually. That's some here you can type. Text area also is included here. Let's see. Text area, enter some text. This is how you can do. This is about, various controls. It's enough, more than enough, I feel. Now let's go ahead and see the house price. We'll do the house pricing. I'll just show you, or otherwise first I'll give the demo, then we'll come back to the code, so that will be interesting. House price. I hope there are some people who are listening. Okay, ma'am. Now, can you see here? It's like the house price prediction example we have seen already, right? And here you can give some values. Some random values I'm giving. That's fine. Relation to average occupancy, latitude, longitude, it's already given. So after filling these values, can you see all the values? To fill all the values, so what are the different features that you need for your house prediction example? The house prediction sample is having all these values. So for every sample, like once you train your model, you saved your model and it's available in Pickle, right? Yeah. So once you have the model and then you would like to test, means you are giving to the customers, means they would like to, you can launch it actually as a website also. So now you can allow the user to enter all the values. Now they can click on predict. They're predicting, predicted median house value is minus $44. 44. Because it's very bad. The values I have given is also very bad. So that is how it is predicting. Can you see? This is what you can make it like more attractive and all colorful. You can do that. Now let me walk through the code. What we have done, we have loaded our machine learning model, and then we have put some controls like allowed the user to enter the data, and then we have run the model, like call the predict on the model so that we get some predictions. So import Streamlit as ST. So we are importing Streamlit and import pandas as PD. We are importing pandas also. Then we are importing Pickle because I have stored, if you remember, I have saved my house price prediction model as Pickle. So now this house price underscore model.pkl, we are opening that and we are passing it to the load method because I would like to load it. So I'm opening it in the read mode. So now to the model, you are calling pickle.load. So this will load the model. And the features, what are all the features you need to have? You just list out the features as a list. And every feature you just read from the value. So before that, if you observe, no, the interface is having the, like, this is the the title. So the title is st.title, whatever the title you would like to have. And you are going to get the user input for every feature. So user input, a dictionary you are formulating, and for every feature you are getting the detail. Okay, for features, for every feature. So for longitude, latitude, the default value we are putting. Otherwise, we are creating a text box and we are getting the value. And with that, our dictionary will be formulated. So you are adding that. Now, once you get the dictionary, you pass it to your data frame, and it will be converted to the data frame. And now using this input underscore df, you can pass it to the predict model. So now when the user, after entering, when the user clicks on this predict model, then only you should call the predict method, right? Yeah. So now if st.button of predict, if it is called, you are handling that button click event here. So prediction equal to model.predict of input df. So means you are calling the predict. You can see here, model you already loaded here. It's already trained. There, nowhere else you are training it. And now you are calling the predict method. So once you call the predict on your data, actually on which data sample you are calling the predict, on whatever the values the user entered, so you are using them and you are getting the prediction. Now, what is the result that you are displaying here? st.success link. You get this color, we call the st.success. And what is the data you would like to display? Predicted median house value is so and so, whatever is predicted, that value. This is how you can load the machine learning models and you can create the web interface. Now, if there are, I'll give a pause for a minute or so because Streamlit, we are done with that. And of course, you can take n number of examples. You can extend it to like any big demonstration and all, but in the interest of time, and look, we have only 2 hours session, right? So I've taken a couple of examples and I have shown. It's like it's all your creativity now. Before we proceed to Streamlit, I give a 5-minute break. It's a longer session already, 1.5 hours. So maybe you can practice or you can go through it and try to understand. We'll start the session now by 6:35. Yeah, let's go ahead with the next framework, that is Flask. So basically, when you are designing with Streamlit, you are designing from scratch, and it's not possible for. Hello, am I audible? Hello. Hello. So now let's see how to use Flask for designing the web interface for your machine learning applications. Flask is another framework which allows you to integrate your machine learning model interface with the existing web application. Say, for example, there is a hospital and they're already maintaining a website, and you would like to make your a specific application you have designed, model you have designed, and that related interface you would like to design. So that is where this Flask will be useful. So now let's see how to use Flask for it. So brief details about Flask here. So it's a lightweight web server gateway interface web application framework. So it's very lightweight compared to Django. And compared to Django, it's very simple also. And scalable compared to your Streamlit. So like moderately large applications you can create, web applications you can create, and it's developed by Armin Roracher. And based on the web server gateway interface and Zinja 2 template engine, it is based on, and more explicit and easier than Django framework and more simple, but it doesn't allow you to create as complex documents as Django allows. And the minimal code base for simple web applications. It provides minimal code base. With minimal code base only, you can create simple web applications. Maybe if you if you would like to design few web pages, and that can be made as part of your existing framework, then you can use it. And the prerequisites for this Flask, the web framework design is HTML. You need to have the knowledge of HTML and also Python and also CSS. So all these three different knowledge you need to have. So you should be familiar with the HTML for web structure and web form design. You are anyhow, you are making your model deployment as part of the web framework only, existing web framework. Then the the web interface design is with HTML, and style cascading design like style sheets and all. Styling can be designed with CSS, the cascading style sheets, and Python is for backend logic and server-side programming. I'll not be discussing about the backend logic and all, but I'll be showing you how to integrate, how to deploy your machine learning models. Yeah. So here, when you are designing the web application using Flask, so these are the steps that can be followed. You design your HTML form. This is the first step. You design your HTML form for taking the user input. So once you have the HTML form, this is the actual interface with the user, for the end user. Then you design your Python file, typically app.py or some other .py file, a Python file. And this should have the Flask framework for backend logic. So the backend logic should be part of your Flask framework, and you can even load either backend logic or otherwise the model, because it's a machine learning model deployment. What we do is we include the pre-trained models using pickle module we have saved, and we load it, which is already saved, and those models or Keras models which are already saved, we can load them. So that should be done here as part of this Python file. Once this is done, both files are available. Like I have the HTML forms designed and I have the app.py. This is a Python file with all the logic that is required to handle the backend or to handle the model loading and all. So now we should design as a directory. We should follow some specific directory structure where all the HTML files should be part of the templates directory. I'll show you so like in the demo also how it should be. So your files should be part of the templates directory. So now let me give the walkthrough of few of the commands that are helpful while designing the Flask-based interface. So creating a Flask app instance, you have to create the instance of the Flask application. Like Flask, you must import, like install Flask, then you import Flask, then you create the object of Flask. So Flask of __name__. So now app object is created, and defining functions, you can define these functions. Basically, when you click on button, when you are in the home, what should be done? Or when you click on a button, to which web page it should be redirected. So that redirected functions need to be mentioned here. And you need to mention the routes also here. So def home, this is the function that will be executed. So as part of the home page. Okay, and def predict, this is like the normal function, and you can design your own function names also. So it had for handling the form data submission and prediction. I just have shown related to my code. You can have any number of functions, but home is a function which will be, this function should have the route to the web page or the HTML file, which contains the home page details. So that is how you need to ensure. And defining the routes can be done with the help of app.root. And the slash indicates you are redirecting to the home page or directly to the home function. And this home function will have the code, the related to the index.html and all. And app.root of slash predict means when this predict method is called, then what is the data that should be forwarded? That is what method is equal to post, and it handles the post request for predictions. So when your method is post, then you call the predict. So that is how this routes you are defining. You are defining functions and you are defining the routes also. And there are some functions which are helpful for rendering your HTML documents and all. So as part of your functions home, predict and all, you can call render template of index.html. So when you are in the home page, you need to render index.html, and similarly some other form. And you would like to retrieve the form data into an object. You can say that request.form of, so the element name. So form element name you have to. So then it will be converted. It will be taken similar to your JavaScript. So it will be converted to int. Sorry. Yeah. Yes. So now it will be converted to integer, the typecasting, and then you are storing in the object age. Now to run the application, you can say, you can use the command python space app.py. So the once you run the command, it will not directly redirect you to the browser. You have to copy paste this URL. So then only it will show you the the modal interface. So that is how you need to design. So now let's see. Yeah, why to use Flask? Some justification, because it's simple compared to a Django and all, and small to medium sized projects is most preferable. And you can integrate with existing libraries and existing HTML web pages and all, and web-based ML model deployment you can use, or interactive dashboards and forms if you would like to create. These are the use cases for the Flask. And coming to the Flask demonstration, let me show the files where they're available. I've created a Flask demo folder. Yeah, here you can see. So please observe, this is the Flask demo. This is the folder. And under this folder, we have templates. So this templates will have all the index HTML files, the HTML form designing. The form designing is like normal HTML code only. So the normal HTML file, then we have .py, and this is the pickle file we already stored. Okay, and how do we, this is a Python file. This contains the all loading of the file, or if you have any backend support, if you require, all that can be part of your app.py. So now let's go ahead and see. This is not required. Let me show the codes. Just open the folder and see. I'll just show the codes. We're just, displaying the codes. Here you can see Flask demo is a folder, and as part of that we have templates. Template is one folder which contains these HTML files and app.py. So please make sure that your app.py and templates are in the same under same directory. And this is the pickle file. This is like the model that you saved after training your model in the Jupyter notebook and all. Yeah. So now open your app.py. I'll just show you, or otherwise let's start with index.html. You can observe here, this is the entirely a HTML document only, nothing else. The top type is HTML and HTML head tag, body tag, then under head you have the title. So what is the title of the web page? Then on the body tag you have the header one, you have the form tags, the form elements you can see. All these things, it can be part of your, the .html file. So index.html. So form method equal to post, action equal to /predict. So when the method is post, what is the action that should be taken? That you are mentioning here itself. You see, so action is /predict. So your root that should be taken is a predict. And what are all the elements that are part of this form? The age, what is the type of it, and what like age I would like to get, and the number, and name is age. And similarly, the name means when you call, you can like extract the value from the form element. For that, we are giving the name. And similarly, the gender, and then we have the chest pain values. All the remaining values are also we are giving. You can observe. So now all the entries we have given. Once that is done, at the end, I am including the submit button. So then for the submit button, we are giving the name as predict. Okay, the type is submit, but the name we are giving is the predict. So when you call this predict, then the action is /predict. So now this is part of your index.html. Okay, I have result.html also. What is result.html? It does is, it says it is another page, another web page, which is having the title as prediction result, as having the body as prediction result and the actual prediction value. And the prediction value is passed through your actual app.py. Now I'll show you the app.py. How is it designed? App.py. So you can observe here, we are importing pandas, then we are importing Flask and render template from Flask and request also from Flask. So these three methods and classes are imported from Flask, and import in pickle also, because you need to load the file which is already stored, the pickle file. And we are creating an instance. Here, please observe, a Flask instance is created. So we already imported Flask class, and Flask object is created. Underscore underscore name underscore underscore. Now app is created. Now you are opening your file, the pickle file in read mode, and you are calling pickle.load of f. Now your model is loaded into the model object. Now the model object is ready. Then app.root / means this is a home page. App.root / right? And that means whenever you are in the home page, initially, what is the page that should be displayed that you are going to define? And what is the method that you would like to, when you launch the home page, then this function should be executed. And this function contains all the details about the index.html should be rendered. What should happen? Already I have shown you, right? Index.html contains a form with the heading and all. So that should be rendered. So you're rendering the HTML file. That's what you are doing when you are on the home page. Now, when you click on the button, then there's a /predict method, right? It's in index I have shown already. When the method is post, that is when the button is clicked, the post method will be triggered. Then the action, sorry, the action should be taken as a predict method. So now that is the root. Now /predict. So when it is /predict, then the method is post, and you can see the predict method should be called. And here you can observe, if request.method equal to post, of course, there we have mentioned the method as post, then you get all the values from the form. And then you prepare this kind of list and you pass it to your predict method of the model.predict, and it will say that what is the prediction for this. Whether it's a heart disease or not, it will be predicting. And if the prediction is 1, it's having the heart disease detected. Otherwise, no heart disease detected. And the result should be displayed. And we are storing that in the result. And result should be displayed where you are returning render template. You are rendering another HTML file. Please observe. your form is in one page and the result you are passing, and when the form elements are uploaded and the model predict is called with those values, and when you click on the button, the values will be extracted and stored in a list, and then with that the predict method is called, and the prediction value will be displayed in the next page, and that is the result.html. And what this result.html, we are passing the prediction value also. Here you can observe the result.html. The prediction value you are passing, and that will be displayed here. Similar to your JavaScript and all, how you pass, like how do you handle your get post methods, the same way, no difference at all. Now this, let me show this. How do you exit it and all? Just let me. Yeah, just change your directory to class demo folder. This is the class demo folder. Now I would like to run Python file only. It's just the Python command you need to use. Python space, what is that? App.py. Simply run this. Now please observe, when you run this command, you will not be redirected to browser. But when Streamlit, when you run that Streamlit, run your file name .py, it will be automatically redirected to the browser. Now what you need to do here is you just copy paste this. Here is the URL. When you run this, on running it, you will be getting that here. You just paste it in one of the browser. Paste it in the browser. You can see this. Right? So the age, you just enter the age value, then the gender value and chest pain, and the blood pressure, then the cholesterol, fasting blood sugar, ECG, maximum heart rate. Then we have exercise-induced angina, something like that. Exercise. Some value, you just enter meaningful values in real time. Then you can see we are redirected to other page and we got no heart disease detected, right? Yeah, so this is some. Now I will just show you that it's not very colorful and all. I have designed one more page. I don't know whether it comes or not. It's CSS and all. You can observe style sheets and all. I would like to change this to this one. Yes. Now I'm just going back. What is it? This one. We didn't save it, right? Just save the files. So app.py. Here we need to change. So rather than rendering index.html, I have included, all this cascading, because if I show the cascading and all, it will be tedious for you to understand. So I wanted to make it very simple. That's how I designed it that way. So now index1.html, that's saving. You can see, just refresh your page so that you will get some problems then. Yeah, I have this kind of, colorful design, you can do it. Give me 1 minute. Just I will just quickly change the code and show you. Now maybe we are almost close to it. I have shown everything. Now I just would like to show one more colorful page. That's it. If you have any doubts, maybe you can ask. The last 5 minutes we have. Yes. See, yeah. So here you can observe like rather than having the simple interface, we have made it a little colorful as a table, as part of the table also. The age, now you can give the details, and the result page also you can make it as like aesthetic as possible. That's all up to your creativity and all. Yeah, that's all from my side. Now I have shown you the demonstration of model deployment using Streamlit and also using Flask. So if there are any questions, maybe last 2 minutes we'll spend for question answers.
Ma'am, would you like to add something else to the session, ma'am?
No, I just wanted the last 2 minutes for question and answers. No, there was no response. So
Yeah, ma'am.
if there are no further questions, then maybe we can wind up.
Shall we wait for some time more, ma'am?
That's fine. No response at all so far. I have given a break for 5 minutes at 6:30. That time also I asked for question and answers, and then now for 3 minutes. Maybe you can text me if you have any questions in chat box. You can.
Yes, ma'am. We'll just wait for 2 more minutes and we'll see. And all the participants who have any kind of doubts, you can either unmute yourself or else you can just keep in the chat section. Or else we'll just wind up the session if there's nothing.
Yes, perfect. Okay, then. Fine. Yeah, thank you guys for giving me the opportunity, or the organizers, and I thank Dr. Maithili Madam for giving me the opportunity. Yesterday, we incidentally met in a workshop also. Thank you, Madam, and I thank other organizers for giving this opportunity, and I thank the participants for their patience listening. Thank you. I hope this is useful. This session is useful. Thank you. Please practice it. The recording will be available even if you could not, be throughout the session. It's very much useful, the morning session and this session. Thank you all.
Thank you so much, ma'am, for joining us today for both the sessions. Both the sessions were really amazing and also informative. And to all the participants, in the chat box, we have the feedback form. Please fill up the feedback form before you leave, or furtherly, it will be updated in the WhatsApp group too. Thank you so much for joining today.